Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. And really, it is, because guys, with this video, either I love you all very much, or I hate myself very much, or some combination, some blend in between, some combination of both. Because folks, what I'm going to do here, I'm doing, this is the tail end for me when I'm making this video, at the very least, the full version of this, of a semester for all my classes. And so for my integrated math 1 folks, we've done a lot of quizzes, 15 or so quizzes and a midterm during this semester, and normally I'd have to go over the answers with them in class, but I figured I should make a video with all of them, and I'm going to do that right now. So what I'm going to do here, and I'll show you how it works. I'm going to show you the whole layout, because eventually this video probably won't stay public forever, and what I'm going to do is splice it up in a bunch of different videos, which will privatize themselves along the way. So that way, when I'm doing other quizzes with my students in the future, maybe I can go reveal them at some point for them, later, so they can use that as a key instead of me going over it in class. But the way that this thing worked was this, and I have a blinking light on my graphing calculator. It's just, whoops, it's just doing this over and over, and I gotta get it out of the way. Which I'm going to use that time to time. So here's what we would do, and your classes may have done this. They may be doing this as well. We're in what's called a skills-based environment for my integrated math 1 class, and so basically every single week they learn a new skill. At the end of that week, they get quizzed, and they get quizzed on that most recent skill as well as any other skills before it, or at least they can choose to get quizzed on. They can choose those skills before it, up to 5 skills to get quizzed on. So after 1 week, this wasn't perfect. In fact, after week 2, it actually falls apart. But after, let's say, a week, they learn a skill, and then the next week they learn another skill, and the next week another skill, another skill, another skill. Every week after that, let's say 8 weeks in, they've learned 8 skills. Well, on that quiz, they will quiz on skill number 8 with 2 questions on skill number 8, and then they can choose 4 other skills to complete 5, 8, and then 4 others is 5. They can choose 4 other skills to quiz on among 1 through 7, and 2 questions per skill with that. And they're all different questions within, and so we go over this, and that's every single week. Well, now I have all those quizzes here. So what happens is you get 2 questions in the first week, 4 in the next. Actually, I think 6, because skills 2 and 3 were both in the same week, etc. And you keep building onto those. That's a lot of questions over time. And there was a midterm after one of the weeks as well for the first 10 skills, and I have that in here as well. So folks, I believe when I did the math, there are 256 questions in here. And that doesn't even count the next quiz I'm going to be giving them this week, and then their final, which this is all reviewing for, which will have 45 new questions on it. If I did all of those together, there'd be over 300 questions on this thing. I'm not going to martyr myself for the sake of a YouTube video that won't always stay up here forever, but apparently I'm going to do an F here. And actually, I started this video, I got really short into it, but I started this video a few days ago, and then boom, power outage. There's a big storm here. So, and I actually didn't have enough time to just go back and redo it, or I was too frustrated or whatever. So I'm doing it again now. But like I said, this introduction is probably not going to live on here very long, because this won't stay public for very long for my students. Overall, in the long run, it'll be privatized and unlisted and things like that. But I'll splice this up into each individual quiz. So let me lay out what this is going to look like for you and give you the example. This won't be perfect, because I'm going to have to blank out a lot of them. These had to fit on pages for them to look at, and they wouldn't generally write on these. They would write on a different answer sheet. So every so often I'm going to have to pull graph axes into here. Every so often I'm going to have to blank out some other problems just to fit and do some room. But I promise you, for 256 questions, guys, even for 1 minute a question, that'd be 4 hours and 16 minutes, not even including this intro. I do not plan on going for 4 hours. It's already 7:30 p.m. I'm not going till midnight on this thing. So after I've taught a skill the first time, if it's not a brand new kind of question, unless I'm finding different ways to do that problem, I'm not speaking too long on it. I'm doing a problem, whip fast, even if it's in the slice portion video, those students will have assumed to have seen that kind of content before. So here are the 15 skills, and it's important, I always get a nose itch whenever I start talking for whatever reason, or at least I'm consciously aware of the fact I have to scratch my nose here. But here are the 15 skills listed right here. This is all kind of Algebra 1 based material, and I suppose if I do this next semester, the same kind of thing, you're going to see 15 new skills where some are exponential function based, but the rest are really geometry. So you're going to see a lot more geometry in the second semester of integrated math 1. But here they are. I'll kind of say what they are when I introduce them for the first time. They won't have these titles except for in the midterm. Otherwise, you're going to see it just say skill number 1, and that'll be within the first thing in that first week. And I guess this will have its own video. Or maybe not. I don't think I need to splice it for a single video unless I slow down and talk about this one a lot, which I don't intend to for a long time. But then you see week 2, and there were 2 skills introduced then, and then week 3 we'll have these ones here, and you can see where new questions are built. Sometimes they're harder, sometimes they're easier. But here are the skills. I'll try and explain what they are as we do them. At least you can take a look at them. Hopefully, by the time, not by the time I upload it, but hopefully within this time frame that I need to do these, in the description section, I will provide you with timestamps for each week that you can find something in. I will provide you a PDF of all of these questions here, for which you'll probably need your own paper to do the work on, and your own graph paper to draw the graphs on, okay? So a PDF for all these things as well. I'll attach this one. Yeah, and timestamps for all these things as well. So you can find the perfect breakdown of what you want. Because listen, if you're focused, here are 2 of the problems, and then I promise I'm going to start. If you're focusing on a single skill, like skill number 10, I'm not going to do all skill number 10 questions together. I didn't rearrange these again, so all skill number 10 questions are together. The first time you see skill number 10, you'll see 2 questions. Then I'm going to go back and do another set of skill numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then hit 11. And then I'm going to do it again and hit all of them through 11, and then 12, right? So it just keeps cycling back through, which is kind of an interesting way to watch this. But then I'll try and rearrange timestamps that way so you can see everything from skill number 10 under one block. That'd be nice. Here's the only other problem about this, guys. There are only 2 questions you're ever going to see on skill number 15. Because we've only had 1 quiz on it, so only 2 questions there, and they don't cover everything that I want to do with them. Maybe I'll talk a little bit about that at the end, but you only see 2 questions on skill number 15, whereas you'll probably see 30 questions on skill number 1. So it's not a perfect science when we do this stuff. They have a couple more quizzes where they can see skill 15 stuff, but not by the time of this video. All right, without further ado, grab this paper and a PDF and graph paper and a calculator and a pencil, or sit back, watch, and let me do the rest of the work here. Let's see how long this thing goes. Okay. Week 1, skill number 1, which is simplifying expressions. Not solving equations, but simplifying expressions. We're not trying to figure out what x is and what b is. We're trying to break this down and make it smaller. Or it's not always smaller. I imagine it generally is, but it's not always necessarily smaller. The idea of simplifying is no parentheses, combine like terms. That's basically the general thing for us. So we have 10 minus 7b plus 10b plus 2 minus b. Now, first of all, what we're doing as far as combining like terms is we want to find any terms that share, say, the same variable, like these ones right here, and then like these constants right here, we can find as well. Like, what is 10 plus 2? Well, that's 12. What's 10 minus 7b? Is that 3? No. Is that 3b? No. They do not combine together. B, if it was a number, would multiply by 7 first before you would subtract it from 10. So you can't guarantee that it's going to be equivalent to 3 or 3 times that number, unless b was 1. So you can't guarantee any of that. So we just simplify it as much as possible. You take negative 7 times b plus 10 times b, though. That is equivalent to 3 times b. That is equivalent to 3b. Minus b, b is implied as 1b right there. So really what we're doing here is negative 7b plus 10b minus 1b, which is negative 7 plus 10, which is 3, minus 1, which is 2. That amounts to 2b, 2 times b. Basically, there were 7 b's subtracted here, and then 10 b's that were added. That's 3 b's total. And then another b was taken away, 2 b's left. Great. And then 10 plus 2, as I said, is 12, and that's a positive 12 right there. And that is the simplification of this. No, I'm not doing, and I'll probably mention it on the next couple week things when I talk about it, I'm not going to divide both sides by 2 and find out b equals 6. That's not what this is. We're not solving. We're just simplifying what that is. And number 2 is the same kind of stuff. Simplify right here. 9 times the quantity x plus 4. X and 4 cannot combine. They are 2 separate, unlike terms there. We keep them separate. And 2 times 2x plus 1 right here, simplify. Well, here's the thing. Even though they can't combine, we can still multiply them separately by 9 and add those results together. See, order of operations would say if x was like 6, I could do 6 plus 4 first, make it 10, and then do 9 times 10. But I could also do 9 times 6 plus 9 times 4, and that would give me the same result as 9 times 10. Case in point, 54 plus 36 is 90. So what we can do is write a simplified version of this by doing what's called the distributive property. Distributing 9 into the x to get 9x. Distributing 9 into the 4 to get 36. and they still don't combine. But now I've gotten them out of parentheses, and even though they're bigger numbers, you're like, Mr. Robinson, I thought you were trying to make them smaller. Well, maybe we have less terms overall, but really what this allows me to do is combine like terms with other things. These couldn't combine with these terms until they multiply by the 2 and the 9. That's order of operations. 2 times 2x is 4x, 2 times 1 is 2, and now I'm in a good set where I can combine like terms. 9x plus 4x is 13x, 36 plus 2 is 38, and I've made it smaller. Less terms overall, I've simplified it. And that's why we don't want parentheses, because they're probably being, not disguised, they're probably being, I don't know, covered, concealed by what else they can do with other terms until they're multiplied out. And that is an example of skill number 1 stuff for week 1. Okay, this week 2 right here, we are going to begin once again with skill number 1, and we'll hit skill numbers 2 and 3 as well, which fall under the same realm. Skill number 2 has to do with solving equations, solving for x, solving for y. Skill number 3 also has to do with solving for variables, but significantly less numbers are thrown into the picture here, and you'll see what I mean with those. They're called literal equations. But before we do that, let's go to skill number 1 all over again. Now, skill number 1 has combining like terms, so we're trying to find ones that share same variables, and we can add them together. For example, 3x plus 1x is 4x right here. And we have to do negative 5 plus 6, which actually ends up being 1. And that's your result. Now, the thing you have to be careful of with something like this is, notice how I said 3x plus 1x. I didn't say 3x minus 1x. See, the 1x is positive. I could have rearranged these terms as 3x plus x together, like that, and negative 5 plus 6 together. It's all about the sign that's in front of your terms, though. Notice how the 5 is negative, it stays negative. The x is positive and stays right there. So you can combine like terms and kind of do that. Now, right here, we're going to distribute the negative 2 into here before we combine negative 3x with something if we can, and that's a part of the simplification process anyway. Notice I did say negative 2. It's not just negative 3x minus, and then do 2 times this and 2 times that. Negative 2 is multiplying by both of these. Negative 2 times x is negative 2x. That's just how that thing works. That's what negative 2x means, negative 2 times x. And negative 2 times 1, which is a negative 2 right there. So yes, you distributed negative 2. Do not do plus 2 with that. That minus is a part of it. And negative 3x minus 2x is negative 5x. And we have minus 2 right there. And there's some skill number 1, simplifying expressions. Skill number 2. Solve 3x plus 16 equals 8x plus 1. This is possibly one of those instances where, I'm going to have to use the room on the side as much as possible or draw blanks and erase work later. Our goal is to get x by itself. This time I want to figure out what value of x can I substitute in the left and right to make the left side equal the right side. And I'm not going to guess things like, let's try 10. Let's try 20. Let's try things until it works. No, we're going to figure it out algebraically, or so what it's called. This says 3 times a number plus 16 equals 8 times some number plus 1. And we want to figure out what that x is right there. Now, there's certain rules to this, or certain algebraic means going about this right here, and I'm going to show you some of them right now. It's all about, isolating x, getting x by itself on one side of the equation, and it's all about this balance thing. Whatever I do, see, if two things are equal to each other, we have to keep them equal no matter what we do, but we can do whatever we want mathematically as long as they stay equal, and as long as it gives us a chance of solving for x. Such as if you're like, I have no idea, like some sort of handicap thing, like to keep things comparison like on an even keel. Like, you put one arm behind your back for this thing, I have to put one arm behind my back. Like that kind of thing. You lost $5 in the shelf, I'll throw out $5 myself. Whatever it is, like that, keeping it equal. So the whole idea here is I want to get x by itself here. Now, you've seen me combine like terms in these previous problems. I can't combine anything on the left expression here in this equation, and this equal sign is a great barrier which divides what happens on the left with what happens on the right. No, I don't combine 3x with 8x, at least not right now, because they aren't on the same side of the equation. They are separate expressions, and 8x plus 1 can't combine, but they are simplified. So now I can start isolating my x variable. I'd like to get x on one side of the equation only. With other coefficients, that's fine. So, what if I did this? What if I made this side 3x less than it is right now? If I subtracted 3x right here, you know what 3x minus 3x is? Same thing as anything minus itself. It's 0. A better way of writing 0 plus 16 is just 16. What we tend to say in these instances is we tend to say this cancels out. Basically a way of saying that I don't need what's written there because it's equivalent to whatever else I already have there. But 3x minus 3x is 0. Now I just made this side 3x smaller. Is that allowed? Sort of. I have to also make the other side 3x smaller. If I subtract 3x here, I have to subtract 3x here. 8x minus 3x is 5x, like that. So now I have an equation that says 16 equals 5x plus 1. Now what did I accomplish? I just got my x terms on one side of the equation. When it comes to solving for x and making this say x equals this, I've at least gotten my x's on one side. 5 of them, but I've gotten them on one side, so it doesn't say x equals, excuse me, something else with x in it. That's one step down. Let's continue forward. Let's subtract 1 from this side, both sides of the equation. If I want x's by themselves, I need to drink water probably. If I need to get x's by themselves, let's get this 1 out of the way. I want to know what x equals. Well, first, let's find out what 5x equals. 5 times some number plus 1 is 16. If I take 1 away from 16, then I'll figure out what 5 times that number is. 1 minus 1 is 0. 5x plus 0 is 5x. 16 minus 1 is 15. 5 times some number is 15. Everybody, what is that number? Awesome. How did you get 3? Because 5 times 3, I want to hear a different way. How did you get 3? Not how can you use 3 to show that it works. If some number times 5 is 15, then 15 divided by 5 gives us that number. If you notice, we were adding 1 here, so let's subtract 1 to figure out what that result was. Now we're multiplying by 5 here. Remember, that's what 5x means, x times 5. So let's divide by 5 and figure out what that value is. And whatever I do on one side, I do on the other side. So x equals 3, or 3 equals x the way that it's written. You'll tend to see me write it the other way here. And there is the solution. That is x equals 3 right there for the first guy right here. Okay, that's exactly what we're trying to do. Now, that was one way of doing it, meaning if you notice I subtracted 3x from both sides. Mr. Robinson, could have you subtracted 8x from both sides and moved the x's to the left side of the equation and the constants to the right side? Absolutely. Yes, you could have. What you're going to tend to see me do, and it's a strategy which generally tends to pay off more than not, is I try to keep my x terms positive. If I subtracted 8x from both sides of this equation here, I would have had a negative 5x. There's nothing inherently wrong with that other than you might be inducing more negatives than you need. And you'd have to remember to divide both sides by negatives to solve for x and actually divide that negative, which means it would switch your sign. So there are a couple more things involved with that, which, I don't know if I recommend. Okay, number 2, solve 2y minus 1 plus 4 equals y plus 2. Once again, there are y's on both sides of the equation. Right? Oh, by the way, on number 1, I'm just going to double check this visually, like mentally here. I'm not going to do this normally. Does x equals 3 work? 3 times 3 is 9, plus 16 is 25. 8 times 3 is 24, plus 1 is 25. 25 does equal 25. That checks out. And that's the only x value that actually works here. Okay, number 2. 2 times the quantity y minus 1 plus 4 equals y plus 2. Now, there are y's on both sides of the equation, and I'd love to do the same thing as last time, which is move all my y's to one single side of this equation. Last time I did it with x's, though, as I mentioned, both sides were already simplified. They were already fully, like terms were combined. Think about scale number 1. If I just only saw this expression right here, and I asked you to simplify, could we simplify something? Yeah, we could distribute 2 into here and get 2y minus 2 plus 4 equals y plus 2. And negative 2 plus 4 is 2. So I'd have an equation that now says 2y plus 2 equals y plus 2. Well, how does that help me? It just does. Everything's simplified. All that's left is moving terms over. And they're single terms only. I can tell which sides I'd like to move y's over to and my numbers over to. It's just a single one for each of them. Simplifying first before moving terms over is almost always generally a recommended tactic unless there's a division or busting a fraction or something that's involved for these kinds of equations. But as far as this thing goes, yes, absolutely. Distribute that thing first before you start subtracting 4 over here and all that kind of stuff. Now we get to subtract a smaller number in 2, assuming I want to subtract this y over to this side. And I know I don't really have much room here, so I'm going to give it a shot and just move this up and say, let's move the y's to one side of the equation. Remember, this says 1y plus 2. So if I subtract y from both sides like this, 2y minus 1y is indeed just 1y. And just like you saw a y before, I can just write y after, 1y, 2y minus 1y is 1y, and just write y. Because we're not solving for y, we're going to figure out what y equals, but it's really what does 1y equal? So if I'm going to subtract y's to the left side of the equation, let's go ahead and subtract the 2's to the right side of the equation. Minus 2 minus 2. Now an interesting thing's going to happen. I'm going to cancel these 2's out because I know 2 minus 2 is 0 and y plus 0 is y. But I don't have anything on this side of the equation anymore because y minus y is 0 and 2 minus 2 is 0. Should I cancel these 2's out? Well, the idea of canceling is saying that I'm not going to express it visually as anything. But 2 minus 2 is also 0. So that's what I'm going to put. And y equals 0. An interesting answer. Some of my students will sometimes say, what do I do in this stage? Hey guys, 0 is a number just like 3 is. Make no mistake, 0 is the solution. What is 2 times 0 minus 1 plus 4? Does it equal 0 plus 2? 2 times 0 minus 1 is negative 1. 2 times negative 2 is negative 2. Or 2 times negative 1 is negative 2. Plus 4 is 2. 0 plus 2 is 2. 2 equals 2. It checks out. Y equals 0 is your answer. And that's what you get. What's funny is they're more likely to get this question right the first time they see it until they learn other problems which have no solution in it. And those are the 2 answers that we have there. I'm going to move on. Now, when I do those in future problems, you ever see me do them in future problems there, I'm going to speed up a lot more. These are first times you're hearing these. Skill number 3, solve y equals mx plus b for b. What that means is, you could tell in these previous problems, solve. I didn't say what variable to solve for. There was only one variable, solve for x. Here, just solve for y. Here you see 4 different variables, y, m, x, and b. What the heck does that mean to solve for b? It means get b by itself. I want an equation that says b equals. So I'm going to rewrite this one more time. Now, solving for b, making this say b equals eventually, means I have to do opposite of whatever is affecting this equation in the moment. Right now, mx is adding with b. And mx does mean m times x. Do I care? Not really. I just care that they are grouped together. Think of mx as 3 times 5. It's 15. Okay, but I'm writing it as 3 times 5. I'm just going to move them together wherever they go, especially because they don't have a b in it. So what you saw in previous equations was, mx, it's positive mx, right? It's 1 mx. It's positive 1 mx. And it's adding with b. If I want to move it to the other side of the equation, because that's what we're doing, right? Getting b by itself. B plus mx is y, so how do I find out what b is? Let's make it mx smaller. Let's subtract mx from both sides of this equation right here. And you'll end up getting b equals y minus mx. And I know this sounds weird for you to look at. This sounds really weird for you to look at. By the way, future problems, you're going to see y equals mx plus b as an actual slope-intercept form equation if you haven't seen it before, so it's very reasonable to make sense of what it is now. But that's your answer. Why doesn't it say b equals 7 or b equals negative 4? Because we don't know what y and m and x are. But we found a way of getting b by itself using literal equations. And I imagine they're called literal equations because they literally show what it is that you're doing in the problem and how they literally pan out. You want to find out what b is, take y and subtract m times x from it. Instead of saying b is 4, right? We're doing a little bit more as far as that expression goes. Now, I tend to find these problems relatively easy when it comes to that idea. Whatever they're doing with your variable, do the exact opposite of it. My students, on the other hand, sometimes run into issues with these just because they don't clean up as single numbers and because sometimes you can express it as more than one kind of answer. Case in point, number 2. Solve 2a plus 5b equals 20 for a, which means getting a by itself here on this equation. So imagine this problem is kind of like some of the problems you saw above. To get a by itself, I want to first get the a term by itself where it says 2a. There's a 5b that's being added with it. So I'd very much love to subtract 5b from both sides of the equation. 5b. Now we've already learned that if they're not like terms, then they cannot combine. 20 minus 5b is not 15 or 15b. It's just 20 minus 5b. I can't write it any other way, except in a different order, but I can't simplify it. It's just going to stay as 20 minus 5b. You might see negative 5b plus 20 from me later when I do something like that. Now to solve for a, 2a means 2 times a. If I'm doubling a to get 20 minus 5b, then let's divide everything by 2 and figure out what happens. And when I say divide everything by 2, I mean divide everything by 2. Either a single term's 20 divided by 2, negative 5b divided by 2, or leave it just like this, where it says 20 minus 5b all divided by 2. Now, alternative answers can very much vary, and you are going to see me provide alternative answers to other problems of the like in future problems, specifically when we do some slope-intercept form things like this. I like my terms separate. But right here, this is a very valid answer. Otherwise, you could have 10 minus 5b over 2, but the point is they are both being divided by 2. Everything is being divided by 2 right there. That's how multiplication and division kind of work in that realm. Okay, and that is the end of the week number 2 questions. And I know that kind of went well, but that's okay. All right, week 3. Now, on week 3 right here, we are going to do skill numbers 1, 2, and 3, just like week number 2, and skill number 4 will be added. Skill number 4 is translating words into expressions and equations, and sometimes inequalities and such. We're not going to solve them. There's nothing to be solved for unless I'm asking you to interpret something or say what something represents. Other than that, we're going to be writing our own things from them. All right, skill number 1 here is simplify expressions, which is combining like terms. If I distribute the 4 into these two terms, I'll get... Actually, you know, before I mention that, I do not want to do 10 plus 4 first, because order of operations says we multiply before we add. 10 plus 4 may be 14, but 4 is already multiplying with something. I have to do 4 times this thing first before I do 10 plus what that is. So 10 is still here, but now I have 4 times 2x. 4 times 2 is 8, times x is 8x. And 4 times negative 1 is negative 4. So I've distributed, things are out of parentheses. Now I can do 10 minus 4, which is 6. You may either write 6 plus 8x. You'll tend to see me write something like this, 8x plus 6. X termed first just because it's also something called standard form. Get used to it. It happens. All right, number 2 right here, I see x terms and y terms for the first time outside of perhaps literal equations where you see different variables, but what you may have learned in a skill number 3 set of problems is that unlike terms cannot combine, x's do not combine with y's. They represent different values. Even though we don't know what they are, they represent different values. So 6x minus 9y plus 4 plus 11x minus y minus 2 means we got to combine x terms together. We got to combine y terms together. And we got to combine constants together like this. And I worked very hard. I very much intentionally tried to express that the sign in front of the term is the one that applies with it. So maybe just one time with this problem here, I'm going to show the terms next to each other, 6x plus 11x, and then minus 9y minus, maybe you put 1y here, because that is y, plus 4 minus 2. It's just kind of this way of showing them next to each other and just getting that instance of, okay, that's where they go. 6x plus 11x is 17x. Negative 9y minus 1y is negative 10y. And 4 minus 2 is 2, positive 2, like that. And that is your answer. Y's don't combine with x's or with constants or anything like that. Okay, skill number 2, solve x over 2 minus 1 equals 9. Now, if this problem said, let's say this, if this problem said 2x minus 1 equals 9, let's imagine what we would have done from a problem like this, because we haven't seen a fraction like one before, and I hesitate to actually call this a fraction. It is, but it's division. That's kind of how I think about it more. Anyway, in this kind of problem, we'd say get the x term by itself first. So I would be adding 1 to both sides of this equation, keep it equal. Negative 1 plus 1 is 0, but you're left with 2x right there. 9 plus 1 is 10. Can we do the same kind of thing over here? Sure. X over 2 is just a term. X is being divided by 2 instead of multiplied by 2. Because that's the first thing I just want to clear up there. Just don't let it bother you that it's there. We're still going to add 1 to both sides of this thing. That's not going to change. Negative 1 plus 1 is still 0. We just have x divided by 2 instead of x times 2. And 9 plus 1 is still 10. And then in this problem here, because x is being multiplied by 2, some number times 2 is 10, we would do 10 divided by 2 to figure out what that is. Now, and this is not the problem, but I'm giving you an instance of what we're going to do here. This is different. I'll erase this in a second. But now, because some number divided by 2 is 10, I would multiply by 2 to figure out what that is. And make no mistake, this 2 is dividing by that 2 right there. I'm giving the expression that this looks like 2x over 2, just like this was 2x over 2. And 2 over 2 is 1. And 10 times 2 is 20. That's what x equals 20 right there. So let's get rid of this one. I just wanted to give you the impression of what fractions do and how you can do them. Isolate the variable term if possible, unless you have to deal with a fraction first. All right, let's try, I'll call it 2.2. Negative 5 equals 15 minus 2x. Now, I want to get this x term by itself, and I have a couple options. This is one of the times I'll do this more than one way. If I want to get the x term by itself, I could subtract 15 from both sides like this right here, because 15 minus 15 is 0. And negative 5 minus 15 is negative 20. And then I still have a negative 2x here. People tend to just write a positive 2x when they're making a mistake like that. Make sure you include that negative with it. If x times negative 2 is negative 20, I don't just divide by 2 from both sides, because that would give me negative x. I want to figure out what positive x equals. What is x? Let's divide by negative 2. Negative 2 over negative 2 is positive 1. Negative 20 divided by 2 is positive 10, and that's what x equals. You can double check that and see if that works. Alternatively, on that problem right there, and it's not really a big deal, that version was just fine, but what if instead of getting x terms by itself first, you say get your x terms positive first? And one version of that might be like, you can move terms over. I could add 2x to both sides of this equation like this. This might be a little too much, like as far as what you're doing. It's probably too much work to do something when they're negative here. But negative 5 plus 2x, I could write that as 2x minus 5, like that way. Remember, they don't combine. And then I could add 5 to both sides over here. So what I did was I made my terms positive and put my x's on the left side, and maybe it's just a little bit easier for you on that front. And divide both sides by 2, and then once again you get that x equals 10. Regardless of what you do, you should get the same answer. And that's the end goal. Okay, skill number 3, literal equations. Solve E equals mc squared, Einstein's relativity equation, something like that, for m. Get m by itself. E equals mc squared. Mc squared, I'm not saying what it means as regard Einstein and stuff, but it means m times c squared algebraically. C squared is multiplying by m, and I need to get m by itself right here. If something's multiplying by it, just like that 2, you divide it out. I divide c squared. I couldn't care less that c is squared, but c squared is multiplying by m, so I'm going to divide it. C squared over c squared is 1. E over c squared is, yes, exactly that. E over c squared. And that's what m equals, guys. I don't know if Einstein knew that, but that's what m equals. Yeah, Einstein knew that. Anyway, a lot of these equations tend to actually mean something, or they tend to represent something that I've done in previous problems, and that's the Einstein stuff. This one right here has to do with geometry. It has to do with 3D polygons. V minus E plus F equals 2, and solve for F. Let me rewrite that over here, just so it looks a little different. Oops. Let's write V first here. V minus E plus F equals 2. All right, let's do one little variable at a time here, at least talking about it wise. V and negative E are both adding with F. I want to get F by itself. I'd love for it to say F equals. Well, V is in the way in adding with F. I don't divide by V because V ain't multiplying with F. It's adding with F, and it's a positive V. So let's subtract V out. Minus V minus V. V minus V is 0, but that cancels right there. We still have a negative E right there. Maybe on the same step, right? I can save some time. On the same step, let's add E to both sides. Now, why do I subtract V and add E? Because I need to do opposite of how it's affecting F. F is being added with a negative E. Basically, E is subtracting from F. Doesn't matter if it's written on the left or right side, it's being subtracted. So let's add it over just to get rid of it on this side, and that means we have to add it over here as well. Now, nothing on this side combines. I have 2 minus V plus E, and that is the relationship with F, and that is the solution. That's what literal equations do. They tend to not combine things. Maybe they can. But they tend to not combine things. They just show how you can move some things over. Maybe relatively easier ones. Right there. Okay, skill number 4 is all about translating. It says right here, literally, sentences / phrases into mathematical expressions or equations or inequalities. Like this right here. 7 less than twice a number is 40. I don't know how deep I want to get into this stuff itself, other than saying what to avoid. And we'll see a lot of other problems like this right here. But the word is kind of a way of saying is equal to. It matches. It is the same as, right? He is Bob. He equals Bob, right? That person and Bob are one the same. So that is like an equal sign. It is separating that from an expression on the left side with an expression on the right side. The expression on the right side is easy. That's 40. Something is 40. Now, this twice a number, see, we're not trying to find out what the number is. We're just representing it algebraically. We can use something like x. What happens when you take, listen, it says 7 less than twice a number. What happens when you take twice of some number x? You multiply it by 2. That means 2 times x. Now, it says 7 less than twice a number, and you hear less than, and you're thinking, let's subtract. And you would be correct. We should subtract. But do I do 7 minus 2x or 2x minus 7? Because there's a big difference. 5 minus 3 is 2, whereas 3 minus 5 is negative 2. Those are two different sign answers. They're not the same thing, right? I pay you $6, you pay me $6. That's not the same. If you think it's the same, go ahead and pay me $6, please. But they're different. So if I said, what's 7 less than 10? Think about what you would do. Just as far in English, this isn't even a math question. It's an English question. What is 7 less than 10? You would do 10 minus 7 to figure it out. What's 7 less than twice a number? You take 7 away from twice a number. 7 less than twice a number is 40. Now, is that something you could solve? Sure. Is that something I'm asking you to solve? No. I'm just asking you to translate. All right, next one. Mr. Robinson, me. Mr. Robinson's student answered M multiple choice questions correctly and F free response questions correctly on an exam. Multiple choice questions are worth 2 points each and free response questions are worth 4 points each. Write an expression that represents the total number of points Mr. Robinson's student received on the exam. First of all, we're going to write an expression, not an equation. No equal sign whatsoever. I'm just representing the score, right? Their score that they got is going to be like 80 or 30 or whatever. I'm not going to say 30 equals X. I'm just writing an expression, no equal sign. Boom. Okay. Student answered M multiple choice questions. How many? M of them. I don't know, 10, 50, 100, I don't care. M of them. Let's pretend like it was 10. If I answered 10 multiple choice questions and they're worth 2 points each, how many points did I get from it? You do 2 times 10. 2 points per question times the number of multiple choice questions I got correct. So we do 2 times M. This is the amount of points I got on multiple choice, or the student got on multiple choice questions. F free response questions. Let's say they answered them exactly perfect and they got 4 points each on all of those free response questions. How many points did they get from it? You multiply 4 points per times the number of correct. 4 times them. How do you get how many points I got total with both of these? You get all the points from here and all the points from here and you add them. And there it is. 2M plus 4F. It don't equal nothing. I ain't solving for it. We're writing an expression to represent it. Maybe someday we'll set it equal to something and use that to solve for something later. Not right now. Not today. And that is the set for week 3. Okay, week number 4 right here, where we have skill numbers 1, 2, 3, 4, and 5. Skill number 5 is where we are solving word problems by setting them up algebraically. There are 3 different kinds of word problems that you'll ever see me do in these sets. They're all varied as far as what they ask and such, but the kinds that you see will you'll kind of see them click over time if you watch enough problems here. All right, skill number 1, we simplify 4 plus 3x minus 14. 3x can't combine with anything right there, but 4 minus 14 sure can, and 4 minus 14 is negative 10. 3x minus 10 is that result. Find the perimeter of this triangle in terms of A. All in terms of A means is that A is going to be in your answer when you do it. I'm not actually finding out what A is or anything like that. Now this triangle, the triangle has 3 sides, but this triangle also happens to have the sides expressed in terms of A already, and finding a perimeter of any shape is finding the distance around the object. When they are normal lengths like this, we could just add the side lengths right here. So I have one side length that is 3A minus 2 units in length. Whatever A is whatever. 3 times that number minus 2, that's how long this is. Let's add it with 5A plus 3. And let's add that with 6A plus 1. That'll be your perimeter that we're trying to find. Right? P equals, if you want to say that. But that'll be the perimeter. Now, I could wrap parentheses around this as much as I want to. That won't mean anything other than I'm grouping up what those side lengths mean. Or you can get rid of them. Essentially, what's going to happen is we got to combine like terms. Finding the perimeter, let's simplify it. 3A plus 5A is 8A, plus 6A is 14A. Negative 2 plus 3 is 1, plus 1 is 2. This ends up being 14A plus 2. That's another way of expressing the perimeter without having all these terms together right there. That's your perimeter, 14A plus 2. And if A is 10, I don't have to do 3 times 10 minus 2, plus 5 times 10 minus plus 3, plus 6 times 10 plus 1. I can just do 14 times 10 plus 2, and it's 140. Right? So it's nice and fast that way. All right, skill number 2, 3x minus 4 equals 14 for that first question right here. 3x minus 4 equals 14. Our goal is to get x by itself right here. Let's start by getting the x term by itself. I'm going to add 4 to both sides. 3 times x is 18, and divide both sides by 3, and we are going to get x equals 6. You can double check it. 3 times 6 is 18, minus 4 is 14. It works out. All right, then you get a question like this one in number 2, where the x is on both sides. This left side is simplified, but the right side clearly is not. Maybe if we simplify that right side, things will kind of pan out for us for the better. 2 times 5 is 10. 2 times 2x is 4x, and I've distributed right there. I still have negative 9 plus all of that, and that equals 4x plus 1. Yeah, I want to simplify this right side before I start moving terms over. Now I'm going to get 4x plus 1 equals negative 9 plus 10 is 1. So I have 1 plus 4x, or I could write it as 4x plus 1. Now check this out before I keep moving forward on this problem. 4x plus 1 equals 4x plus 1. Yeah, right? I am myself. Okay. Yeah, our goal for this thing is to solve for x. Find what value of x would make the left side equal the right side. Well, I ask you, is there a value of x that you can think of? Or is there a value you can think of substituting for x that will not make the left side equal the right side? Go ahead. I'll wait. I don't know what just happened. No, I won't wait that long. No, no matter what I substitute for x, the left side will always equal the right side. To emphasize that further, if I tried to get x terms by itself by, say, subtracting 4x from both sides like this, they just kind of end up canceling. You just get in a statement that says 1 equals 1, which is very true. Now, does that mean anything? Does that mean x equals 1? No. Does that mean x can equal 1? Yeah, x can equal anything. What I'm getting in this equation is something where the left side equals the right side no matter what I plug in for x. This is a case of saying that x can represent anything. When you get a statement where you can cancel out your variables, and the left side equals right side is a true statement there, you have a solution set that is all real numbers. That's what you want to conclude with right there. X can be anything in the world, not just 1, not just 2, not just 7, or 1.5, or negative whatever, pi. X can be anything. And that's our conclusion that we make off that, assuming you made correct math, which I did, so I'm going to live with it. All right, that is skill number 2. Skill number 3, solve V equals LWH for W. That's volume equals length times width times height. Is that true for all volumes? No. For prisms, yes. Length times width times height. Let's solve for W. Let's get W by itself. Now, I separated these in to show that they are actually literally multiplying with W. If something is multiplying with W and I'd like to get W by itself, we must divide it out in order to solve for W. So, L is multiplying by W. Let's divide by L. H is dividing by W. Let's divide H. Let's divide L times H, basically. Yes, they will multiply together in the denominator happily, where L divided by L is 1, H divided by H is 1, and 1W equals W. And W equals V divided by LH. The width of a prism is its volume, is the prism's volume divided by its length times its height. Length times height in the denominator, you're dividing by both of those, but they are together down there, and that is W. All right, number 2, solve 3x squared plus 8y equals 2b for y. I got to get y by itself, which means I got to get 8y by itself, which means I got to move this whole term over. I don't care that 3 is multiplying with x. I don't care that x is being squared. I just care that it is on this side of the equation, and it's adding with 8y. If it's adding with 8y, let's subtract it over. It doesn't seem to combine with that 2b in any particular way. By the way, this equation means nothing. This is one that's just made up. 8y is still right here. I have 2b minus 3x squared over on this side right here. If I go ahead and divide both sides by 8 as it multiplies with y, remember, you divide everything here by 8. And y then equals 2b minus 3x squared, all divided by 8. Not just one term divided by 8. You don't pick and choose. You don't pick and choose. You divide everything there by 8. Everything. And that is the result. All right, skill 4. Translate the following sentence phrases into mathematical expressions, equations, and inequalities. The product of 3 and a number is 12. Now, what you may have seen before is that is right there. Whoops, that is right there. Kind of represents the equal sign of something that separates the right expression of 12 with the left expression, the product of 3 and a number. 3 and a number means 3 times that number like that. 3 times some x. I don't know what the number is. I'm sure we know it's 4. I'm not trying to solve for it. I'm just trying to set it up. That is my setup. Product means the result of multiplying two numbers together, that first thing and that second thing right there. And that's what we get. All right, half of a number is 8 less than the same number. Now that's an interesting overall statement right there, because you see a number or the same number, whatever, twice there, number, the same number. That must mean that whatever we have, like x, looks like we're going to use it more than once here. Now you see is again, but it's a little bit more. Actually, no, it's not a little bit more than just that. It says is right there, and we see an expression over here and an expression over here. And it's not just a single number on one side like that 12. Half of a number. How do you take half of a number? You can either divide it by 2 or multiply it by 1/2. They both represent the same thing. If some number is x and we divide it by 2, that would be half of a number. You could also put it as what you're going to see in the future, 1/2 x. That's half of a number. Let's go and put it like that. That's half of some number. And that means 1/2 times x, by the way. Taking half of something is multiplying it by 1/2. 8 less than the same number. If that number that we're talking about is x, let's take 8 less than it. And as mentioned in the past, taking 8 less than something is subtracting 8 from it. 8 is written last, even though you see it expressed first in the sentence. And that is that answer there. Again, we didn't solve for x, but we could have. All right, skill number 5. Set up algebraic equations and solve. Answers must contain units. Now, later instructions are going to say that you must, for quiz-based purposes, they must use algebraic equations for full credit, but I'm asking you to do it right here. Set up algebraic equations. All right, the length of a rectangle is triple the width. The perimeter of the rectangle is 80 units. Find the length. Now, this kind of equation, this kind of way of setting something up, and there is more than one way to solve these in the long run, using systems of equations, things like that. We're not dealing in that front. But this kind of equation thing to solve is, when I call it to my students, I call it a totals equation. Basically a way of totaling two different things that can be expressed using the same variable if you try hard enough. If I have a width and a length in a rectangle, opposite sides are also width and length. When you find the perimeter of a rectangle, you add up all the sides. We talked about that with the triangle stuff above. You add up all the sides. So if I add both of these W's and both of these L's right here, I'll get the perimeter, right? So I could write an equation that kind of says perimeter equals both L's plus both W's. That's kind of cool. You know what? Here, let's do both two W's plus two L's right there. Now, they want us to solve this thing right here, and it says the perimeter is 80 units. So I can substitute the perimeter with 80 and say that 80 right here, let's do it on the other side, 2W plus 2L equals 80. But I still haven't accomplished what I need to yet, because there's an infinite number of solutions I could have here. If the width was 10, then the length could be 30. Actually, that might even be the answer. If the width was 20, then the length could be 20. Those add to 80 as well, right? But there's only one in particular that works where the length is triple the width. And what I want to do, instead of writing 2W plus 2L equals 80, because I have two variables in one equation, is let's get this down to one variable in one equation. Let's, if the width is indeed W for me, if it's that long, I can express the length not just as L, but it says the length is triple the width. Literally, the length is triple the width. The length is triple the width. I can express the length as 3W. How does that accomplish anything? It gets me with one variable in one equation. It allows me to solve for W that way. You might be thinking, how do I solve for length after that? Well, you can triple the width. You can do that, or you can find out what, the widths, the perimeter adds to 80, and you can find the length that way. There are a lot of ways you can find it out after that, but right now we need one equation with one variable. That's our way of solving. You can't assume that they're both the same and they divide by 2 equally. They tell you the information. The length is triple the width. So now we have one equation where we can solve. And 2 times 3W is 6W. Let's use this information to solve for W. 2W plus 6W is 8W. And you divide both sides by 8 right here. If I divide both sides by 8, I get W equals 10. Now, there's something specific they asked us for, or they stated as well. No, I take it back. They just said units. So I'm going to say units. Normally, if the word problem, guys, if it said inches, say inches, things like that. You're going to see me do that all the time. This one just said units. All right, that's the width. I asked to find the length. So the width, that's great. What's the length? Well, the length is 3 times the width. The length is 30 units. And that should work out. That is 3 times the width. And when you add 10 with 30 with 10 with 30, you get 80. Hold on, give me 1 second. I'm going to pause this. I just got a text. Okay. So yeah. I just had to pause for something. I forgot what I was finishing up on for this week's stuff. Oh, I didn't finish everything though. But so yeah, the length is 30 units right there. And yeah, you can double check all that information from what we had. All right, let's delete that. Let's go to this next one. Samantha has $400 in her savings account. She is saving for an $850 iPhone and currently makes just around $45 a month. How many months until Samantha will have enough to purchase the iPhone? Now, you could make a table, you could plug things in, or you could try it until it works and things like that. We're going to do this algebraically, and we're always going to do it algebraically. Now, this is what I would call I forget how I called it before. There are a lot of easier ways I can tell my students about it now. It's a linear model. But we called it a rate total problem or something like that, where there's some rate that's involved and you have to total it with some amount that you already have to figure out, what it comes up to be. Okay, she has $400 right now. What I want to come up with is how much money Samantha is going to be making. How much Samantha has for money. Samantha money. She has $400, but she's going to be adding more money over time. We'll talk about that in a second. On this other side of this equation, we're going to be talking about how much the iPhone cost. iPhone money. And I'm not always going to establish it this way. iPhone money is $850. Does 400 equal 850? No. But we're going to add how much, you have to add 450 to it. But how many 45s does that take? Because here's the idea. We want to be adding 45, not just once, but over and over and over again a certain number of times. How many times? That's what we're figuring out. Every month she adds another 45. How many months? So we can represent this with a variable, 45 times the number of months, and let's define the variable. Let's call it x. I'm going to say let x equal the number of months. That's the thing that I don't know. That's the thing that I'm trying to solve. And here's my rate total equation. There's a rate, which we had $45 a month for x number of months, with the 400, and it totals to $850, and now it's an equation we can solve. And that's what we do, set it up algebraically and solve there. That's another kind of problem that you're going to see on these ones. Subtract 400 from both sides right there, and we get 45x equals 450, like we said before. That's the extra amount she would have had to add. So if you do 45 that many times for it, right, logic can kick in, and I'm sure you can solve those things conventionally. But I don't want it to make it so hard that you can't later, and just trust me, it works that way. I am going to see, that's why I always had to start making the statement. By the way, that's 10. I always had to start making my statement for the students that as much as you're applying this logically, I need to see that you can set things up algebraically and solve things algebraically. The word problem I'm going to make easy enough for you to be able to do logically if you want to make sense of the situation. But I need them to do that, and that's what I'm going to keep reinforcing here. 10 months. It'll take Samantha 10 months to save for the iPhone with how much she makes per month. All right, and that is this week number 4 material here on skills 1 through 5. Okay, week 5, which will have skills 1 through 6 right here. Skill number 6 is on proportions. But let's tackle these ones before. And you can see these are going to start bunching up right here a little bit. I'll still fit within here what I can. All right, skill number 1, simplify negative 11 times 5 minus 2x. I shall distribute the negative 11 into both parts of the quantity here. That's negative 55 plus 22x. Just like that, straight up, point blank, we are done. See, a negative times a negative is a positive there. That's where the plus 22x comes from here. Now, number 2 is a little interesting here because now I have this 5xy term, x times y. When I have x terms and y terms, how do terms combine? You combine x's with x's. You combine y's with y's. You combine constants with constants. You combine xy's with xy's. X doesn't combine with xy. Y doesn't combine with xy. Only xy's combine together. So I have x terms right here. 2x minus x is 1x, so just x. 5xy don't combine with nothing. It just stays as is. It's 5xy. That's it. And then positive 8y and positive 10y add to become positive 18. y. And those are your 3 terms. That's as much as I could simplify. Not too much, but I did. Skill number 2, solve. 2 minus x equals 7x plus 18. As we've done in the past, we should move all x terms to one side of the equation. My strongest recommendation is to get your x terms positive. Keep them positive. If I subtract 7x from both sides, that would make my x terms negative. I kind of recommend you make them positive. Let's add x to both sides just like that right there. Negative x plus x is 0. You're left with 2 on that side. 7x plus x is 8x right here. We have the plus 18. If I moved x's to one side of the equation, let's move constants to the other side of the equation. Subtract 18 from both sides. We get 8x equals negative 16. Divide both sides by 8, as 8's multiplying with x, and we get x equals negative 2. You can double check it. I promise you, it works. That's number 1. Number 2, solve 2x plus 1 over 3 equals 1. Allow me to write that a little bit bigger, just with more space one more time here. Now, we've seen a problem in the past where x was dividing by something, but it wasn't also adding with something before it divided. You see, in this numerator, pretend like this was in parentheses. Order of operations says you do grouped items first, and 2x plus 1 happens before you divide by 3. In fact, dividing by 3 is the last thing that happens to get 1. Something divided by 3 equals 1. What is that something? We got to multiply by 3 to figure it out. You begin by multiplying by 3 right here. You begin by multiplying by 3. Not 3 times 3 right here. 3 is multiplying with these guys. But do I distribute the 3? No. The whole reason I multiplied by 3 is because this is dividing by 3. 3 times something, something times 3 divided by 3 is just that something. 3 over 3 is 1. Those are dividing together. That is on top. That is on bottom. They're dividing. Whereas 1 times 3 is actually 3. So 2x plus 1 equals 3. No more fraction. We can actually just solve this how we want to. If I subtract 1 from both sides right there, I get 2x equals 2. And then divide both sides by 2 right there. 2 over 2 doesn't just cancel. It becomes 1x. So 2 over 2 right here doesn't cancel either. Whoopsie. 2 over 2 over there doesn't cancel either. 2 divided by 2 is 1. X equals 1. There it is. Okay. Skill number 3. Number 1, solve D equals RT for R. D equals RT. That doesn't mean dirt. It means distance equals rate times time. That is a big topic in physics. You might have heard that one before. Solve for R. R is multiplying with T. Let's divide by T. I want to know what R is equal to. R equals D over T. That's a huge thing. Distance is rate times time, and rate is distance over time. Think about it. Some rate on something. You drive a certain miles per hour. Miles per hour. And you're going to see word problems with that kind of thing as well. 80 miles divided by 2 hours equals 40 miles per hour. That's a rate, right? That's what that is. That's what that is. All right, solve A equals 1/2 times the quantity B plus C for B. Now, when my students had done this, there are a lot of different answers that I've seen, including having 1/2s all over the space right here. I am going to rewrite this one more time right here, and I actually in this version, I'm going to imagine it as something else. You might have heard me before say that dividing something by 2 is the same thing as multiplying it by 1/2. Well, you can work it the other way around. Half of something is the same as dividing something by 2. We're taking half of B plus C. We're dividing B plus C by 2. Now, you don't have to write it this way, but I'm giving you this visual as to have you imagine what you can do next. We just saw a problem where we had something divided all by 3, so we multiplied by 3 to kind of annex that thing. To ax that thing right there. So if I want to get B by itself right here, B is adding with C, all of that's dividing by 2. Let's multiply both sides by 2, right? Now you could have done that right here as well. You take half of something, let's double that something all over again. What's double the half of something? It's just that something. 2 over 2 is 1, and yeah, you're left with that. I have 2 times A on this other side now. So I have 2A equals B plus C, no matter whether you wrote it this way or that way. And I can subtract C from both sides. 2A minus C do not combine. I'm going to have B equals 2A minus C. Sorry for me writing B on the left, but I just prefer that. And that's the best version of the answer you can write. There's another version. If you divided both sides by 1/2, you'd have A over 1/2 and then minus C. You don't want to write it like that. There's too many kind of hiccups with saying exactly that. You don't want a fraction in a fraction. Okay, skill number 4. Translate the following sentences or phrases into mathematical expressions / equations / inequalities. Twice the difference of a number and 6. Now, this is pretty interesting how this thing's written. First of all, it's an expression, not an equation. I don't see the word is or equals or anything like that. It just says twice the difference of a number and 6. Just write the expression. Now, difference means subtraction. So when you see the difference of a number and 6 is kind of its own arrangement of something. A number is like x. I'm going to subtract 6 from x, the difference of a number and 6. We're going to take twice this amount. Does that mean I do 2x minus 6? Not quite. I'm not taking twice a number. I'm taking twice the difference of a number and 6. I want the difference to happen first and take twice that amount. How do I do that? Parentheses. Order of operations. This is twice the difference of a number and 6 right there. By the way, so that's the answer. By the way, if this said twice the difference of a number less than, twice a number less than 6, we've seen it before. When I say 7 less than something, I got to subtract 7 from it. Even though 7 was written first, I have to write 7 last in my subtraction. This time of a number and 6, number goes first, 6 goes second. That's exactly how it works. Same with product and quotient and sum. You want to write it like that. Okay, a cinema charges $15 per adult ticket and $12 per child ticket. Let A be the number of adult tickets purchased for a screening, and let C be the number of children tickets purchased. In the equation 15A plus 12C equals 2,508, what does the number 2,508 represent? Okay, in order to figure out what that represents, we got to figure out what these other terms here represent. We've kind of seen questions like this before. There was the one on the multiple choice and free response stuff. We ended up getting a point value through that expression represented by how many points per multiple choice question times the number of them, how many points per free response question times the number of them. Same with this right here. $15 per adult ticket times A adult tickets gets you how much money the theater collects from adults. This is money from this is adult money. See, they didn't just collect $15. What if there were 10 adults that attended? Maybe more. What if there were 10 adults that attended? That's $150. You got to multiply it. That's adult money. This is child money right here. $12 per child times the number of children is child money. This is how much chid money. This is how much money they collected from, not from children, but from child tickets. When you add the money from adult tickets and the money from child tickets, you get total money here. What does 2,508 represent? Represents the amount of money the theater collected for a screening. They made, or whatever. They made for the screening. I should type it next time. I don't want to write this much. Single screening made $2,508. I don't know if that's a lot or a little, but hey, that's how much they made. That's what that represents. And now that you saw an equation like this, be ready to start building equations like this over time in other kind of quizzes. I had to bit my tongue. All right, skill number 5, set up equations for each situation and solve. Tina is saving to buy a notebook computer. She has 2 options. The first option is to put $200 away initially and save $10 every month. The second option is to put $100 away initially and save $30 every month. Now, this is kind of a 2-part question here. Question 1 is right here. After how many months would Tina save the same amount using either option? And the second question is how much would Tina save with either option? Excuse me. Now, I won't answer this question before I answer this question here. Once I figure out how many months Tina would take to save the same amount, then I could actually figure out how much that would be. So this is the third, because I mentioned in the past that there are 3 different kinds of equations you're going to see in these word problems. There was a totals kind, where you expressed one variable in terms of the other to add them to something and solve. There was like a rate totals kind, where you added some initial amount with some rate and then you got some total, whatever. And then there's a rate kind, where you set 2 rates equal to each other and see when they kind of equal the same thing. And that's not all the different kinds of word problems they are, but that's the kinds that you're going to see here. So that's what we have here. 2 options. One option is where money grows. She saves this amount. Another where she saves this amount. And when do the amounts saved end up giving you the same amount of money? When? After how many months? This is our unknown. Let's let this be X, number of months. Now, we've seen something like this by totaling some things to an amount. Let's look at the first option. She saves $200. That's what put 200 away means in this case. She saves $200 for her first option. She says, okay, if I save 200 and then I start saving 10 every month on top of it, I will save this amount. This is first option. $200 saved initially plus $10 per month times the number of months. That's the first option. Second option is to put $100 away and save $30 every month, like this. $100 put away, $30 per month times the number of months. This is how much money I'm going to save. For what value of x do the amounts saved be equal? That's the question being asked right there. So we can solve for x. Let's go ahead and do that kind of in a faster fashion. I'm going to subtract 10x from both sides to keep my x terms positive, in which case that means I should probably subtract 100 from both sides to move them to this side of the equation. So 100s go away here, 10x's go away here, and now I have an equation that says 20x equals 100. If I divide both sides by 20, I don't know if you can see that, sorry, my picture might be in the way. If I divide both sides by 20 right here, I will get x equals 5. The answer to the question is 5 months. It'll take Tina 5 months to save the same amount of money using either option. Now, before that, the first option, she would have saved more money because she put away 200 initially and she's growing less over time. After 5 months, she would probably be saving, or she would be saving more money because after that they're equal, then she keeps saving 30 more after that, and then you can kind of tell, you know, what's going on with that. Now, how much would have she saved with either option? What I mean is with either option when they are equal. 5 months later, how much would have that been saved when they're equal? So what can you do? We know that the x equals 5, that's 5 months, and we have two different expressions representing the amount of money she saved. 5 months later, we can either do 200 plus 10 times 5, which is 200 plus 50, which is $250, use your units. Or, heck, I could have used the other expression. 100 plus 30 times 5 equals 100 plus 150 equals $250. It's the same amount, right? That was the whole goal, getting the month that has you save the same amount. This is the only month where it does it. But that's the one. My neck, man. I'm like leaning too much. I got to find a way. Hold on. Can you still see me? I don't matter, but can you still see? Yeah, you can still see me up here. Give me 1 second. Let me just stretch while I'm talking about this. Oh, it's the way that I'm kind of doing the lean right there. It's just, oh, so much. Oh, and then it induced a yawn there as well. And yeah, so those are the units. That's the thing. That's what answers that. And normally when you see a rates question, a rate comparison where they're equal, I'm going to turn my head more like this a little bit when I'm talking to you guys. That's the kind of thing you're going to see. Maybe a two-parter more often than not, I'd say. All right, the new one here, skill number 6. I have so much room that I'm going to write all this stuff. X plus 2 over 8 equals 5 over 4. Now, as we're solving for x, you could look at previous problems that we did and say, hey, solving for x, let's multiply 8 from both sides. And you know what? This would actually probably be the fastest approach. But what you're actually looking at also right now is something called a proportion. A proportion is a comparison of two ratios, two fractions that are equal to each other. And they all will kind of tend to have something in common here, which is they have fractions on both sides with denominator. And I can clear the fractions in a lot of different ways. This particular way that I'm going to do it is probably not best served for solving fastest, but it is most convenient and foolproof for any other proportion that you always see. Trust me, there are a lot of ways I can solve them. I'm going to try and reduce the number of ways for time's sake for this one. Basic crux of it is this. Let's get rid of the fractions. If we are dividing both sides by 4, if this side is dividing by 4, I can multiply both sides by 4 like this, and then the 4 divided by 4 is 1. If I am dividing by 8 on this side of the equation, I can multiply both sides by 8 like this, and here 8 over 8 is gone. You know what ends up happening is 4 ends up multiplying with x plus 2. Keep in mind, x plus 2 is a quantity. This is 4 times x plus 2. And 5 ends up multiplying with 8, like that. Now, what I wrote felt like a lot of steps just to get to here, when I don't know if you noticed, this 8 kind of just got out of the denominator and multiplied with 5, and this 4 kind of just got out of the denominator and multiplied with x plus 2. Not every teacher's favorite terminology. It's mine as long as you know what's happening and understand it's not just a magic step. It happens for a reason, and it only happens in proportions. This is something called cross multiplication. Cross multiply. And listen, a lot of people screw this thing up. That's why I really shudder in fear in saying it, but I work toward convenience. Assuming that you understand what's going on here. You multiply both sides by your variables. That's what makes it go away on one side and goes up to the other side right there. And it's still an equation. I see a lot of students just, let's put a thing here and a thing here and then cross multiply with fractions, multiply. No. This is cross multiplication in a very certain way for a very certain reason. Here on out, it will be doing cross multiplication, nothing further. So I hope that you know why this is happening. No more denominator. Yes to these things right here. If I now distribute 4 into x and 4 into 2, I get 4x plus 8. If I multiply 5 with 8, I get 40. And this is one of those let's solve kinds of problems. Subtract 8 from both sides right there. I get 4x equals 32. Divide both sides by 4. I get x equals 8. Excuse me, yes, x equals 8. You can double check that. Let's try that from the original problem. 8 plus 2 is 10. 10 divided by 8, besides the decimal, 10/8 reduces to 5/4. So yeah, it's the same as 5/4. Now, there are a lot of other ways you can kind of solve these problems. And again, I'm not going to get too deep into this for every kind of problem, but you might say, well, Mr. Robinson, could have I multiplied both sides by 8 and subtracted 2? Yes. Mr. Robinson, 8 is twice that of 4. Half of 8 is 4. Would half of this be 5? Could I double 5 and make this? Yes. There are a lot of different things that you can do once you understand proportions, and I like that logic and understanding of it, but I also like you solving algebraically for the sake of falling back on it when you need to. And for the sake of this, I'm going to work on the algebra. All right, number 2, a certain recipe calls for 3 cups of sugar for every 24 cookies made. It's a word problem. Mr. Robinson plans on making cookies for his 168 students. No, I don't. I did not do that. I will not do that. I might, but who knows when you see the video. How many total cups of sugar will he need to make the cookies for his classes? Now, this is in skill number 6. This is about proportions. The proportion shows a rate of something. 3 cups of sugar for every 24 cookies. Every time you make 24 cookies, you're going to need 3 cups of sugar. That is a rate. 3 cups of sugar for every 24 cookies. Ratios can be represented as fractions to just show this could reduce to 1 cup of sugar for 8 cookies, or X cups of sugars for 168 cookies, right? By the way, I never mentioned 168 students. We're assuming each student gets 1 cookie. So here's what we do. We set up a proportion. We have a ratio right here. We're going to keep this in proportion for growing to 168 cookies. 168 cookies, notice how I put it on bottom with cookies right here, equals how many cups of sugar? That's what we're trying to figure out. And that's our proportion in our setup. And you're going to tend to see me write those proportions with units to start, and then after just kind of reduce it to this. 3 over 24 equals x over 168. And we have a proportion. Yes, if I multiply both sides by 168, I would solve, but for the sake of proportion, and yes, I can reduce this fraction to 1/8. But for the sake of proportion talk, let's stick with what we got. Let's deal with big numbers. I'm going to even use the calculator. If I cross multiply right now, I get 24 times x equals 168 times 3. 3 times 168. Calculator. 3 times, you're not going to see this because you don't need to, it doesn't matter. 3 times, I probably know what it is, but I don't want to mess it up. 3 times 168 is 504. And then I can divide both sides by 24 and figure out what x is. How many cookies will Mr. Robinson have to make? Divided by, excuse me, not how many cookies, how many cups of sugar will Mr. Robinson have to need? X, that's the units. X equals 21. 21 cups of sugar. That's how much I would need for 168. So that's a lot of sugar. It's a lot of students. It's a lot of cookies, right? But that's how many cups of sugar. So set up a proportion, solve that way, all good to go. Okay, and that's skill number 6 here in this week number 5 material. Now, any future problems that you see from me, you might have noticed where I wrote divide by 4, subtract 8, divide by 24, all that kind of stuff. You're going to see me do that a lot less in other problems. Now that you've seen a lot of algebra there, I will write the action from here to here. I will say out loud divide both sides by 4, but you will see me do a lot less of the actual action of dividing by 4. Now that you've seen a bunch, hopefully you know what's happening from one problem to the next. You're going to start seeing a lot of speeding up outside of problems that we haven't done before. Okay, week 6 here. Skill number 1. Once again, simplifying. We're combining like terms. A lot less room to work with, but I don't need that much room for these kinds of problems. I'm going to combine 14x plus 6x plus 1x. That is 20 plus 1, which is 20. Oh, plus 100. It's 21x plus 100 is 121x plus 1. That doesn't seem to combine with anything, and that's it. Number 2, 3 distributes into x and negative 7. We get 3x minus 21, and plus that 7, Negative 21 plus 7 is not negative 28, but negative 14. We get 3x minus 14. That's how those combine. Okay, skill 2. Number 1, solve these guys right here. Now, you've heard me say before you move terms over, let's combine, not combine like terms, let's simplify this expression here. Negative 5x plus 6x can combine to just become, well, x, 1x. And I have x minus 8 still equals 19. Now I should move that negative 8 over, now that I'm simplified. If I add 8 to both sides, I'm going to get 19 plus 8 is 27. And that's what x equals, 27 right there. Number 2, I solve 2 equals negative x over 5. Now, it's interesting because it's negative here. And the interesting part about negatives, which I'll talk about more when we dive into slopes, is that the negative really applies, it's applying to the fraction. But as far as numbers go, I don't care what x is, but it can either apply to the top number or the bottom number, as if to say 2 equals negative x over 5 or 2 equals x over negative 5. Either or, they all represent the same thing. A negative divided by a positive is a negative divided by a negative is a negative, but a negative divided by a negative is a positive. So you can only represent it in one way or the other. And for the sake of this problem and solving for x, I'm going to represent it this way. I'd rather multiply both sides by negative 5 just to already get x by itself, rather than multiply both sides by 5 and then have that negative x to deal with later. Negative 5 times 2 is negative 10, and that is exactly what x equals there. Check it out. The opposite of negative 10 over 5 is the opposite of negative 2, which is 2. That's it. All right, skill number 3. Solve m minus n equals p plus q for q. Q is literally just adding with p right there. If I subtract p with both sides, I'm done. That's all q is going to equal. What is it? M minus n minus p. I just subtracted that p over, and that's it. Some of these problems get a little bit easier than others, all depending on what there is. And then I ramp up to a maybe harder one right here, like this number 2. 2y minus 1 equals x, solving for y. You know, 2y is a term I got to get by itself. Let's add 1 to both sides right there. Boom, boom. I'm going to get 2y equals x plus 1. X plus 1 sure don't combine right there, but they will both divide by 2. If I divide both sides by 2 like that, I'm going to get y equals x plus 1 all over 2. Now, here's one version of an answer that I completely accept. However, you are going to start seeing equations down the line in y equals mx plus b, slope-intercept form, which if I divide them separately by 2, they're all dividing by 2. I could write it like this, you know, kind of like that. And in doing so, you know, the x over 2, you also see me write as a 1/2. I think you've seen that in the past. So like y equals 1/2 x plus 1/2 like that. That's a version of an answer you can write. All 3 of these answers all apply. Why would you write it like that? When you start graphing, you'll realize why, if you haven't graphed before, or maybe you know exactly why I would do that. I don't like a y-intercept of 1/2 personally when I graph, but that is the way that I'd like to have it represented. Any of these apply. As long as you get y by itself, you're good. All right, skill number 4. Translate the following sentence phrases into mathematical expressions, equations, and inequalities. Your driving speed is at most 65 miles per hour. Now there's context in the situation. Now they're talking about my driving. How dare they? No, now we're talking about your driving speed is some unknown, some variable right here that can grow as much or shrink as much as it wants to. Take it back. It can't grow as much as it wants to. It can only grow up to 65 miles per hour. That means your driving speed must be 65 miles per hour or less. This is what we call an inequality. It's not an equation. It's not, my driving speed ain't 65 miles per hour. It can be less as well. So, in inequality, I see the word is, but it's is at most. You might also see is less than or equal to, is greater than or equal to, is at least in those situations. X don't just equal 65. X can be as much as 65 or smaller. X is less than or equal to 65 is a great version of that. You know, some students will get really fancy with this and say, well, you can't have negative speed, so you have to be greater than or equal to 0. This is called a compound inequality. I dig that. I actually dig that a lot. I'm not maybe thinking in those terms. I'm thinking we can drive reverse speed. We can go negative. No, I'm just thinking in terms of this. As far as context goes, I get it. At stopping point is 0. But got to just be under 65 or equal to. And that's what the inequality means, less than or equal to 65. Okay, on a farm there are C chickens and P pigs. Write an expression for the total number of legs the chicken and pigs have on the farm. The chickens and pigs have on the farm. C chickens might mean 7 chickens. How many legs does 7 chickens have? Our assumption, let's stick with it, is that there are 2 legs per chicken. and there are 4 legs per pig. So if there were 10 pigs, you would do 40 legs. If there were 7 chickens, you would have 14 legs for those. If you want to find out how many total legs there are, when you hear total, you're thinking add them up, and you'd be correct. So what we're going to do is take the 2 legs per chicken and multiply by the C chicken. This is how many legs you get from all the chickens. And then you add it with the total number of legs for all the pigs. That is the 4 legs per pig times the number of pigs that there are. They said write an expression. It's not equal to anything, not equals x. This is my expression. I am good. It's kind of like the multiple choice free response question we had some weeks ago. That's it. We're done. Skill number 5, set up equations for each situation and solve. Now I start saying things like no credit will be earned if not solved algebraically. I think over time I started to see my students kind of slouch on that part, trying to find logic into it. Let's do it this way. Al is 6 years older than twice his son's age. The sum of their ages is 72. How old is Al's son? So here's the thing. We have 2 different ages we can represent. Al's age and his son's age. I'll put Al and son. Al is 6 years older than twice his son's age. So if I represented the son's age as x, Al's age compares to his son in such a way that if you take 6 years older than twice his age, what's twice his age? 2x. What's 6 years older than that? Add 6 to it. If his son is x years old, Al is 2x plus 6 years old. If son is 10 years old, Al is 26 years old. Pretty young for a father to have. He'd been 16 years old to have his son, but that's why I hope that this problem has a better answer than that. The sum of their ages is 72. When you add this age with this age, you get 72, and hopefully you notice what I was doing there. This is one of those totals equations where you're expressing one in terms of the other, because now you can solve for a variable here, and that x will be the son's age when I solve for it. I'm going to combine like terms. 2x plus x is 3x, and all 3x plus 6 is 72. If I subtract 6 from both sides there, I get 3x equals 66. If you divide both sides by 3, you get x equals 22. Al's son is 22 years old. They did not ask how old Al is, but if we were to answer it, you can do it one of 2 ways. You can either take twice 22, which is 44, plus 6, which is 50. Al is 50 years old. Or the sum of their ages is 72. If the son is 22, subtract 22 from 72. You get 50, like that. All right, that's the first question. The second question has nothing to do with ages, but it's Al and his son still. They drive together to the 49ers game. I'm in Sacramento, so this is kind of just that concept. They buy 2 tickets and pay $40 for parking, spending a total of $300. How much does each ticket cost? So they drove together. That means they pay for parking just once. That parking is one static value. $40 is an amount of how much they did pay. They also bought 2 tickets. We don't know how much each ticket cost, but if you multiply the number of tickets purchased by the cost per ticket, X is number of tickets, cost per ticket in dollars, then you get the total amount that they spent with the $40 spent on parking. They spent $40 on parking, 2 tickets there, and pretend like they didn't spend buying food, or we're not talking about that. Right here, or souvenirs, then you can solve for x. X is number of tickets. Subtract 40 from both sides, I get 2x equals 260. Divide both sides by 2, I get x equals 130. I don't know, that sounds kind of cheap. Maybe they're nosebleed sections. They spent each ticket costs $130. $130 per ticket. Sorry for all the blue, but that is the second question there. Oh, my neck. All right. Okay. In November, Mr. Robinson... I'm sorry. We're on here. Number 1. Solve. This is a proportion. 4 over 7 equals 12 over x. Hey, we can cross-multiply this thing. Now, x is in the denominator, but we get to move it up and multiply it with 4, and we get to move 7 up and multiply it with 12. When we move that up, that says 4 times x. This equals, we have 7 times 12. That's 84. I'm going to do quick math with you. If I divide both sides by 4, I get x equals 21. You can double check it and see if that works. It will. They should give you the same value. 4 divided by 7 is some weird decimal. 12 divided by 21 is that same weird decimal. That's what x equals. All right, number 2. In November, Mr. Robinson will drive 550 miles to Las Vegas, Nevada. That was the plan. Didn't happen. If his average driving speed is 80 miles per hour, how long will it take him to reach Las Vegas? Give an exact answer. So here's the thing. The rate, you're trying to look for the rate. 550 miles is the total amount driven, so I need to figure out the total amount of hours it's going to take for that. But I have a rate right here. It's 80 miles per hour. That's 80 miles for every 1 hour. That's kind of hard to find that rate sometimes. I'm sure you could find the logic to make this happen, but to set up a proportion, this is what we want. If miles are on top here, I'd like to have miles on top right here as well. 550 miles for X, unknown, hours on bottom. And that's our proportion we get to set up. 80 over 1 equals 550 over X. Same thing as last one. It looks even very similar as well. I can cross multiply these guys right here, and I get 80 times X equals 550 times 1. 80X equals 550. And maybe you knew this the whole time. 550 miles divided by 80 miles per hour should give us the number of hours. Or 80 miles per hour times the number of hours should give us the total distance. What is 550 divided by 80? 55 divided by 8. I'm trying to use that calculator. I think it's 6.875. Let's see. 550 divided by 80. 6.875. 6.875 hours. A tick under 7 hours right there. Not accounting stopping for gas and food and already driving over the speed limit right there. Hopefully I don't get pulled over. Things like that. Okay, so that many hours. That's probably close to 6 hours and like 50 minutes or something like that. That's really good time from Sacramento. Okay, skill number 7. This is the new one. Is the following relation of function justify your answer? The basic thing I want to say on functions, and I'm going to say it out loud, is this. Functions are relations, which is a set of ordered pairs represented with a list, a table, a mapping diagram, which I'm sure you'll see on another quiz, a graph, any sort of way you see ordered pairs together. They don't have to relate in such a way that you see a pattern. They're just together as a cluster. But a function is a relation where every x only has a single y. And I know that people will mess that up. That'll go backwards. People will go, wait, which one is it? And things like that. Every x only has a single y. Every input only has a single output. Every domain only has a single range. That doesn't mean you can't repeat those outputs. That just means that you can't have a single input with different outputs. The way I tell my students about it is a vending machine. If I push a button on a vending machine, I only expect one type of drink to come out. I push this number, that drink comes out. 1 Pepsi, 1 Pepsi, 1 Pepsi. I push 2, I get Coke. 2 Coke, 2 Coke. I shouldn't push 1 Pepsi and then push 1 and get Coke. That's not a function. Meanwhile, you see some vending machines where you can push 1 for Pepsi, 2 for Pepsi, 3 for Pepsi. That's allowed. Like that, vending machines have multiple options for stock things. That's just how it works. That's fine. You can have multiple inputs have the same output, but no one input can have different outputs. We'll see the different representations. This one is ordered pairs. 3 is x, 6 is y. X, y, x, y, x, y, x, y. When you're looking at this, you're looking to see, do I have repeat x's? And with those repeat x's, do I have different y's? In this case, no. You see no repeat x's. No. No, they don't repeat. Yes, this is a function. Justify your answer. I'm going to say it out loud. Justify your answer. X's don't repeat. If x's don't repeat, then you can't have the same x with different y's. There it is. All right, this other thing here, this is called function notation. This does not say f times x. This does not say f times x or anything like that. You don't need parentheses around that thing. That's not what this says. This is a notation called f of x, function notation. This is still all about functions. Basically, it says when I plug in something for x, I should only get a single value out for y. Where's y in this thing? This is y. Y and f of x are the same thing. There are a lot of different ways you're going to see this, guys. Maybe not on my sheets here. G of x, h of t, all these kinds of things. Your input and your output. I know this looks really weird. You're going to have to go with it. Here's what this says. When it says evaluate f of -2, it says find y when x equals -2. And remember, f of x and y are the same thing. So f of -2 means the y value when x is -2. So what am I going to do? I'm going to substitute -2 for x, like that. Boom. -2 just took x's place. I'm not going to do anything on this side of the equation. This part of the equation says y when x is -2 equals and I do everything on this side. This doesn't change. I don't divide both sides by -2. It's not multiplying. No. Keep this exactly like that. That's it. Point blank, period. Here, I got to do -16. -6 times -2 is +12. -16 plus 12 is -4. F of -2 equals -4. That means when you substitute -2 for x in that equation, you will get -4 for y. That input gives us that output. That means there's an ordered pair on my graph that is -2, -4. Yay! I don't need to write that, but that's what that represents. That's it, and that's all. I am done. I say that like in that way, emphasizing it, because I've had students that screw that up all the time. They divide by -2 here. They don't know what's going on. They replace f of x with -2. Not what we're doing there. And that is skill number 7. That is week number 6 material. Okay, so week number 7 goes up to skill number 8 somewhere. No, it doesn't. That is, maybe it's just the same thing again. Okay, we can go with it. Sorry, I paused for a second just to make sure that I did what I intended to. I think I remember what this stuff was all about now. I believe this I did earlier in the week, and then now we're getting to that. Okay, that's okay. Let's move forward right here. Now it's the same 7 skills, so I'm actually going to go really fast on this one compared to what I had in this previous one on week 6, because the 7 skills is no new one. -6 plus 5 times x plus 2, we're going to distribute there. That is -6x plus 5x plus 10. And I combine like terms there, and that's -x plus 10 like that. Second one right here, there's a lot more distributing to have happen, but you do end up combining like terms in the end when we make it happen. So 6 times 6x is 36x. 6 times 2 is 12. 7 times 7x is 49x. 7 times 1 is 7. Now I can combine like terms, 36 plus 49. Careful on your calculation. I believe that's 85. 85x. 12 plus 7 is 19. Maybe use your calculator right there if you have to. Okay, skill 2. Number 1, solve 3x minus 8 equals 40. Despite the fact that it's a larger number you have to divide by 3 with, pretty good 2-step problem. Add 8 to both sides right there, or pretty simple 2-step problem. Add 8 to both sides right there, and then divide both sides by 3. Now 48 divided by 3 is 16. That's the bigger value we're trying to get there. All right, the second one right here, 7x plus 4 equals 2x minus 3 plus 5x. I want to simplify this side of the equation right there. 2x plus 5x is 7x. And I get 7x minus 3 equals 7x plus 4. This is one of those good instances for why simplifying really helps you recognize what's going on here. You know, move x's to one side of the equation, but look at this for a second. 7x plus 4 equals 7x minus 3. Well, if I'm plugging the same value for x and they're both being multiplied by the same value 7, how will 7x and 7x change on these sides of the equation? They won't. They're the same. So how does some number plus 4 ever equal some number minus 3? Tell you what, it can't happen. And let's further that by subtracting 7x from both sides. 7x minus 7x is 0. They cancel on both sides because we're still left with a 4 equals -3. Now this isn't my answer, but this is a result that I'm getting right now before I move anything over. 4 doesn't equal -3. That's not a true statement. What did that mean? I did correct math. It means no matter what I substitute for x, the left side will never equal the right side. We're trying to solve for x. What value of x makes the left side equal the right side? When no value works, that's a phrase that we call no solution. No solution, no solution. And it's unfortunate because once I introduce that phrase no solution, people start saying no solution whenever you're dividing by something to make a fraction, whenever x equals 0. When it's all real numbers, they accidentally say it. So, you know, it's hard for me to introduce that kind of thing there because then people start using it in places where it doesn't exist. And it exists here when your variables cancel and the left side doesn't equal the right side. All right, skill number 3. I got to keep moving. Skill number 3 right here, -4x minus k equals -2. Solve for k. Now, if I add 4x to both sides right here because it's subtracted, I'm still going to have a -k on this side. -k equals 4x minus 2. Notice how I added it over. It made it positive. But that's a -k. That means -1k. So if I divide both sides by -1, notice everything would divide by -1 over here. What happens when you divide something by -1? The signs change. That's why I wanted to turn a -k to a positive k. You know what 4x turns into? -4x. -2, +2. Sometimes you'll hear me instead say divide everything by -1. I'll just say switch all the signs. That's just another version of that. K equals -4x plus 2. That's 3.1. 3.2, solve G equals 3a minus 2 for G. Oh my goodness, I remember when I first gave this. Listen, that's the answer. G equals 3a minus 2. I don't know how many students I can always trick by having them move terms over. G's already by itself. There's nothing you have to do. There's nothing you have to do. There it is. Mwah, chef's kiss. Favorite question on here. All right, translate these into these kinds of things here. The quotient of 4 and a number is 19. Is meaning the equal sign. Something equals 19. What is it? The quotient of 4 and a number. Quotient is division. I'm going to tend to represent division as fractions here. So the quotient of 4 and a number is 4 divided by a number, not a number divided by 4. There's a difference here. 4 divided by something is 19. We're not solving for what it is. But that's how you write it. Susie has Q quarters. I was going to call her Susie Q for a second. Susie has Q quarters, D dimes, and N nickels in her piggy bank for a total of $6.60. In the equation 0.25Q plus 0.10D plus 0.05N equals 6.60, what does 0.10D represent? Now, the idea here, hopefully, you'd have to kind of know some real-world logic to this thing, kind of like the previous question that had chickens and pigs in their legs. You have to know that chickens have 2 legs, pigs have 4 legs, on a good day. Now, in this case here, you have to know something about the values of quarters, dimes, and nickels, or at the very least, when I write them, what I'm trying to tell you about them. Quarters are valued at 25 cents each. That's $0.25, right? That's kind of how we see cents, right? Point like that. Dimes are 10 cents each, and nickels are 5 cents each. And that's kind of how we see them represented like that. When you add not a quarter with a dime and a nickel, but when you add all these quarters, money, the value of all the quarters, and the value of all of the dimes, that's the answer, and the value of all the nickels, you get your $6.60 you're looking for. That's what 0.10D represents. 0.10 in and of itself, or 0.1, represents the value of a dime. When you multiply it by your D dimes, that's how much money you have in dimes. If I have 8 dimes, that's 80 cents. You multiply. So what does 0.10D represent? The value of Susie's dimes. Not a single dime. Each of her dimes is valued at 10 cents, like all of my dimes are. I have a dime right. I don't have a dime right here. I have quarters and nickels and pennies. But Susie's overall dimes, her D dimes, her 10 dimes, her whatever dimes, is valued at that much money. Okay, skill number 5. A new gaming lounge. This is set up equations and solve. A new gaming lounge offers 2 entry pricing options. Option A is to pay $7 per hour, and option B is to pay an upfront cost of $20 plus an additional $3 per hour. After how many hours would you pay the same amount for either option? So this is one of those kind of rate problems, right? You kind of have a rate going on here when one rate equals the other. Option A is $7 per hour. You enter, and every hour you pay $7. I assume once the first hour starts, you just start paying $7. But we're trying to find out how many hours. After how many hours, this is our unknown. If I multiply $7 per hour by the number of hours I'm in there, that's how much money I'm going to spend with option A. Option B, an upfront cost of $20. I enter by paying $20. Every hour after that, I pay $3. Well, which option would you prefer? That depends. How long will you stay in there? And which one would make you pay less versus more? First, let's figure out how many hours would make you pay the same. Let's solve for x through this. Subtract 3x from both sides, I get 4x equals 20. Divide both sides by 4, I get x equals 5. After 5 hours, you would pay the same amount of money. So the real question is, would you be in there for 5 hours? Less than 5 hours or more than 5 hours? Depends on what I'm playing, I guess. Me, it sounds like 5 hours is a lot, but when you're lost in a game or gaming, you could have long runs easily. I can see a lot of people doing option B because after 5 hours, you're making better use of that time. Better yet, just buy the game. I mean, come on. How much money would you spend after that amount of hours? So after 5 hours, how much would you be spending? You can either look at 7 times 5, which is 35. I was about to say 35 hours, which is $35. $35. Or option B, you should get the same amount, right? Option B, 20 plus 3 times 5. That's 20 plus 15, which is $35. The point is you can use either expression for that answer because we found out which value gets you the same, how many hours gets you the same amount of dollars. Either should confirm it. $35 spent. Okay, skill number 6, proportion. This is a good time really to use that cross multiplication tactic. If I cross multiply x times 2 and 3 times x plus 1, got to be careful with the 3 times x plus 1 though. 3 isn't multiplying with x, 3 isn't multiplying with 1, 3 is multiplying with x plus 1, both of them. 3 times x plus 1 equals 2 times x. In order to solve this, I got to distribute this thing here. 3x plus 3 equals 2x. If I subtract 2x from both sides here, I will get x. But this would say x plus 3. This is where a lot of students will say x plus 3, x equals 3. No, that's not what we did. Where did your equation go? Right now this says x plus 3 equals 0. Don't lose your equal sign there. Subtract 3 from both sides, you'll get x equals negative 3. That's it. Be very, very careful on problems like that. All right, Johan was paid $190 for a job that required 40 hours of work. At this rate, how much should he be paid for a job requiring 60 hours of work? First of all, that ain't much money he's making there. I mean, if I told you right now what that value is, it's less than $5 per hour. Whatever Johan was doing must have been some small student stuff. Little meagerly wages. I don't know what he was doing there. Anyway, he was paid $190 for that job that required 40 hours of work. That is a rate that we can write out. $190 for every 40 hours. So, how much should he be paid? X dollars for 60 hours is the setup. So 190 over 40 equals X over 60, like that. This is one of those things. You could reduce this to 19 over 4 if you wanted to. Let's just go straight-laced. What most students will tend to do here. Just cross multiply. Let me compute that. Hold on. 190 times 60. I don't want to mess anything up here. 190 times 60 is 11,400. 11,400 equals 40 times x. Divide both sides by 40. Excuse me. This is where I would want to use the calculator anyway. You get 285. X equals 285. What was this? Dollars. He should be paid. I mean, we can argue he should be paid more. I mean, that's quite a lot. But quite a lot of hours. But he should be paid $285 at that rate. At that rate. Okay. I might have the hiccups here. Skill number 7, is the relation graph to the right a function justify your answer? Well, the idea behind a function, as I've mentioned in the past, is that every x should only give me a single y value. Remember, a curve or a line is representative of just a series of points. Here's a point, here's a point, here's a point. These are points in the relation. Now, these are not vertically on top of each other. As you can tell, the graph is still moving right. No matter how sharp, it is still moving right. And there's an infinite series of points on this thing. Is there ever a time where there are multiple y's for the same x? At x equals negative 2, is there any other y value other than 0? I would say no. There isn't above. You've got to kind of look above and below it at negative 2. Or at 1, it looks like it's kind of right there at negative 3. Is there any other y value there? No. We use something called the vertical line test, which basically is just this representation that's like, well, if I scan this thing left to right here, you'll clearly notice that this line only hits a single point right here. And that vertical line test, this passes the vertical line test. It's kind of just that way of saying that, well, there's only one x for every single y. Now, there may be multiple x's that have the same y, but every x only has a single y. Sorry if I said it backwards. Sorry if I said it wrong earlier. Every x only has a single y. No x has more than one y, but you can have multiple x's with the same y. Again, sorry if I said it backwards. There was a text thing that popped up in the bottom of my screen. This passes the vertical line test. That's my justification. Yes, it passes the vertical line test. Every x is the same way. Sorry about that. All right, I kind of just answered this earlier. Use the graph to the right to evaluate f of 1. Now, f of 1 means the value of y when x equals 1. Now, we had an equation last time to do this. It was f of x equals blah, 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 blah. And you're going to see a lot of equations like that. We can substitute. Now, we have a graph that's a function that represents it. We're asking, when x is 1, what is y? I just answered this earlier. When x is 1, let's go down. Y is negative 3. So you know what f of 1 equals? Negative 3. The input is 1, the output is negative 3. And as functions go, each input should only have one output. This is a function. It does it. All right, that is it for week 7. Let's go. All right, week number 8. Week number 8, we do have up to skill 7 right there, and then it goes to skills 8 and 9. You know, I could have sworn, I must be missing a page somewhere. That must have had this previous one should have had a skill number 8 question. I don't know where it is. Maybe it did, maybe it didn't. I'm not sure. Let's go ahead and just move forward with that. All right, skill number 1, simplify x plus 2x squared plus 3x plus 4x squared. The first time we've seen x squareds in these problems with simplifying. Let's establish it right now. You do not combine x's with x squareds. They are separate terms like x and y are. X's add with x's, x squareds add with x squareds. You don't do anything to this exponent when you're adding these things. X squared means x times x, but we're not multiplying x's together. We are adding x squareds together. So x plus 3x is 4x. 2x squared plus 4x squared is 6x squared. These do not combine. They stay separate. 4x plus 6x squared. I should have probably written 6x squared plus 4x. We're okay. And that's it. Simplify 5 minus the quantity 6x minus 7. This is not the same thing as 5 minus 6x minus 7. Notice there are parentheses around here. That means this has to happen first. Not that I can combine anything in there, but that subtraction's there. Remember I've talked about distributing negative values into things. Here we could literally just distribute the negative into here. The negative distributes into here. It's kind of the same thing as multiplying these by negative 1. Putting a negative 1 outside there. What's negative 1 times 6x? Negative 6x. What's negative 1 times negative 7? Positive 7. We have 5 minus 6x plus 7. Notice how that sign changed. 5 plus 7 is 12. We're going to get negative 6x plus 12, or 12 minus 6x. That applies as well. All right, skill number 2 is down here. We solve x over 10 minus 1 equals 2. I'd like to get that x term by itself, please. Before multiplying both, see, I don't want to multiply both sides by 10 right now. I could, but you have to make sure that you multiply that negative 1 by 10 as well. Negative 1's not special in not multiplying by 10. You can't pick and choose what to multiply by 10. Everything does. But if I add the 1 over and combine it with the 2 to get 3, now I have less things to multiply by 10, and that 1 that is integrated with the 2 will be affected by the 10 when I do now multiply both sides by 10. And 3 times 10 is 30. X equals, let me write it up here, x equals 30. A purdy, 30. All right, this next problem here has a couple distribution aspects to it. 2 times 5x, 2 times 2. 4 times 2x, 4 times negative 3, they equal each other. 2 times 5x is 10x, 2 times 2 is 4. Over here, we're going to have 8x minus 12 after distribution. I want to keep my x terms positive, so I'm going to subtract 8x from both sides. I'll get 2x here. If I subtract 4 from both sides, I'll get negative 16. Divide both sides by 2, we get x equals negative 8. And that's skill number 2. Skill number 3. Solve 2a plus b equals a minus b for a. Let's write that down below here. 2a plus b equals a minus b. I need to get a by itself on its own side of the equation. Just like the x's on this last problem right here. I got x's by itself on one side of the equation. I want to keep my a's positive just like I kept my x's positive. Let's subtract a from both sides. Minus a here goes away. 2a minus a is 1a. Now I have an equation that says a plus b equals negative b. Where'd your a go? I just subtracted it. A minus a is 0. And we did that. Now I'm going to subtract b from both sides. Minus b minus b. B minus b is 0. Negative b minus b, let me write this one. Negative b minus b is negative 1b minus 1b. That is negative 2b. Whoops. Negative 2b. A equals negative 2b. That is the answer to the first guy. The second guy here, we got to solve for y. We've seen a bunch of these before. This is very much in one of those slope-intercept form. It's standard form right now, but I want to get in y equals mx plus b form. I'm going to subtract 6x from both sides to solve for y here. 2y equals negative 6x minus 10. And then we divide both sides by 2. And what happens when I divide both sides by 2? Everything divides by 2. Over 2, over 2, over 2. Y equals negative 3x minus 5. I almost put minus 10. I was going to say, you could write it as all over 2, negative 6x minus 10 all over 2. But since they can divide by 2, I really want to write that. This is very truly in slope-intercept form. It doesn't mean anything for you guys right now if you haven't yet learned it, but you'll pick up on it very shortly if you're at this stage with me. Skill number, where's 4? Here it is. Translate the following sentences right here. 9 more than triple a number. Sounds like an expression to me. I don't see is anything. 9 more than triple a number. Well, triple a number, we take some x and triple it. And we take 9 more than that. 9 more than that right here. Now you might ask, Mr. Robinson, I put 9 plus 3x. Is that correct? Well, maybe that's not the question I want you to ask. The answer to your question is yes. But the question you should be asking is, Mr. Robinson, should I write this? To that I'll say the answer is no. Remember, they're the same thing. Why do I not recommend that? They're both correct. Why do I not recommend you write this? Because what if it said 9 less than triple a number? 9 minus 3x don't fly. Only 3x minus 9 flies. 9 less than, you subtract 9 from it. You want to think of 9 more than as you add 9 to it. So 9 comes after the fact. Both are correct. But I'm always going to encourage and recommend this right here. All right. Mr. Robinson has already scored 32 points after the first half of the student staff basketball game and scores another 5 points every minute afterward. So when I made this question, it was off the heels of actually playing in that student staff basketball game where I not only didn't make a single shot, but I maybe shot 4 times and I airballed and bricked and I think I shot over the backboard once. Mr. Robinson don't play basketball, but even if he did, pressure was on, everyone was watching. I tried to shoot over this really tall guy, adrenaline kicking in. It was a girls' basketball. No excuses on that part, but just, I'm terrible. I think this was probably what the whole staff was doing, scoring. I wasn't. Good lies can fit into quizzes, though. All right, Mr. Robinson's already scored 32 points after the first half. Every minute afterward, so in the second half, I'm scoring buckets, 5 points per minute afterward. Let's write an expression for how many points I've scored X minutes into the second half. So I've scored 32 points to start off so far in that first half. Now, going into the second half, how many total points have I scored? X minutes in the second half. So we're not counting first half minutes, just second half minutes. Then I add 5 points per minute times the number of minutes that I've been out there scoring buckets. And that's an expression for me. So if it's 10 minutes into there, I scored another 50 points on top of 32. I've scored 82 points. I'm Kobe Bryant, baby. Look at that. That's pretty unrealistic there. So even for the teachers. All right. Skill number 5, set up equations. Now my school, Rio Americano, rival school El Camino. Rio Americano and El Camino are receiving donations for a shoe drive. Rio Americano has received 100 pairs, of shoes. I got to edit that for a future time. 100 pairs of shoes and received an additional 12 pairs of shoes daily. And El Camino just started their shoe drive and received 16 pairs of shoes daily. How many days? One of those rate questions. How many days will it take both schools to receive the same number of shoes? So X is the number of days, right? How many days? This is our X. X is the number of days that will have passed by. Now, Rio will have an expression for themselves for how many pairs of shoes they've collected over the number of days by. We've already received 100. And hopefully you understand why I'm writing this right here. But we've already received 100. We get 12 more pairs of shoes a day. When you multiply by the number of days, this is how many pairs of shoes we'll collect in total. El Camino just started their shoe drive, so they haven't collected any yet. But they are going to collect 16 pairs of shoes daily times the number of days right there. How many days will it take for us to have the same amount? For the left side to equal the right side. Subtract 12x from both sides, you get 4x. Divide both sides by 4, you will get 25. That's x equals 25. It'll take 25 days. 25 days for the same amount. Now, I didn't ask how many pairs of shoes for the next thing. This next question is completely different and isolated. Cassie and Bernice are competitive team bowlers. In their most recent game, they scored a total of 410 points, and Cassie scored 64 points less than Bernice. How many points did Cassie score? Now, a perfect game is 300, so if they combined, they would have gotten 600. So they're not perfect. Oh, who is? Okay, they scored 410 points total. Cassie scored 64 points less than Bernice. So this is one of those totals kind of things. Cassie scored so many points, Bernice scored so many points. Let's say Bernice scored I don't know, B amounts of points. B for Bernice. Cassie, you don't just want to put C. We want to compare. Cassie compares to Bernice. She scored 64 points less than. And we just talked about how less than works here. Less than is subtracting 64 from it. If Bernice scored B amount of points, Cassie scored 64 less than B minus 64 points. Okay, there are expressions for both of them. When we add these scores together, we get 410. So it's not just B minus 64 equals 410. That's just Cassie's score. You got to add Bernice's score, and they add to 410 points total. B plus B is 2B. 2B minus 64 is 410. I'm going to go kind of fast here, guys. You can work the math after. 2B equals 474. You divide by 2. B equals 237, I believe. I hope so. I hope that's right. B equals 237. That's Bernice's score. That's Bernice's score. They asked how many points did Cassie score. So you can do this one of two ways. You can subtract 237 from 410 or subtract 64 from 237. Cassie is B minus 64. That's 237 minus 64, which is, 173 points. I hope I did that correctly. The idea is intact if I didn't calculate that correctly. My bad. I think it is. Sometimes my addition and subtraction are much worse than my multiplication and division. All right, skill number 6 here. Proportions. Solve. X over 2 equals x plus 5 over 5. Let's cross multiply right there. We get 5 times x equals 2. See, as I do more of these quizzes, guys, I am going to go significantly faster. I feel like I'm going at a snail's pace still right here. Subtract 2x from both sides, you get 3x equals 10. Divide both sides by 3, you get x equals 10 over 3. Now, this answer is perfect. I would not want 3 1/3, which is exact, but no mixed numbers. I do not want 3 1/3, 3.3 repeating, 3.3, 3.33, or 3. Those last few are approximations. 10/3 is perfect. This is a non-contextual problem. Exact answers, improper fractions, as long as they're reduced, are perfect. Leave it be. If it's contextual, like money or something like that, it may change. It all depends on what's asked. All right, a person who weighs 200 pounds on Earth would weigh about 32 pounds on the moon. Facts. Find the weight of a person on Earth who would weigh 15 pounds on the moon. So let's set up a proportion. 200 Earth pounds, Earth, is equivalent to 32 moon pounds on the moon. So find the weight of a person, X pounds on the Earth, if you weigh 15 pounds on the moon. They should be in proportion, right? It grows and shrinks those amounts. So 200 over 32 equals x over 15. Let's cross multiply. Red doesn't mean wrong. It just means it stands out. 15 times 200 is 3,000, to my knowledge, equals 32x. We divide both sides by 32. I was trying to find a personal calculator. I don't seem to have one. Let's make sure 200 times 15 is exactly what I wanted. And divided by 32, I'm getting 93.75. And I want that exact answer like that. I don't want 33,000 over 32 or reduced. This has context. This is weight. 93.75 pounds on Earth. I actually want that exact one right there. Hopefully you can tell the difference in context when decimals kind of seem to make more sense when you're telling somebody about their weight. Like in a good way. Okay, does the following table represent a function? Explain why or why not. You have x's and y's, like that's like 2, 0 and 5, 5 and things like that. What we're looking for are, in a table and such, repeat x's. Repeat x's isn't the only thing, but we are looking for repeat x's. 2, 5, -1, 1, -2, 0, 3, -1. -1 repeats here and here. I don't know if there were other repeats, but they repeat there and there for x, and they have different y's. Different x's, same x with different y's is a problem, not a function. Not a function. I'm just going to explain out loud to you. The same input gave 2 different outputs. Same x gave different y's. Repeat x's, different y's. That's not a function. If f of x equals 2/3 x minus 1, evaluate f of 6. Well, f of 6 is going to be 2/3 times 6 minus 1. So we substitute, and then we evaluate this. Don't do anything to that side. except just keep rewriting it. 2/3 of 6 is 4. Now, a couple ways you could do that. 6 is 6 over 1. 6 is multiplying with 2 and dividing by 3. So you can do 6 times 2 is 12. 12 divided by 3 is 4. Or my personal favorite, 6 divided by 3 is 2, and 2 times 2 is 4. I like to divide first, personally, because it makes the numbers smaller. It lets you work for fractions the way that they're supposed to be working themselves out. And I can reduce it along the way like that. So anyway, 4 minus 1. Maybe you just know 2/3 of 6 anyway. 4 minus 1 is 3. 1x is 6. Y is 3. That's what f of 6 is. Done. Now that's the end of this page, but not this week's stuff. I got 2 more skills to work with, and I maybe they were the first time I introduced both of these. They do work hand in hand. Now, skill number 8 is just on slope. Slopes of lines. Not full equations, but just really asking about slope. Find the slope of a line in the equation y equals x plus 5. Without getting too detailed, y equals mx plus b is something called slope-intercept form. It's the equation of a line where m represents the slope. It's written as some sort of rise over run. We'll get into them when we start doing some graphs. B represents what's called the y-intercept. This does not yet matter for ourselves until we hit skill number 9, which will apply next year. But the slope is the m. Y equals x plus 5. X is also 1x, or 1 over 1x. The slope, m, equals 1. We'll talk about what that means, or 1 over 1. We'll talk about what that means when we do other problems. Find the slope of the line that passes through the points -1, 4, and 5, -6. Now, graphically, without huge graphs on these, because otherwise I'll spend all day on them, -1, 4 is somewhere up here. And 5, -6 is somewhere down here, if you understand how your Cartesian coordinate system works. There's a line that goes through these 2 points kind of like that. Whatever. We're trying to find the slope of it. Slope is this rise over run concept, or a fall over run. As we run to the right, does our graph go up and down, and by how much? And how much does it run over that time as well? So we're trying to figure out how much we go down as how much we go right. It's kind of a rate kind of thing. We lose $2 every hour, kind of thing like that, right? We're falling from a y value of 4 to a y value of -6. You just lost 10 in y. Where we gained from -1 to 5 on x, we just went over 6 right there. The slope is -10 over 6, and that reduces to -5 over 3, like that. You could count that. I'm going to show you another version of this with subtraction and a slope formula in a moment right here. But you have to reduce the fraction. This is definitely where you want exact, improper fraction, reduced fraction, things like that. No mixed numbers here, no decimals here, period. This is the perfect. If the other answer was perfect before, this is the perfect answer now. Now your slope formula is y2 minus y1 over x2 minus x1. What did I just say here? This was rise. Change in your y values. If I have a y value right here, and a y value right here, I can subtract them. The slope is y2, -6, minus y1, 4, divided by x2, 5, minus x1, -1, 5 minus -1. Where have we seen these values before? -6 minus 4 is -10, and 5 minus -1 is 5 plus 1. That's 6. We just saw it right here. The distance between your y values is the difference of them. Subtract one from the other, and subtract 1x from the other. Does it matter which x's I choose as x1, x2, and y's I choose y1, y2? Not fully, but whatever I choose as x1, I must choose as y1. I could have chosen this as x1, y1, and x2, y2. You'll get the same sign if you work that out correctly. And there it is. Now, I gave you a rough sketch of a graph as well. We'll probably have some that are actually on a graph, and we can count it, and that's all I'll do for those. All right, skill number 9. They ask us to sketch the graph. This is where I'm going to need a graph. Every time we hit skill number 9, the first question will be a graph sketch. So I'm going to pop this up right there. Hopefully you can see that. Yep. All right, skill number 9, sketch the graph of y equals -1/2 x minus 2. So this is your y equals mx plus b form right here. And I just mentioned this up above. M is your slope, b is your y-intercept. Without spending too long on this, the y-intercept is the value of y when x equals 0. It's where it crosses the y-axis. This thing has a y-intercept of 0, -2. That's what the -2 is doing there. This graph crosses at -2 right there. If I plug in 0 for x, that's exactly what I'll get for y. Now, there are certain values you can plug in for x to get other y values out, but we can also utilize this slope of -1/2 to do exactly that, which basically says this. Every time the graph goes down 1, it'll go right 2 units. from here, if I go down 1, I'll go right 2. Down 1, right 2, down 1, right 2. Now my mantra for my students is plot as many points as you can fit in both directions. If I go up, I can also go left as well. Up 1, left 2, and follow this pattern. This is known as a negative slope when it goes down and right and up and left like that. That's a negative slope. Think of it as in like a word problem if there was time. As time goes on, what's occurring in this thing? Well, exactly that. Exactly that. And then you draw a line through it. See, the points were to simulate the most accurate line we could draw. The line represents all the points that it can be. Not just the integer points that we had, but that's all of them right there. Okay, write the equation of the line in slope-intercept form. That's y equals mx plus b, right there. Given the following information. A slope of 5 through the point -4, comma -24. Now, the slope of 5 means that's your m. Your goal of slope-intercept form is find m and b. We have m. We don't have b. b is the value of y when x equals 0. b is that part. It's not going to be 5x minus 24, because that's when x is -4. But what we can do is we can kind of simulate. We have an equation for y equals mx plus b where the m is 5. If only we could find out b. Well, guess what? We have an x and a y right here. What if we substitute -24 for y? And I'm not getting very, I acknowledge, I'm not getting very deep in this problem compared to, like, as far as explanation, what I'm doing other than process. And what if I substituted -4 for x? And by the way, that is a multiplication. Now all I have left is b, and I can find out what b value works. And I'm going to explain this as I'm writing this out, adding 20 to both sides. B is -4. What I did was I substituted what is known as a solution to this equation. By the way, that's not my full answer. I have to write the equation. This equation right here, y equals 5x minus 4, is not only something that I can graph and say, here's the slope and y-intercept and all that, but it means for any x, y value that exists on this graph, I can substitute values for x and y, and the left side should equal the right side. If I substitute -4 for x and -24 for y, it would check out. Left side would equal right side. There are other points that work as well, such as 0, -4, and other things. And this one has a bunch of them as well. I could substitute, what is this? 6, -5. I could substitute 6 for x and -5 for y in this, and the left side will equal the right side on it because it's a solution to it. It's a point that's on the line. And that's what -4 and -24 allowed me to do. Find out what b, given that slope with that solution, would work, and it was -4. So that's what you do. Substitute into y equals mx plus b form. You'll learn another one in time, but that's a good one. All right, and that's all of them for week number 8. Week number 9, skill number 1, simplify x plus x minus x plus 1x minus 1. Well, 1x plus 1x is 2x, minus 1x is 1x, plus 1x is 2x, minus 1 is 2x minus 1. Remember, those don't combine. Distribute right here. 4 times 4 is 16. 4 times -3x is -12x. Then we have a minus 3x right there. That was it was unaffiliated with the 4. It wasn't distributing there. -12x minus 3x is -15x. So you get 16 minus 15x. Kind of speedier than previous problems I've done. Skill 2. 5x equals 33 minus 6x. If I add 6x to both sides of this equation, I will see it say 11x equals 33. And if I divide both sides by 11 there, I will get x equals 3. Yes, the speed is coming. 10x minus 1 minus 7x. Unsimplified. Let's do 10x minus 7x to get 3x minus 1. No, we're not done with the problem. I'm just simplifying this equation. Equals 2 plus 3 times x minus 1. I have 2 here. Don't add it with the 3. You're going to add it with whatever 3 distributes into. 3x minus 3. As we distributed 3 into right there. Now 2 minus 3 is -1, so I'll get 3x minus 1 equals 3x minus 1. Oh, we've seen this before. Whether or not you choose to subtract 3x from both sides, if I subtract it now, I'll get -1 equals -1. The basic blanket statement is this. Anything works for x, all real numbers. I've stated this before. I'm going to kind of state again. No matter what I substitute for x, the left side will always equal the right side, but I need this statement right there to lay claim to that. All right, skill number 3. Let's solve for z when x minus y equals y plus z. Well, it's straightforward. I can subtract y from both sides. The y's cancel out here, but -y minus y is -2y. So x minus 2y equals z. And I'm just going to fit that right there. That is the answer, subtracting y from both sides. Don't overthink it. If it's adding with y, adding with z, subtract it. Solve a equals 1/2 base times height for h. Now we've seen something before where something was multiplied by 1/2. And multiplying by 1/2 is the same thing as dividing by 2. So maybe instead it might help to rewrite it as b times h all over 2, because that's what's happening. I don't know. Maybe it does, maybe it doesn't. That means I should multiply both sides by 2 here at some point. I am trying to get h by itself after all. 2 times a is 2a, and here I have b times h. b times h. Let's divide both sides by b like that, and we will get h equals 2a over b. h equals 2a over b like that. Literal equations. They're so fun. I understand them. Skill number 4. 9 is greater than triple a number. Now what's interesting is if you saw our last quiz or last thing, it said 9 more than triple a number. Is this the same thing? 9 greater than triple a number? It doesn't say 9 greater than triple a number. It says 9 is greater than triple a number. Normally you see is and you think equal sign. No, is a part of the barrier between two expressions. But this whole phrase is greater than is its own expression now. Is greater than is literally where we see that greater than inequality, like that. This guy right here. 9, this left expression, is greater than triple a number, like that. This is an inequality this time, and it looks like that right there. At a fast food restaurant, a burger costs $3.25 and a milkshake costs $2.50. You and a large group order B burgers and M milkshakes. Write an expression representing the total cost of your order. Okay. B burgers times $3.25 per burger is 3.25B. We add it with all our milkshakes, 2.50 M. And that's how much we're going to spend there. 10 burgers would be $32.50. 10 milkshakes would be $25. And you add those together, that's how much. That's not how much there are. Maybe there are. I don't know. They're variables. But that's all it is as an expression. Sorry about this. I'm very crick in the necky. Oh, it happens. Oh, it happens. Okay. Set up equations for each situation here. You want to buy 8 posters online, and the website you're ordering from charges $15 for shipping. That's a flat shipping rate. So I buy the 8 posters, or 1 poster, or 80 posters. I'm just going to pay $15. The total cost is $103. How much would each poster cost? Okay. So the idea is I paid a total of $103. I paid a total of $103. So something equals 103. That's the 8 posters I bought times the cost per each poster cost. That's the cost per poster. Then I paid $15 for shipping on top of it. So if I take away the $15 of shipping, then you see how much I spent on all 8 posters. If I divide by 8, you'll see how much I spent on each poster. 11. 11 what? $11 right there. All right, totally different question. Olivia and Shay collect rocks. Together they collected 50 rocks. Olivia collected 10 more rocks than Shay. How many rocks did each of them collect? It's not like they collected 50 rocks, so 25 each, and then Olivia collected 10 more. No. Together they collected 50. And within that 50, Olivia has 10 more. Now, this could be a very easy answer. I think we know that's probably 30 and 20. That's not what we're trying to get to, though. We're trying to set it up algebraically. So we got to figure that out. We're comparing Olivia to Shay right there. So Olivia and Shay. Now, the problem with these names is if you say Olivia's O or Shay is S or something like that, O looks like 0 and S looks like 5, at least my 5s. So we want to do it a different way. If Shay collected X rocks and Olivia collected 10 more than it, then Olivia collected X plus 10 rocks like that. So I'm just going to use X. Okay, so if I add their total, X plus 10 with X, we get 50 rocks in total. Add X plus X is 2X. We can subtract 10 from both sides. We get 2X equals 40. Divide both sides by 2, we get X equals 20. Now, what does 20 represent? The amount of rocks that Shay collected. It asks how many rocks did each of them collect. So I'm just going to fit it down here. Sorry. Shay collected 20 rocks. And Olivia collected 10 more than that. 20 plus 10, 30. And Olivia collected 30 rocks. 30 rocks from the sun. 30 rocks from the sun. All right, there we go. Okay, that is skill number 5. Skill number 6 is proportions. Now, is this a proportion? I don't see a fraction on this side. 2 equals x over x plus 1. More than one way to solve, but I do give a hint. You may write it as a proportion by turning 2 into a fraction. How do you turn 2 into a fraction? Do 2 over 2? No, 2 is 2 divided by 1. 2 over 1 equals x over x plus 1. This gives people the perception of, oh, I cross multiply. Multiplying something by 1 doesn't change its value, but it gives you a better perception of what the problem is doing. 2 times x plus 1, remember parentheses, equals 1 times x like that. We still got to distribute. 2x plus 2 equals x. Now I'd like to subtract x over here and get x, but remember that is x plus 2 equals 0. I got to subtract 2 to that side as well. X equals negative 2. If I subtract x to one side, I subtract 2 to the other side right there. There's still an equation. I got to keep it intact. That's the value. All right, number 2. If 2 pounds of meat will serve 5 people, how many pounds of meat will serve 13 people? I want an exact answer here. All right, 2 pounds of meat for 5 people. I'll just put peeps. Equals how many x pounds for 13 peeps? Let's just cross multiply right off that for my time's sake. 13 times 2 is 26 people pounds. And 5 times x here. If I divide both sides by 5, this is one of those ones where, although I said exact answer, I don't want the fraction. When I say exact, I actually want a decimal. This is context. 26 fifths pounds of meat? No. 26 divided by 5. That is 5.2. 5.2 pounds of meat. Just like that. Just like that. That's how you want to say it. All right. Skill 7. Does the following mapping diagram represent a function? Explain why or why not. All right, so a mapping diagram, very simply put, is this. These are your x values, these are your y values. Now, they say domain and range, which is something else we're going to have to get into, like really soon. But domain and range, very specifically, only list every element in them once, meaning if there are repeats, they don't list them more than once. And better yet, they list them in numerical order, in ascending order, as to just keep a good order for them. Or they try to. I try to, for sure. That's a good practice. But they do not repeat their values. I'm not talking about mapping diagrams. I'm talking about domain and range. You don't repeat. The domain says what x values exist in your thing. Range says what y values exist. If I don't say 2 exists and 2 exists and 2 exists, no, you just say 2 exists. How many times is a different question. 2 exists, period. Anyway. The next part about a mapping diagram is the mapping portion of it. Mapping means drawing an arrow from one to the other. Input goes to output. Maps, right? -1 goes to 5. That means there's a point that's -1, 5. 0 goes to 3. There's 0, 3. 1 goes to 5. That's 1, 5. 2 goes to 11. And 3 goes to 21. They don't always go in ascending order like that, but hey, they are. As you notice, there are no repeats in x. Therefore, this is a function. I can say that straight up. No repeats in x. But you can also tell in the mapping diagram, nothing in the domain ever maps to different elements in the range. And remember what I said. There are no repeats on these things. But there was a repeat right here on y. -1, 5, and 1, 5. Don't worry, it's a function. I'm just saying that you saw y's repeat here, but they didn't repeat here. So in a mapping diagram, when something's not a function, what you would actually see is an arrow split, like 2 going into 5 and 11. 2, 5, 2, 11. That would be not a function, because the same element in the domain that won't repeat will map to different elements in the range, and this one's fine. Yes, this is a function. You're good. All right, in the mapping diagram, if f of x equals 3, what is x? So we learned some function notation stuff before, like f of 3. If I ask what f of 3 equals, this is a different question. If I ask what f of 3 equals, that would say you plug in 3 for x, what do you get for y? That would be 21. That's not what this is asking. This says f of x equals 3, what is x? They're asking, if you substitute something for x and you get 3 out, what did you substitute? Or what was your input? 3 was the output. The input is 0. Do you see that? If y is 3, then x is 0. That is the answer right there. It's not this one. This is a good question too. But notice the difference between the questions. This means y equals 3. What is x? There it is. All right, let's move on to skill number 8. This one says find the slope of the line in the graph to the right. Now this one is clear as day, shown for you. Looks a lot kind of like the last graph that we kind of had, where we fall we fall. And we can actually count this right here, but I'm going to draw what's called a slope triangle. Slope, rise over run. And we're going to see that we go from 4 to negative 4. That should go down 1, 2, 3, 4, 5, 6, 7, 8. Down 8 right there. Down is negative. Left would be negative as well, but we're going down as we go right. We're going from negative 1 to 4. That's over 1, 2, 3, 4, 5. Notice that you don't count the point that you start on, just how much you travel. So from here is 1, 2, 3, 4, 5. Now they ask for slope. The slope is still your rise over run. It's an m value. It is negative 8 over 5. Rise over run is negative 8/5. Boom. Number 2, find the slope of the line in the equation negative 2x plus 3y equals 6. Okay, you've seen some y equals mx plus b equations before, but this is not y equals mx plus b. Be careful. M equals negative 2 ain't the answer, or at least you can't just expect it to be the answer, because this isn't in slope-intercept form. Trust me, y being by itself and the number multiplying by x is the true revelation of your slope. It's nothing other than that. So until you get y by itself right here, then you don't know for sure what it is. How do you do it? Think about skill number 3, literal equations. There are a couple times where I hinted at the fact that you would sometimes have to get in slope-intercept form. So what do? We add 2x to both sides. We get 3y equals 2x plus 6. Then we divide both sides by 3. And remember, everything divides by 3, and I want to divide them separately. This is truly where I want to see y equals mx plus b for what it is. This is y equals 2/3 x plus 2. Now, this is slope-intercept form. I'll be honest, I couldn't care less about the y-intercept. They asked about the slope. The slope is m, and m is 2/3, not 2/3 x. X is not a part of your slope, and I must specify that. X is not a part of your slope. Your slope is 2/3. That's where we got it. It was not negative 2. Once y was by itself, you could recognize what it was. Okay, skill number 9. Sketch the graph of y equals 3x. Gladly. And I will, of course, inherit a graph. Set of graph axes right there. Sketch the graph of y equals 3x. Now, when it comes to slope-intercept form, that is y equals 3x plus 0. 0 being your y-intercept. We are actually going to start right at the origin right there. Now, that is a b value of 0, 0. When x is 0, y is 0. The slope is 3, but I like to write it as a fraction, up 3 over 1. 3 is 3 over 1. It's not 3 over 0. It's not 3 over 3. It's you rise 3, 1, 2, 3. You run 1 and plot a point. Notice it's a positive slope, up and right. Rise 3, run 1. Rise 3, run 1, and plot as many points as you can fit. Fall 3, run 1 to the left. Fall 3, run 1 to the left to maintain the positive slope. See, this goes negative over negative. That's positive still. That still pans out. And that's what we have as a graph right there. Close enough. All right, number 2, write the equation of the line in slope-intercept form given the following information. You go through the points 1, 12, and 10, 3. Now, tell you what, we could simulate what this would kind of look like, but I'm not going to use this graph to answer it. So, like right here, 1, 12 would have been like way up here, and 10, 3 would have been like way over here. So, as far as you can tell, what it looks like is, just as far as predictability goes, the slope will be negative, and the y-intercept will be somewhere probably more than 12. So at least I can have expectations for things, but I don't want to do this with this graph, especially when it falls out of window range. Let's do it algebraically. But you can see what to expect. A negative slope, not too sharp, not sharper than 3 it looks like, and a y-intercept around 12, maybe a little higher. So how do we figure it out? How do we figure it out? We need m and b, y equals mx plus b, and we don't have either. Now, before we were given m on a previous problem, we've also found m with 2 points, and that's what we're going to do. We have an x1, y1. We have an x2, y2. Slope is y2 minus y1 over x2 minus x1. Slope is 3 minus 12 over 10 minus 1. That is negative 9 divided by positive 9. That is negative 1. Negative 1 over 1. The slope's negative 1. That's not the answer. That is the m. We still need b. Now, b, we've mentioned before. In y equals mx plus b form, I currently have y equals negative 1x plus b, or negative x plus b, right? If I write this, is that okay? Negative x plus b? I hope so. We have 2 different sets of points we can choose from, either 1, 12 as xy or 10, 3 as xy. Honestly, it doesn't matter. Just like those word problems where for what value will they be the same, and what is that value? You can plug it into either. I could plug 112 into here, 1 for x and 12 for y, just like that. And I'll get some b value. If I add 1 to both sides, I get b equals 13. Or in y equals negative x plus b, if I substituted 10 for x, and this is probably the only time I'm going to do both of them, 10 for x and 3 for y, like that. If I add 10 to both sides, I get b equals 13. So you get the same b no matter what you do right there. Awesome. We're still not done. Write it in slope-intercept form. Y equals mx plus b. Y equals negative 1x or negative x plus b plus 13. Now, what were the two things I predicted about this problem? The slope would be negative, and it would be just above 12. Yes, it was. Okay, skill number 10. This is a new one. Now, this one kind of varies. It is interpreting and analyzing graphs. Some of them you're finding the domain and range. That's a big part of it. And some of them is you have a story. And what does the story tell? You know, what's going on in the situation? Can you draw something? Can you make sense of the situation? Within domain and range, because my students learned domain and range a little bit earlier with inequalities, it is, or functions I should say, they did inequalities at the time. Provide the domain and range of the graph. You also figured out whether graphs were called continuous versus discrete. This is known as a continuous graph because I can draw this whole thing without lifting my pencil from the paper. A discrete graph is something where I have like a point here and a point here and a point here and, you know, like that, whatever. That'd be discrete. This is continuous. And in a continuous graph, that means it touches every point along the way. Now, this is not a function. Oh, well, this is not a function, but it's continuous, which means it hits every point along the way. From what x to what x? That's going to be the domain question. It hits an x as far right as negative 2. And as you can tell, it hits to negative 3 and negative 4. And notice I'm kind of scanning right here. I'm saying, what x values do I hit? Notice I go here. I hit these x values. I hit these x values right here. Or I should point it the other way. I hit these x values here of negative 8 and negative 6 and negative 4. So really scanning left to right. I hit as far right as negative 2 and as far left as negative 8. Now notice there's an open circle on negative 8, which is a big dealio. Negative 8 don't count. It goes as far left as negative 8, not including negative 8. Negative 8's got to be less than all the x values we choose. And x can go as far right as negative 2, and it can include negative 2. This is known as domain. And I know this is going to be a little struggling for you to look at. Some people have a lot of questions. Unfortunately, as far as time's sake, I'm going to move on. You're going to see more questions like it. Hopefully I can address them. The range asks what y values exist for this thing. How low does it go? How high does it go? The lowest y value we see is negative 4. Now, it doesn't actually hit negative 4 because of the open circle, but it keeps going up from there. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and everything in between because it's continuous, and it happens to also hit 2. It goes as low as negative 4, does not include it. These are for y values. It goes as high as positive 2. It does include it. So what you got to figure out for these things right here for domain and range is you really got to look at x versus y. Look at these values here and compare them to the points on the graph. And the curve is points on the graph right here. The open circle negates points on the graph. It goes as far, as close to that, but doesn't hit the actual value itself. And these are also known as compound inequalities. You'll see those more as we move on. But we will move on to number 2. This is a situation. Let's see which graph works it out. A candle burns at a constant rate over the course of 8 hours. If x represents the amount of time the candle is burning and y represents the height of the candle, which is the most appropriate graph for the situation? Explain why. All right, when a candle burns, its height shortens because the wax melts. So, over time, as time goes on, you should lose height in the candle. This is height over time. This situation shows the candle at 0 height at 0 time, and as time goes on, the candle gains height. That doesn't seem to make much sense there. This one shows what's called a discrete relation between the candle's height and time, which means time isn't recorded and height isn't recorded at each instance, just at these ones. That doesn't really make sense because that's assuming that there's no time in between and there's no height in between. It just goes and not like that. That doesn't really seem to make sense either. C kind of makes sense there. It's continuous and it goes down, but it did mention it burns at a constant rate. This one seems to look like it melts a little faster earlier on, and then it slows its melting rate over time towards 0 like that as time goes on. It doesn't work because it's not a constant rate. It seems like it's D. It melts continuously and at a constant rate right there. That seems to be the thing. Continuous and constant and melting. Okay, and there's that one. And that is skill number 10 for this week 9 right there, and that will be that for week 9. All right. Now, there was this fall semester midterm that I did here that did all of weeks skills 1 through 10. Unfortunately, I'm going to go through these rather quickly here. Now, what it will show are the actual guys here, simplifying expression. When I say quickly, I mean I've taught it. I've taught these. So let's move on. 9 plus 2x is 11x, minus x is 10x. You combine like terms there. Negative 5 plus 3 is negative 2. Hey, that's pretty fast. By the way, this is all the room in the world because I required my students to do all the problems. So I'm going to have a bunch of room for these guys. 8x plus 2, this can distribute. 2 times 3x is 6x. 2 times negative 1 is negative 2. 8x plus 6x minus 2 plus 4. 8x plus 6x is 14. Negative 14x. Negative 2 plus 4 is 2. See how long I can use blue for without bothering you guys. Solving equations, skill number 2. Let's solve this guy right here. If I subtract 5 from both sides, that's cool. Just make sure you know that 10x is still negative. 25 minus 5 is 20. And I'm going to divide not just by 10, but by negative 10. 20 divided by 10 is 2. 20 divided by negative 10 is negative 2. You can double check it. It should work out. This one here, let's simplify the left and right sides of this equation here. I got 7x minus 4x to get 3x. I have 3x plus 3. If I distribute 6 into here, I get 6x plus 6. Remember, it's a distribution of. Subtract 3x from both sides to keep the x terms positive. That's a personal preference of mine. Subtract 6 from both sides over here. 3 minus 6 is negative 3. Divide both sides by 3 here. You will get x equals negative 1. Yes, I wrote the x on the left side. Deal with it. All right, skill 3, solve A equals B over C for B. Now, you have options here. You could write it as a proportion if you want. A over 1 equals B over C, and then we cross multiply there. 1 times B is B, A times C is AC, and that is the answer, B equals AC. Or literally, as A equals B, C, right, B over C. Don't write it as a proportion. Just know that B is dividing by C, so let's multiply both sides by C to figure out. C times A is A times C, and we get the same answer. Number 2, y equals 3x minus 2 for x. That's slope-intercept form, but this equation don't care. It's asking you to solve for x this time. Get x by itself. It's multiplied by 3, and that's subtracted by 2. Let's add 2 to both sides to start. We get y plus 2 equals 3x. And then we divide both sides by 3. Now, in dividing both sides by 3 here, you have options. I'm going to leave it as y plus 2 all over 3. You know, unlike slope-intercept form, this ain't that. So I'm not curious to write 1/3 y plus 2/3. I just like it like that. We're good. But everything does. Divide by 3. All right, flip the page here. We got skill number 4, writing expressions from words or a table. Translate these things. The sum of twice a number and 9. Okay, the sum of twice a number and 9. We are going to add twice a number with 9. This is not twice the sum of a number 9. See, twice the sum would be twice the sum of a number 9. That's a different story. This is the sum of twice a number and 9. Okay. A football team scores T touchdowns and F field goals in a game. If each touchdown is worth 7 points and each field goal is worth 3 points, write an expression for the total number of points the football team scores in a game. I know touchdowns are 6 points each plus the field goal. Get over it. All right. Each touchdown is 7 points. If you multiply 7 points per touchdown by the number of touchdowns T, then you get how many points you scored in touchdowns. If you multiply 3 points per field goal times the number of field goals made F, you get how many points are made in field goals. When you add the number of points from touchdowns with the number of points from field goals, you get the number of points scored in the game. That is the expression, 7T plus 3F. All right, skill 5, write equations and solve word problems. A YouTube channel has 337 subscribers and gains 13 new subscribers every day. How many days will it take for the YouTube channel to reach 1,000 subscribers? So you have 337 right now, meaning if no days pass, no new subscribers are earned. If you don't get any new subscribers, then you're going to keep 337. But we are going to gain. We're going to gain 13 every day. Maybe you lose some along the way, but pretend like just at the end you have 13 more than the previous day. How many days? How many days? This is our x right here. We do not know. We're multiplying 13 subscribers per day times the number of days. When you add this amount of subscribers you have, we're going to figure out how many days it'll take to reach 1,000. Here's our equation. Subtract 337 from both sides, and that's, I hope, 663. I don't know if that's right or not. Divide by 13. 663 divided by 13. Let's see if it's a clean number. If not, then I subtracted incorrectly. Divided by 13 there is 51. 51. It'll take 51 days, less than 2 months, to reach 1,000 subscribers at that rate. It's a pretty good rate. Hopefully your channel starts growing exponentially after that, not just linearly. Rio Americano High School has 28 less seniors than it does juniors. If there are a total of 978 upperclassmen, how many juniors are there at Rio Americano? Okay, upperclassmen is juniors and seniors combined. So if there are, X juniors, X seniors, whatever. So here's what I have. Juniors, seniors, how many are there? Not J and S, not X and Y. We got to represent them with the same variable. 28 less seniors than juniors. So however many juniors there are, you subtract 28, and that's how many seniors there are, like that. So when we add the number of juniors with the number of seniors, we will get 978 total. Add X with X to get 2X. We add 28 to both sides right there, and we get 2X equals 1,006. Is that right? Yeah. And then divide both sides by 2, we get X equals 503. That's how many juniors there are. Is that what they wanted, or do they want seniors? They is me. Juniors, yeah, 503 juniors. And that is the answer. If you wanted seniors, what do you do with that number? You subtract 28 from it. And subtracting 28, you would get 475. And 475 plus 503 is indeed 978. Yep. Oh, I got rid of blue. Oh, well. All right, moving forward. Skill number 6, proportions. Write and solve them. So I got this proportion right here. Let's cross multiply, shall we? 4 times x plus 4 equals 7 times x minus 2 as quantities. Let's distribute there. We get 4x plus 16, equals 7x minus 14. That's the distribution. Subtract 4x from both sides to keep terms positive. Add 14 to both sides to move the other side of the equation. We get 30. Divide both sides by 3. You get x equals 10. All right, New York Yankees slugger Aaron Judge hit 10 home runs after 30 games this year. That's true, 2022, 30 games in, 10 home runs. Had he maintained this pace, how many home runs would have he hit after 162 games? So 10 homers in 30 games equals how many homers after 162 games, which would be a full season. That doesn't mean he played every game of the 30 games. It just means it's how many he hit at this pace. If I cross multiplied here, 30, and remember that G is games. That's not variable. 30 times x is 30x. Let me write it this way. 162 times 10 is 1620, and 30 times x is 30x. You divide both sides by 30 here. You will get x equals, I think it's 54. 54 home runs at that pace. Now, the real Aaron Judge hit 62. That means he outpaced his average, his rate, over that time. Okay, skill number 7, writing and evaluating identifying functions. Do the points in the graph to the right represent a function? Explain why or why not. You know, there's this thing called a vertical line test right here, which this fails. At this x value of 2, there are 2 different y values. At this x value of 3, there are 2 different y values. Doesn't matter that this passes and this passes, this failed as well. It just needs to fail once. That for a single x, if there's more than one y, it fails the vertical line test, therefore it's not a function. I'll just say no, because it fails the vertical line test. And the vertical line test is all that matters for that. One x, different y's. Same x, different y's. It fails the vertical line test. Vertical is not spelled C-L-E, it's C-A-L, line test. To my students, not an English class, but vertical is a math word. F of x equals x squared plus 2x. Find f of negative 3. Okay, you have to substitute, you have to substitute negative 3 for x everywhere x exists. You want to use parentheses around these substitutions, especially if you use a calculator, because your calculator will tell you that negative 3 quantity squared is positive 9, which is what we're looking for, not negative 9. That's negative 3 times negative 3. 2 times negative 3 is negative 6. We get 9 minus 6, which is 3. F of negative 3 equals 3. When you substitute negative 3 for x, you get 3 for y. Skill number 8, slope. Find the slope of the line in the graph below. I'm very commonly getting you negative slopes right here. We're falling. and we're running. We're falling 1, 2, 3, 4, 5. As we run 1, positive 1 to the right, your slope is negative 5 over positive 1 or negative 5. Either is acceptable. Those are the only two acceptable answers to this. Not positive 5 or anything like that. Find the slope of the line that passes through the points negative 2, 7, and 6, 0. You know, it's one of those things where you could almost use this graph. Negative 2, 6, 7 is up there, and 6, 0 is over here. And get the idea. You can tell it will be a negative slope, but what is it exactly? You could count. The point is to kind of use your y2 minus y1 stuff, and let's do exactly that. x1, y1, x2, y2. Your slope is going to be x2, y2. y2 minus y1 over x2 minus x1. That's negative 7 divided by 6 minus negative 2 is 6 plus 2, which is 8. So your slope is negative 7/8, and that's exactly that. It falls from 7 to 0. That falls 7. It runs from negative 2 to 6. That runs 8. Negative 7/8 is your slope. All right, skill number 9, graph this line. Sketch the graph of y equals 3/5 x minus 4. A y-intercept of negative 4 is down here. We can rise 3, run 5. Rise 3, run 5. Fall 3 as we run 5 to the left. That maintains our positive slope. Fall 3, run 5 to the left, and there is our line. Use a ruler. Draw. Oh, by the way, I never mentioned this. Draw arrows on your thing as well. The line may show all the points that are in between that we haven't plotted, but the arrow represents all the points beyond the window that we can't graph. So we always have to draw arrows on these things. My line tool is doing that, but be certain of it. All right, number 2, write the equation of the line in slope-intercept form given the following information. You got a slope of 1/4 passing through 8, 5. We need this y equals mx plus b form here. So far, I only know m. Y equals 1/4 x plus b. 8 is an x, 5 is a y. Let's substitute those into this equation right here and find out what b is so we can rewrite this equation with a proper b value. If I substitute 5 for y, I'll get 1/4 times 8 plus b. 1/4 of 8 is 2. 8 divided by 4 is 2 times 1 is 2. So 5 equals 2 plus b. If I subtract 2 from both sides, I'll get b equals 3, which then tells me that my equation I can write here is y equals, I think it was 1/4, 1/4 x plus 3. That is the equation in slope-intercept form that passes through 8, 5. You could actually try that. You could actually graph that on here and see that it actually passes there. Okay. Actually, yeah, here, just let me show you that. It'll tailor into something else later. Like 8, 5, I can use my slope of 1/4. Maybe don't go up 1 over 4. Go down 1 left 4 and find out. Look at that. It passes right at 0, 3 right there. That's what we were looking for there. All right, last skill for this midterm before we move on to those quizzes again from other weeks. Marta rides her bike to pick up a sweatshirt from her friend's house. The following graph displays the situation relating Marta's distance from home in miles and the time in minutes. So, distance from home in time in minutes. Looks like she leaves home. Segment A shows she's going at some speed. Segment B, she's still going. Segment C shows something else. Segment D shows something else. What does segment D represent? Well, let's try and represent them. She's distancing herself from home. She must be riding her bike to her friend's house. Now, she never stopped riding her bike, even though she slowed up a little bit here. Looks like she covered 2 miles in 10 minutes here, and then she covered another 2 miles over 20 minutes here. So a little slower, still arriving. At C, she stopped. Why is she stopped? She's probably at her friend's house, probably picking up her sweatshirt there. Segment D is what they're asking for, though. Marta's returning home. Marta is riding her bike home. She's distancing herself closer to home. She's being chased by somebody. She, like her friend. No one else. Nothing sinister. Martha is riding her bike back home. From her friend's house. Right? She already picked up the sweatshirt. That's representing time. That's my as time goes on. That's why I like to run to the right when talking about these things. All right, what is the range of this situation? What we're asking for in that thing is what y values exist on this graph. What distances from home has she covered? Not what's the farthest, but also what is the closest and what is everything in between. What mile markers did she hit at any point? Could somebody find her? Was she ever 1 mile away? Was she ever 10 miles away? Was she ever at home? Things like that. The range covers everything from as close to at home, which includes home, all the way up to her friend's house, which is 4 miles away. She hits everything up until, she hits everything through there. She goes from y values from 0 all the way to 4 And these are miles, by the way, and that's range. Domain would be how much time was covered in that span, and that'd be from minutes 0 to 80. And she hit every time in that span as well. But that is the range. And that is the midterm portion of this thing here. Congrats. There's a blank. I don't know what the blank's for. Oh, that's something else. All right. Let's keep... those are repeats. Okay. Didn't mean to have that. All right, perfect. Here we go. Week 11. Is this new? Yeah, that looks new. Okay, week 11. We are combining like terms. Now, I've seen some of these things before. X's with XY's and Y's. XY's combined with each other. X's combined with each other. I don't see any other X terms here. So I think 3X is all to itself. But I do see a 2xy with a 2xy. That is 4xy. So they do combine. Negative y plus 6y combines to 5y right there. And then you're done. All right, 3 distributes into these 3. Now, these do not combine. X squareds do not combine with x's. These stay separate. And even after I distribute, they stay separate. They just become 3 times larger. That's 3x squared plus 18x minus 15. And that is it. It's just a distribution of those 3. Something to get used to once you hit integrated math 2 especially. All right, skill number 2, solving for x here. I want to keep my x terms positive, separate sides of the equation. I'm going to add 4x to both sides right here to get 7x. In doing so, that means I also want to subtract 22 to that side likely. 1 minus 22 is negative 21. Let's divide by 7. I'm going to get x equals negative 3. On this one right here, x is subtracting from 20 and then dividing by 4. Yes, I could write a proportion right here and cross multiply. I don't really want to think of those in those terms too often. If you want to, great. I'm going to multiply both sides by 4 to start. That does not mean, let me change my color. That does not mean that I distribute my 4 into x minus 20. The whole goal of this was to get rid of that 4, and I just did. In exchange, negative 5 becomes 4 times larger as well. See, the left side did become 4 times larger. It's just no longer dividing by 4. The right side has this. What's negative 20 plus 20? 0. Not no solution. 0. Solve c equals 2 pi r for r. That circumference is 2 pi times the radius, or diameter times pi. But let's solve for the radius here. Let's divide by both sides by 2 pi. Let me just do that. R equals, I don't need this arrow. R equals c over 2 pi. Cool. That's it. 2 pi, by the way, does mean 2 times pi. And pi is a constant, 3.14, something, something. All right, solve y minus y1 equals m times x minus x1 for x. That's a really weird equation, but you know what? This is, I didn't mention yet. This new week, we are going to be talking about other forms of linear equations on skill number 11, point slope form and standard form. This is what's known as point slope form. So you're going to run into this form again, and I'll try and explain what it is at the time. But let's get this x by itself, which is being multiplied, it's being subtracted by x1. These are different. X and x1 are 2 different things. They do not combine. Being multiplied by m and all that. So if it's being multiplied by m, I'd rather not distribute. You can. Oh, shoot. We have 2 options. Let me show you the 2. Option number 1 is divide both sides by m right now. As it's multiplying by the quantity x minus x1, I could divide both sides by m right now. And then I'll have y minus y1 over m equals x minus x1. And then if I add x1 to both sides, then I'll get x equals y minus y1 over m plus x1. So that's one version of it. X and x1 are 2 different things. Alternatively, what you could do is you could distribute the m into here, knowing that you're going to have to divide by m later, but it gets rid of the parentheses, and you'll have y minus y1 equals mx minus mx1. And I say x1, I should say x sub 1. I'm going to be saying that more with arithmetic sequences. If I add mx1 over to both sides, because I got to get that term by itself, it'll say mx equals y minus y1 plus mx1. And I divide both sides by m here. We divide everything here by m. And notice that answer says x equals y minus y1 plus mx1 all over m. These are the same answer. This one just doesn't share the common denominator, multiplying top and bottom by m over m. But you can see you get the same. They are equivalent. Well, you can tell. Maybe literal equations are hard for people. Depends on what's being asked. That might have been a hard one. Okay, skill number 4. Triple the difference of 8 and a number. Triple the difference. We're not tripling 8. We're tripling the difference of 8 and a number. We're going to triple 8 minus some number. tripling the difference. 8 does have to go first because in the difference wording, 8 was written first. All right, Maribel uses her phone X hours per day on weekdays and Y hours per day on weekends, and her parents won't let her use her phone more than 15 hours during the week in total, weekdays and weekends. In the inequality 5x plus 2y is less than or equal to 15, what does the coefficient 2 represent? Okay, let's see if we can make sense of this here. The situation kind of spells out how the inequality is made by this thing. 15 is the number of hours she can use in total. She can use up to 15, no more. She can use less than or equal to. 5x plus 2y seems to be an expression that represents the amount of hours that she's using. If she used x hours per day on weekdays, why is it multiplying by 5? Because there are 5 weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, in the week. Let's say she uses the same amount every day on each weekday there. Running out of water. I actually have water bottles I can use. And then 2 is the number of days in a weekend multiplied by y hours per weekend, and that's that. So what does 2 represent? Not 2y, just 2. 2 represents the 2 weekend days. The 2 days of the weekend. That's it. So, the reason why we have these questions like this is to help you understand why you build the equations and inequalities the way that you do. I could have asked any question here. What does 15 represent? What does 5x represent? I just asked, what does 2 represent there? Obviously, we know what x and y represents, but why would you make an inequality this way? How would you know to make it yourself? How would you know where the 2 comes from to make it yourself? And that's really the big thing. All right, skill number 5, set up equations for each situation and solve. A phone battery is at 90% and loses 5% per hour. How many hours will it take for the battery to reach 32%, given exact decimal? Percentages themselves don't matter as far as units here, as I'm not writing percentages here. We start at 90, where we're at, and we lose 5% per hour. That means we're subtracting 5 every hour for how many hours? X hours. For X hours right there. We're going to subtract 5 so many times that we're going to reach 32. Now, you might be wondering, how do I subtract 5 from 90 to get 32? You don't exactly. That's why there's a decimal in this. The X hours will be a decimal. So let's solve that thing. I'm going to subtract 90 from both sides and get negative 5x equals negative, is that 58? Oh, I think so. Divide both sides by negative 5 there and you get x equals, I believe that's 11.6. No, wait, yes. I believe it's 11.6. I'm sorry if that's wrong. 11.6 hours right there. That's exact, right? That's 11 hours and 36 minutes. So that's how long it would take for it to reduce to that. Okay. 2 phones are supercharging. One phone is at 39% battery level and charges 3% per minute. It's kind of fast. Really fast. While another phone is completely dead and charges 5% per minute. That's really, really fast. How many minutes will both phones be at the exact same battery level, given exact decimal? Okay, so again, a situation where we have 2 different rates that are the same, with 2 different rates to compare. We have 39% battery level for now. The other one's adding 3% every minute for X minutes. X is number of minutes for this one. We're going to find out when it's equal to a battery that's dead, no percent, 0%, and adding 5% per minute times the number of minutes there. That's our equation. If I subtract 3x from both sides there, I will get 2x equals 39. When you divide both sides by 2, you will get x equals, and it says give an exact decimal there, that is 19.5 minutes. I think the other one was the other one was in hours. This was in minutes right here. So that's where we're getting 19.5 minutes. I hope I got my numbers right there because I wasn't using a calculator. Okay, skill 6, we got a proportion right there. Let's move this. I can delete this now, right? Solve x over 5 equals x plus 4 over 7. This is cross multiplication. That is 7 times x equals 5 times the quantity x plus 4. I'm going to distribute that 5, so we get 5x plus 20. Hopefully you're pretty comfortable with proportions these days. Subtract 5x from both sides to get 2x. 2x equals 20. And divide both sides by 2, you get x equals 10. I think we've seen that answer several times now in proportions. All right, number 2, Finnegan Fox lets out 36 he-he-he's every 10 seconds. Look up Finnegan Fox, please, for me. He is adorable, and you will know exactly what I'm talking about here. If he maintains this rate, how many he-he-he's will Finnegan Fox let out after 25 seconds? I mean, he is a he-he-he master. So 36, I'll just put he's, every 10 seconds is how many he's after 25 seconds. That's our proportion. We cross multiply there. 25 times 36. I think I know the number. I don't want to be wrong. Is it 1,000? Enter. No, 900. See, I was wrong. 900. I could have. Oh, duh. 900 equals 10x. Divide both sides by 10. You get x equals 90. He'll get 90 he's over that time span. Boy, is that a lot of them. And I'm sure that's probably pretty accurate. Go to YouTube, look him up, please. And, he's just the best. All right, does this graph on the right represent a function? Explain why or why not. No, this fails the vertical line test. 2 y's for the same x at multiple points. Here's just but one example. Now, this exact point, if I scanned over here, this exact point right there would just give a single x and single y right there. But everywhere else that has x's fails the vertical line test. And it continues on in that direction. No. F of x equals 5 minus x over 2. Find f of negative 3. Well, in substituting negative 3 for x, remember 5 minus, and that's a negative 3 right there. Don't ignore the fact there's a minus in front of the negative 3, which means we have to add. That's 5 plus 3, which is 8, and 8 over 2 is 4. F of negative 3 equals 4 by substituting negative 3 for x. All right, moving on. We got skills 8, 9, 10, and then the new one 11, which we'll get to. So skill 8, find the slope of the line. Very commonly, I seem to be going for negative slopes, so let's do it. Now, be careful with this one. We're going from here to here, but we're not just going down 1, 2, 3, 4, 5, 6. Look at the scale. Height of balloon, ooh, in meters. We're going down 10, 20, 30, 40, 50, 60. Subtract 60 from there. Oh, that'll throw a loop for my students who just count. Look at the scales. Now, is this scale going by tens? No, and that's what makes it important. If these were tens and these were tens, you could just say 1, 2, 3, 4. We're going over 1, 2, 3 right there. So down 60, right 3. That is a slope of negative 60 thirds, which is negative 20 over 1 or negative 20. Yes, you must reduce your fractions for slopes. Slopes must be comparing as best as possible for reduction. Must. Now, we could have also done units, meters per minute. I didn't ask. All right, find the slope of the line in the equation y equals 6. Okay, y equals 6 is also, in slope-intercept form, that would be y equals 0x plus 6. Now, slope of 0 is horizontal like that, and that's what this thing is right here. So by the way, the answer is m equals 0. I guess I'm over-speaking on it. Y equals 6 as a graph. Look at this little graph down here. This is y equals 6. It sounds weird because you think of y as up and down, right? Well, notice we went up. From the x-axis, we went up to y equals 6. But these are all the values of y, of x, where y equals 6. This is 1, 6, 2, 6, 3, 6, 0, 6. What do they all have in common? Well, y equals 6. That's what it looks like. Anyway, a horizontal line is a slope of 0. And I was saying this is equivalent to this because, why isn't the x here? In y equals mx plus b form, where's x? It's being multiplied by 0. You know what anything times 0 is? 0. You know what 0 plus 6 is? 6. We don't have to write it. They don't have to write it, and that's what they're showing you. So it's a horizontal line. Your slope is 0. That's not nothing. That's not no slope. It is a slope literally of 0. All right, sketch the graph of y equals negative x plus 4. If y'all don't mind, I'm just going to use this graph right here. Now, with this one, we got to maintain that that slope right there is actually negative 1. Better yet, negative 1 over 1. We like our slopes as fractions. We like to talk about starting from 0, 4, we're going to go down 1, right 1, down 1, right 1 like this. That is a negative slope as we plot those points right there, and up 1, left 1 over in this direction like that. And we get exactly what we was looking for. Right there. That is that line. All right, write the equation of the line in slope-intercept form graph to the right. So this one, we got to identify what our slope is, y-intercept is, which looks like 1 because it crosses at 0, 1, and what our slope is. And I gave you this point right here. You can find other points if you'd like to, but that's a rise of 1, 2, 3, 4, and over 2. Up 4 over 2 is a slope. Oh, but you got to reduce that. That's 2. You could write 2 over 1. That's fine, but the slope is 2. Do not write 4 halves. So, slope-intercept form, y equals mx plus b, y equals 2x plus 1. That's the only acceptable answer. All right, skill number 10. This is interpreting graphs and domain and range and all that kind of stuff. One day, Manu leaves work and drives to his parents' house. For 3 hours, he has dinner and hangs out at their house. Then he drives home. The graph on the right shows his situation with his distance. Is it his or this? Whatever. With his distance from his home as a function of time. So he drives to his parents' house, stays at his parents' house for 3 hours, then drives home. How far did Manu travel overall on this day? Now, he didn't start from home. Looks like he started from somewhere, from work. Work is, 10 miles from home, apparently. How far did he travel on the day? Well, he traveled from mile 10 to mile 40 up there. That distance right there is 30 miles. And then he traveled home. You don't want to consider this negative miles. It's miles he traveled. It's distance. So going downward right here, not downward, but as the graph goes downward, he goes 40 miles away back to home. Takes him an hour. And that's another 40 miles. So 30 plus 40 equals 70 miles. That's how much he traveled on the day. Assuming he woke up from work. That's what we're talking about right there. He left from work for it. All right, what is the domain of the situation? The domain asks x values here. What times were counted? We counted everything from time 0 to time 5, and those are in terms of hours. Everything in between, this was continuous, counted from 0 to 5. From 0 to 5. And if you want to put hours and hours, that's totally fine, but that is your domain of the situation. It's a compound inequality because it's continuous. And there you go. All right, skill 11. This is the new one. What are the x and y intercepts of the equation 5x minus 8y equals 40? State both answers as coordinate pairs x, 0, and 0y. We're not using this graph for that, but this is something called standard form. Now, we've been in standard form before, but we haven't explored what it does. First of all, it's not like you have a slope of 5 and a y-intercept of 40. We've talked about that. You'd have to get y by itself and figure out what its true revelation is. That being said, I'm going to get y by itself by different means with this. I'm hinting to you right here, but the x-intercept, to find it, you set y equal to 0 when you solve for x. For the y-intercept, you set x equal to 0. Set x equal to 0 and solve for y. If I find my x-intercept right here, right, and x-intercept is where we cross the x-axis. It's at something comma 0, and y-intercept is 0 comma something. So x-intercept, if I set y equal to 0 in this equation, I'm going to get an equation that says 5x equals 40. If I divide both sides by 5, I get x equals 8. My x-intercept is 8 comma 0. Where should I write that? I guess right here. 8 comma 0. That's where we cross the x-axis right there. If I want to find my y-intercept, I set x equal to 0. Set x, 5 times 0 is 0. I get an equation that says negative 8y equals 40. I divide both sides by negative 8. I get y equals negative 5. And that's a point on my graph that's 0 comma negative 5 right here. 0 comma negative 5. So that's what it's saying when I'm asking you to write them as x comma 0 and 0 comma y. Write them as actual ordered pairs. I want to know that you know specifically where they go on the graph and that kind of thing. And that's what it is. Your teacher would probably want the same thing. All right, write an equation of the line graph to the right. Now, there's a recommendation right here that's basically don't use slope-intercept form, because here's the thing. Where is that thing crossing? Don't make a guess. Don't assume it's 1/2, 3/4. Don't round. Nothing like that. There are ways where you can get that answer. I'm going to say no. So how do you do it? If slope-intercept form, Mr. Robinson, I need the y-intercept for slope-intercept form. Well, there are different forms. There's something called point-slope form. Now, you saw it in the literal equation on skill number 3 earlier. And it looked like y minus y1 equals m times x minus x1. Now, m is the same m from mx plus b. It's your slope. Before b was your y-intercept. I know that b and y-intercept have nothing to do with each other as far as lettering. But this x1, y1, we've seen x1, y1s before. They represented points on a graph. There's an x1, y1, which would represent a point on the graph right here. This is a point on the graph. We have 2 different known points on the graph. This could be our x1, y1. This could be our x1, y1. And I say that loosely because sometimes we call something x1, y1 and x2, y2 when we talk about slopes, like we could here. I'm not going to use the slope formula because I can count my slope here, which I need, by the way, but I can use either of these as points on the graph, and then when I plug them into this equation, that would represent an equation that could be graphable or used in that way, and I'm sure other skills quizzes I'll be doing exactly that. Anyway, right here I still need my slope. My slope will be a rise of here and a run of here. We're going to rise 1, 2, 3. That's from 1 to 4, a rise of 3. And a run from -4 to 3 of 1, 2, 3, 4, 5, 6, 7. My slope is 3/7. Now I can choose either point here. Either this is x1, y1 or this is x1, y1. Let's start with 3, 4. If I use my point slope form like this, then my equation could say y minus y1, which is 4, equals m, which is 3/7, times x minus x1, which is 3. That's one equation I could write, and you can leave it like that. There are ways to convert it to slope-intercept form, get y by itself. I don't want to do that because of the fraction issues. You could. I could kind of say what the answer is if you were very curious, but I kind of feel like moving on. And then I could otherwise use this as x1, y1. That's y minus 1 equals 3/7 times... Now check this out. It's x minus x1, but that's a -4 there. That becomes x plus 4. That's something that people have trouble getting used to, the whole switching signs in this thing. That happens a lot in a lot of equations and such. There's a reason for it. These things aren't just made up for no reason particular. I don't think this is the thing to dive into with it when I have 256 problems to do in total. But yeah, that's just another instance where you're seeing it. So those are two of the valid answers that I'd probably looking for. Now, if you were dying to know what the slope-intercept form would be, it would be y equals 3/7 x, and I believe plus 19/7. And I'm writing it as an exact. No rounded nothing. Just plus 19/7 like that. That's a third. Now that is, if you're curious, that is 2 and 5/7. So that's where that's going. That's 5/7 up from 2. Okay. All right. And that ends week 11. Now there was no week 12. As far as this goes, I spent kind of a week and a half on this other one right here. So let's go to week 13. Going to go pretty fast on the ones leading up to the new skill. By the way, the new skill here is systems of equations. Systems of equations. Week 13. Skill 1, 7x plus 5x plus 6x is 18x. 3 plus 4 is 7. I get 18x plus 7. -5x minus 15 is that distribution. Remember, distributing the negative. And plus 7 there. -15 plus 7 is -8. Skill number 2. 4x minus 4 equals 12. If I add 4 to both sides, I get 16. Divide both sides by 4, I do get 4. And this one right here, 5x plus 2 is already simplified, but the left side can be simplified more. -6 plus 8 is 2, so I get 2x plus 2. If I subtract 2x from both sides here to keep my x's positive, I get 3x. Subtract 2 from both sides, I get 0. 3 times something is 0. That's 0. Divide both sides by 3, right? What's 0 divided by 3? It is 0. X equals 0. Don't get lost in that. Don't say no solution. Don't say 3. Don't mess up things like that. That's how it's supposed to be right there. Okay. Oh, I see a number I want to change over here. I'm going to when I get to it. All right, skill number 3. That's another note I'd like to make. Solve k minus c equals 273.15 for c. This is Kelvin, degrees Kelvin minus degrees Celsius is 273.15. Another science lesson for you guys. Solve for c. I got to subtract k over if I'm going to do that. Or this one version of it. C is still negative, so I'll put negative k plus 273.15. And if I divide everything by -1, i.e. switch all the signs right there, that is k minus 273.15. So that is the answer. I could have added c over and then subtracted 273.15 over. That would have been the same answer. Pretty clumps for room. I haven't had to clear space yet too much, but there we go. Solve for d here. Now d is multiplied with c and added with ab. Let's change the color and just talk about what I'd want to do there. Let's subtract AB from both sides to start with there. So now I'm going to have CD equals E minus AB. And then I divide both sides by C there. And let's kind of have it like that. E minus AB all over C. That's just the best version of that. I know it's clunky, but that is exactly how it works. That's skill 6. Skill number 4, translate these things. 6 increased by a number is 9, is being the equal sign between left expression. 6 is increased by a number, and then equals 9. So 6 plus x is 9. Yeah, x equals 3. What of it? I'm not asking you to solve. At Rio Americano, class periods are 59 minutes each, passing periods are 5 minutes each, and break/lunch combined to 37 minutes total. All true. In the equation 59x, I really wish this was on one line. 59x plus 5y plus 37, I'm rewriting this anyway, equals, I believe this number was supposed to be, I think it was supposed to be 420. I think I was multiplying the wrong thing. I think I was doing 50 times 7 in my head when I wanted to do 60 times 7. But what does 350 or what does 420 represent? Let's change that number. All right, what does 420 represent? So here's what's happening. 59 minutes per period. What is x? I didn't define x yet. It must be the number of periods there are in the school. So 59x represents how many minutes you spend in classes. 5y, 5 minutes per passing period times y passing periods. This is how much time you spend in passing periods. And 37 minutes is the combined break/lunch, brunch, lunch, combined 37 minutes total. This is how many minutes you spend in class, in passing period, and during brunch and lunch. That's how many minutes you spend in school. 420 minutes spent in school. From bell to bell. Doesn't matter if it was 350 or 420 or whatever. We weren't solving. What does it represent? That's it. All right, let's get rid of that blue. Let's go to like green. Skill number 5, set up and solve equations. Trent purchased 4 oranges at the grocery store. He also spent an extra $5 on Sour Patch Kids, just a single bag, right? I didn't mention multiple things. His total grocery bill is $8. How much did each orange cost? So if $5 is spent on Sour Patch Kids, and then he also spends money on oranges, $4 or 4 oranges times X dollars per orange. How much did, right? Each orange cost $4 per orange times, or 4 oranges times X dollars per orange. It's $8 total. He must have spent only $3 on oranges. Subtract 5 from both sides, and then you divide by 4 there, and you get 3/4. Now that is, this is context. I want money. $0.75, 75 cents. That each orange costs 75 cents. Leslie scored 2 times higher than Miguel on the recent history quiz. Together they scored 87 points. How many points did each score? Well, if Leslie and Miguel are here, Miguel scored X points. Leslie scored 2 times higher. She scored 2X points. When you combine those, you get 87. All right, well, 3X equals 87, and I believe that's 29. Now that's how many points Miguel scored. 29 points. Leslie scored twice as many. 29 times 2. 58. Now you don't know how much this was out of. Could have been out of 58, in which case Miguel still got 50%. But don't assume this is out of 100 points there. But those are the answers right there. All right, solve. Proportion. Got to cross multiply. Let's go right at it. 5 times 12 and 2 times x plus 10. 5 times 12 is 60. You could distribute right here. Let me do this for you once. I'm going to divide both sides by 2. You notice you could ever do that? Divide both sides by 2. As long as it divides evenly. X plus 10 equals 30. Try it the other way. Trust me, you'll get the same answer. Subtract 10, you get x equals 20. I want to move forward. At a bake sale, you can buy 5 cookies for $3, but you have $10 on you today. How many cookies can you afford to buy? Whole number answer expected, because you're not going to buy a decimal amount of a cookie if it's not exact. So you can buy 5 cookies for $3. Now, that's not necessarily a bundled deal. That's just, you just figured that out. The last sale, someone said I got 5 cookies, $3. So 5 cookies, $3, equals how many cookies? X cookies for $10. 10 times 5 is 50, equals 3 times x there. You divide by 3. And remember, we're going to kind of decimalize this thing out. It's going to be around, I'm just telling you this right now, it's going to be around 6 repeating, right? 16.6 repeating cookies. Now, that's not an exact number. The answer is either 16 or 17. Now, most people would want to round up, because this 0.6 is more than 0.5. But my question is, can you afford 17 cookies? The answer is no. If you can't afford you can't afford the 17th cookie. No, you can't. You can't afford 17. It costs too much. You only have $10. You can only afford 16 cookies. You actually got to round down in that scenario. So that's a real world problem where logic applies as far as limiting yourself to a certain something. And there's one right there. All right, skill number 7. Does the relation at the right represent a function? Does this represent a function? Explain why or why not. We are looking to see if x's repeat. 1, 2, 3, 4, 5, 6. X's never repeat. And if x's did repeat, we're looking to see if the y's were different. If so, the x's did not repeat. That does make this a function. Yes, no repeating x's. That means no same x with different y's. All right, f of x equals negative 2x minus 3. F of negative 1 would be negative 2 times negative 1 minus 3. That's 2 minus 3, which is negative 1. That is f of negative 1 there. All right, a colorful graph. Find the slope of the line in the graph to the right. Now this one, probably not as easy to count because no grid lines here, but I can kind of ask it out loud. The slope of the line, we go up from negative 1 to 3. What is that rise? That's a rise of 4. You can try and count. I guess you can count right here. 1, 2, 3, 4. That works. The run from negative 2 to 4, that is a run of 6. That is a slope of rise of 4, run of 6, but you got to reduce it, divide top and bottom by 2. That's 2/3. Yes, you do need to do that. Find the slope in the equation 5x plus 2y equals negative 1. We've seen something like this in the past here. If I subtract 5x from both sides, now remember, I kind of want that slope-intercept form, right? 2y equals negative 5x minus 1, and then I can divide everything by 2 there. Now I really like to see that exactly like this, negative 5 halves x minus 1 half. Now, I just want the slope. I couldn't care less about what the y-intercept was. I didn't have to calculate it. I also don't care about x so much, but I care about slope-intercept form indicating for me that I got the proper slope. It is negative 5 over 2. It's not 5. It's not negative 5 halves x. And I do not want this equation. I want the slope. I want to know that you can provide me the information I'm asking for. And in that case, that's it. All right. Skill number 9. Sketch the graph. Gladly. Let me get graph paper. Actually, you know what? Let me pause this for one moment here. Okay. I'm back and you didn't even notice I was gone. Okay. Here we go. Where are we? All right. Sketch the graph of... Oh, wait. That's right. I have to grab the graph. Sketch the graph of 2x plus 3y equals 12. So it's going to kind of just be in the way of this one here. So you have options, and I'm going to present the options here only when it's convenient. Otherwise, I'll probably just do one way versus the other. Now, this is in standard form, and you can actually graph out of standard form by getting your intercepts. I think we've had a question that asked us to find intercepts of a graph, and that helps because 2 points make a line, and x and y intercepts can represent 2 different points. So I can find the x-intercept by setting y equal to 0 in this equation. When y is 0, this term goes away. We get an equation that says 2x equals 12. Divide both sides by 2, you get x equals 6. That means that 6, 0 is a point that's on this graph. It looks like that. And if I set x equal to 0, I can get the y-intercept here, where I have an equation that says 3y equals 12. Divide both sides by 3, you get y equals 4. When x is 0, y is 4, and that's a point that's on our graph. That thing we can make a line with, and I'm going to change it blue and all that, but we can make a line with that one through those 2 points, and that's sketching the line of that graph right there. And that's all you got to do for that. So standard form's pretty helpful for using intercepts to do that here. Now you can also get this into slope-intercept form, so let's do that equivalent, and let's just see if it's the same line. After this, I got to erase it because I got to do the next question. So 2x plus 3y equals 12. If I subtract 2x from both sides, I get 3y equals negative 2x plus 12. And then I divide both sides by 3 here, and then I get the equation to say y equals negative 2/3 x plus 4. Now that's slope-intercept form right there. You start at 0, 4 right there. You would go down 2, right 3, there's a point. Down 2, right 3, there's that point. And down 2, right 3, and it seems to follow that suit. Up 2, left 3. So you can do either or, not stopping you from one or the other. I'll tell you what, I'd prefer standard form when it's convenient for me. And the only convenience comes in the fact of no fractions. I could divide 12 by 3, and 12 by 2. There are sometimes, what if it said 7x? I don't want to divide 12 by 7. I don't want that fraction. So maybe less convenient in those scenarios. It all really depends on what you're talking about with those problems. But that one's pretty good. All right, I'm going to delete that. We're going to go to number 2 here. Write the equation of the line in slope-intercept form. That's what skill number 9 is all about. That has a slope of 1 and passes through -3, -11. So your slope is 1. Now, -3, -11 is your... for mx plus b, that's 1x plus b. Remember, 1x is just x, so I'm going to put that. -3, -11 is your xy that I can substitute into here. So -11 equals -3 plus b. If I add 3 to both sides, I get b equals -8. Not bad. So anyway, so your equation would be y equals 1x or just x minus 8, like that. That would be the answer. Now, there are other versions of answers that you can put. You have lately learned about point slope form. Y minus y1 equals m times x minus x1. That means you can use this m, this x, and this y as x1, y1, and you can literally substitute them in. What's an alternate answer? We could use y minus y1, minus -11 is plus 11, equals m, which is 1, you don't really need it there, times x plus 3. X minus x1 is x minus -3 and x plus 3. And listen, if you distribute 1, which again literally means nothing, and subtract 11, you would get that equation out. So either of these equations are oh, I'm sorry, this is slope-intercept form. I spoke a little quickly there. Anyway, okay, then let's do this. That answer doesn't work because you need slope-intercept form, but you can use this equation to get into slope-intercept form. So like I said, 1 times something is the something, so you distribute 1, boom. Subtract 11 from both sides, you do get y equals x minus 8. I guess the other point I can make is you don't have to use slope-intercept form to get your equation in slope-intercept form. You can use point-slope form as well if you feel more convenient. I know a lot of people don't like this formula. You practice it over time, you might get used to it, but I know some people don't. All right, skill number 10. Find the domain of the graph below. Now this is a continuous function right here. Domain is just the x values. It goes as far left as 1 and as far right as 7, and it hits everything in between right there. So it goes all the way from 1 to 7, and it includes both. The domain is x is between everything between 1 and 7, like that. I didn't ask for range, but that would be everything from -14 to -2. Y is -14 is less than or equal to y is less than or equal to 2. All right, was there? Oh, here it is. Sketch a graph of the following situation. I'm going to need to move myself here. Sketch a graph of the following situation representing x as time and y as gallons of water. Oh, this is not the graph for that. Okay, let me just blank that out and let me move that out of the way for a moment here. All right, here we go. We're going to draw our own little graph here very quickly. Okay, Everett gets into his bathtub and turns on the faucet to fill it with water. Okay, so no water at time 0. He starts filling it up. Here we go, filling it up. After some time, the tub is full of water, and he turns off the faucet. So now, as he turns off the faucet, that means no change in water is happening, but time is going on. So you'll just see this moving. This is time going on, but no water change. He chills in the tub for 10 minutes. So let's say 10 minutes, boom, right there. I'm not going to actually scale it. Then he opens the drain to let out water. Water drains. After 2 minutes, he accidentally closes the drain. So he realizes that, but boom, drain closed, no water. After he realizes this, he opens the drain again and lets the tub drain completely. So you would get a graph similar to this. I don't know exactly to what effect or whatever, but it would have this notion of up, stop, down, down. And that's it. That's Everett. That's Everett. All right, skill number 11. Rewrite y. Okay, so this is exactly what I was talking about from that previous problem set, right? This is this is point slope form right here. Rewrite y plus 5 equals 3 times x minus 1 in slope intercept form. You don't need to know anything about point slope form for this to know. You just need to know what slope intercept form is. Y equals mx plus b. This means get y by itself, have no parentheses. One x term, one y term, y-intercept term, that's it. So I will subtract 5 at some point, but let's first distribute. Let's solve this for y. So distribute that and we get y plus 5 equals 3x minus 3. Then I subtract 5 over, and negative 3 minus 5 is negative 8. You get y equals 3x minus 8. You are done. And that's it. Granted, that is point slope form, and these two represent the same line. Okay, write an equation of the line graph to the right. Now let me get rid of Everett's bathtub problem right there, and let's look at this thing right here. This is a vertical line right there. What the heck is a vertical line doing? Vertical line, first of all, guys, has an undefined slope. It's not a slope of 0. It's dividing by 0. All rise, 0 run. What happens when you divide some y by 0? You get undefined. Now, I'm just saying that just so you know that, but that does not answer the question, what is the equation of the line? It does kind of help say it's not y equals mx plus b because there is no m. In fact, y is irrelevant here. Y changes all the time. X doesn't change at all. You know what x stays this whole time? It stays as 8. No matter what y is, x equals 8. And that's the equation. We've talked about a horizontal line being a y equals equation. Vertical lines are x equals equations. That is the equation of the line x equals 8. Oy. Okay, skill number 12. This is the new one. Solve the below system of equations by graphing. Okay, now solving by graphing it's as simple as this. I'm not going to get deep into it at all. But solving by graphing is a nice important tool for explaining what solving systems does. Well, I'm going to graph both of these lines here, and I'm going to find where they intersect. And that is the solution to the system. So solving the system by graphing here, I'm going to first graph y equals 1/2 x plus 2. And I'm going to mince, mince words, mince no words, whatever. I'm just going to cut words short and just rise 1, run 2, and fall 1, run to the left to draw that line right there. Time has escaped me from a lot of these things where I'm thinking, I'm not going slowly, but this is long. All right, so there's that one. Y equals negative 2x minus 3. Remember, that's negative 2 over 1. So with the minus 3 right there, we're down there, and then down 2, right 1, but also up 2, left 1, which is probably the more important one because we're going to cross right here. So these lines do intersect. The question is, where did they intersect? Let me draw the line first because you got to complete it. There's a lot more I could mention with these things here, but where did they intersect? They intersected at this point of intersection right there. That point is negative 2, 1. Now that's the answer. Now what a solution to a system means is basically this. The blue line has all these x, y values that represent solutions to this system, to this equation. That means I can plug in this for x and this for y, and I'll get the left side equal to the right side. But it won't work for green. Likewise, I could plug this in for x, negative 5 for x, and 7 for y in for green, and that will work, but it won't work for blue. There's only one that works for both of them, which is negative 2, 1. If I substitute negative 2 for x and 1 for y, it'll work. If I substitute negative 2 for x and 1 for y, it'll work. And it's the only x-y combo that'll work for both equations together in this system. That was a terrible curly brace. In this system. Now we're going to solve a system algebraically. We are not going to graph them, but we are going to use algebra to solve them. There are different methods we can choose, some better than others depending on how they're set up. This one is primed for what's called the substitution method. I have one equation where a variable is already isolated. It's by itself, y equals. I know that there's an x in it, but that's to our benefit right now because what we can do is take this expression and substitute it for y in the other equation. See, if y equals 6x minus 11, then we can rewrite that bottom equation where instead of y, we can literally write 6x minus 11. It'll actually take y's place. You see that? 2x plus y equals 5, 2x plus 6x minus 11, 6x minus 11 equals 5. What did I accomplish by doing this? I've created one equation with one variable. I've now made x solvable. 2x plus 6x is 8x. Add 11 to both sides. Divide both sides by 8, I get x equals 2. Now I'm not done. I have to solve the system. I want my answer to look like this. Some x, some y. I found x. Let's find y. How do I do that? I can substitute 2 for x into any equation that I've made in the past or that I have. Like this top one. Y equals 6x minus 11. I can't say that. That's a perfect one. y equals 6 times 2 minus 11. Why is this one perfect? Because y is already by itself in this equation. I really like equations that do that, and that's where the substitution method seems to pay off best. Y equals 1. So that point on the graph is 2, 1. And I say point on the graph, meaning if I graphed these two equations, this is where they would intersect. And yes, your answer must be an ordered pair. It's not enough just to solve for x and y. It's not x equals 2, y equals 1. It's specifically the x equals 2 when y equals 1. And that ordered pair demonstrates that. That's where they intersect. And that is your new skill number 12 for this week number 13. Okay. Week number 14. We're going to simplify these things by skills. X squared does not combine with x terms, and it looks like x squared will not combine with anything. Negative 9x plus 5x is negative 4x, and a plus 1 to seal the deal. Only one set of terms combined. That's it. Now we can distribute 2 times 3x plus 4 plus 5 times 6x minus 7. 2 times 3x is 6x. 2 times 4 is 8. 5 times 6x is 30x. 5 times negative 7 is negative 35. Numbers go up, but oh well. 6x plus 30x is 36x. 8 minus 35, I believe, is negative 27. I think. Skill number 2, 5 plus x over 5 equals 7. Straight up, I want to subtract 5 from both sides right now before I do this times 5. Subtract 5, and I get x over 5 equals 2. What number divided by 5 equals 2? Multiply by 5 and figure it out. That's going to be x equals 10. Get a lot of x equals 10 answers in these quizzes, and I'll deal. All right, x equals 8 times the quantity x minus 1 minus 13. Let's distribute 8 into both of these. We get 8x minus 8, and then minus 13 there. And then combine negative 8 and negative 13. We get x, oh, something just happened. Give me one sec. We get x equals 8x minus 21. All right, that's simplified. Let's subtract 8x from both sides there. I get negative 7x equals negative 21. And divide by negative 7, we get x equals positive 3. Double check that one, because I might have fallen out of favor with that. That looks like it works. Okay. Skill number 3. Number 1. Solve x equals y over z for z. Now that one's a little interesting there. Z's in the denominator. Do not multiply both sides by y. I see people do that. Y times y does not cancel. In fact, the problem is really that z is in the denominator. Let's take care of that first. We need z in the numerator. Yes, you could write it like a proportion and cross multiply. I'm not against it. But regardless, I want to know that you know what's going on here. If I multiply both sides by z, no, maybe I don't solve for z in one step right there. But I did get it out of the denominator. I need to know what z equals, not what 1 over z equals. So z times x, or x times z, equals y. And if I divide both sides by x, that will get z by itself. Basically, x and z kind of switch places. If x equals y over z, z equals y over x. This is called an inversely proportional relationship. And that's what it is. Okay, the next one, number 2 right here, solve a equals s squared for s. You know, when you have something squared, how do you solve for that variable? What if it said x squared equals 9? What squared, what times itself equals 9? Well, that'd be 3, or I guess really, one second, or I guess really negative 3, but you know, we're not really dabbling with that right now. We're assuming our numbers are positive here. You know, what you do is you take what's called a square root. You take the square root of both sides. You know, almost every math thing has an inverse to it. Multiplication is division, addition is subtraction. Squaring has square roots. And that's what it is. S equals the square root of a, just like the square root of 9 is 3. That's how that works. That's how that one would work out there. All right, skill number 4. A stadium can fit at most 55,000 fans. So the fans are X. X doesn't have to be 55,000, but the most it can be is 55,000. So we could say X is less than or equal to 55,000, like that. Less than or equal to. All right, Curtis is buying supplies for his school. He buys C packages of crayons at $1.49 per package and M packages of markers at $3.49 per package. Write an expression, not an equation, representing the amount of money Curtis spends on supplies for his school. He spends this much money on crayons and this much money on markers. Right? 1.49C is not 1.49 crayons. It's $1.49 per package of crayons. You multiply by C packages, that's how much money you spend on crayons, and same with the markers for $3.49 per. All right, skill number 5, here we go. This is both questions run in tandem with each other. They have to do with trees. An 80-foot redwood tree grows 3.5 feet per year, and a 113-foot spruce tree grows 2 feet per year. After how many years will each tree be the same height? So we have two different kind of rate things going on. Here's the redwood tree, 80 feet now, 3.5 feet per year for X years. When will it have the same height as a spruce tree that is currently at 113 feet and grows 2 feet per year for X years? Let's solve for X. Let's make X positive by subtracting 2X for both sides. That's actually 1.5X. I don't think you need a calculator for that. I think I need a calculator for this. 113 minus 80 is 33. You divide both sides by 1.5. Let's try and get that answer. That's going to be X equals, I think it's, 22? Oh gosh, that better be 22. I can't be that insufficient. 22. So X equals 22. So after how many years? 22 years. Notice I keep writing units for these ones whenever they show up. How tall will both trees be when they are the same height? So 22 is the number of years. What is that height then therefore going to be, right? How tall? So now we can substitute 22 in for either expression. We've seen that several times. I'm going to go ahead and take this one only. The spruce tree, being the same height as the redwood tree after 22 years, will be 113 plus 44, which is 157 feet tall for both of them, not just spruce, right? Redwood, you plug in 22 there, you should also get 157 for both. That's the idea for it. Okay, provide an exact answer here. 7 times x equals 11 times 33. 7x equals 33. Divide both sides by 7. You actually get just 33 sevenths, and that's all I'm looking for. Just 33 sevenths. That's exact. That's all I want. No context. All right, each gallon of gas costs $5.79 at a nearby gas station. If your car can hold 12 gallons of gas, how much would it cost to fill an empty tank? I mean, this seems a lot easier than just the proportion set, just because it's each gallon. That's per 1 gallon. For $5.79 per 1 gallon is how much money for 12 gallons? It looks like you just multiply by 12, and that's true. 1 times x equals 12 times 5.79. I'm going straight to the calculator for that one. And if there's more than 2 decimals in it, which there aren't, it looks like $69.48. Remember the units? It looks, if there was more than 2 decimal places, you want to round it to 2 decimal places after that. Maybe even round upward for that cost. But, yeah, 2 decimal places because it's money, right? Okay, skill number 7. Below are the button presses and beverage distributions at a vending machine. You press button 1, you get Coca-Cola, and then someone presses button 3, you get Dr. Pepper. 1 is Coca-Cola. Again, that seems to be good, right? You press 1, you still get Coca-Cola. Same output for the input. 2, you get Pepsi. 2, you get Pepsi. 3, you get Dr. Pepper. 1, you get Pepsi. Now, there's no problem pushing 2 and get Pepsi and get 1 and get Pepsi. That's fine. Different buttons, same output. It's a problem that we push 1 to get Coca-Cola and then you push 1 to get Pepsi. Is this a function? No. Different, same input, different outputs. No, it's not a function there. All right, f of x equals 4 times 2 to the x power. Find f of 3. F of 3 equals 4 times 2 cubed. Now, order of operation states you do exponents before multiplication. You don't do 4 times 2 first, you do 2 cubed first. 2 cubed is not 2 times 3. 2 cubed is 2 times 2 times 2. That's 8. So f of 3 equals 4 times 8. F of 3 is 32. That is function stuff. Skill number 7. Okay, skill number 8. Find the slope of the line in the equation y minus 14 equals negative 3 times x plus 1. Besides getting it in slope-intercept form, which you could do, remember this is point-slope form. Point-slope form does have your slope. It's right there. It is m equals negative 3 or negative 3 over 1. Not really any need to write that, but either or does apply. You get in slope-intercept form, it's still going to be negative 3. That's not going to change. Point-slope form still just reveals the slope right there for you. All right, question 2. Find the slope of the line that passes through the points 0, -6, and -3, 9. These are, again, the x1, y1, x2, y2 stuff, where your slope is y2 minus y1 over x2 minus x1. 9 minus -6 over -3 minus 0. And that is 9 plus 6 over -3, which is 15 over -3. Please reduce that to -5 over 1 or -5. Either or. Yeah, I'm calculating that fast. After we've done a couple of them like that, I definitely will. Skill number 9. Sketch the graph of y equals -4x plus 2. If you don't mind, I'm going to go ahead and use this graph right here. -4 is -4 over 1. And we get to fall 4. 1, 2, 3, 4. Go right 1. From 2. Fall 1, 2, 3, 4. Right 1. Rise 1, 2, 3, 4. Left 1. Draw the line with arrows. Don't mind if I do. And there it is. Write the equation of the line in slope-intercept form graph to the right. That's this other black one right there that I'm going to turn green. All right, slope-intercept form. Your y-intercept is -4. Your slope is a rise of 2 and a run of 3. That's a slope of, 2/3. That is y equals mx plus b. Y equals 2/3 x minus 4. Skill number 10. Find the range of the graph below. Now, range has to do with y values. This is, however, not a continuous relation. This is a discrete relation. Points are separate. We do not write it as an inequality. Yes, the lowest number may be -1, the highest number is 6, but it doesn't hit every point in between. It only hits specific values. It hits -1, 0, 1, 2, 3, and 6. For y values, that's all it hits. Now, how do you write that? You write it as a list, separated by commas. -1, 0, 1, 2, 3, and 6. I mentioned this a long time ago with mapping diagrams, by the way. If numbers repeated, if I had another point that was right here, I don't list 2 twice. I don't list 2 twice. 2 is only listed once in the range. It asks, does it exist? And in that case, it does. Okay, below is a graph showing Lake Superior's water level in meters as a function of time. As time goes on, these are years right here, and those heights. In which 2 years did Lake Superior reach its highest water levels? Now, the question can be a little ambiguous here. What I was intending to ask when I did was, where does it reach relative heights, or relative highs compared to the years around them? Meaning, reach a peak before it kind of lowers down as its highest highs. Like right here in this year, 1986. And in this year right here, 1997. That's what I intended as the answer, 1986 and 1997. However, I'm going to put an or right here. Or you could just say it as, in what 2 years do you just see them at their highest heights at the turn and start of those years? For example, 1986 and this one right here, 1985. Or 1985 and 1986. Because 1985 is higher than 1997. You see that? It is higher than it. So my intention for this question was really the first one. I'm really talking about that one right there. I guess this one still applies. But I'm talking about relative highs before it bottomed out. So, where are the best peaks with the years around it? Okay. Skill number 11. Provide a known point that the line for the equation y minus 1 equals 6 times x plus 4 passes through. Now, skill number 11 is all 3 forms of linear equations, not just slope-intercept form, but point-slope form and standard form. So I'm really hoping that people start to understand how point-slope form works, because that's exactly what this is. Point-slope form gives you the slope, and if you can read it right, a point. These 2 numbers help represent a point. Now, this is your x1 and your y1, but not directly. Remember, the equation is y minus y1. If it says y minus y1, then y1 equals 1. Not -1, but positive 1. x1, it's x minus x1, but this is x plus 4. How do you get a plus out of subtracting? By subtracting a negative. x1 is -4. You know a point that this graph crosses through? -4, 1. Your point-slope form actually reveals a point that it crosses through, right there. Now, what are some other points that it passes through? You could get this in slope-intercept form. You could distribute this and get 6x plus 24 equals y minus 1. Add 1 to both sides, you get y equals 6x plus 25. How does this help you? Because we know in slope-intercept form, it passes through the point 0, 25 right there. X is 0, y is 25. These are two distinct points it passes through. You know where else it passes through? Plug any x value into this equation or this equation and find the y value for it. Plug in 10. Plug in 10, 60 plus 25 is 85. You know what else passes through? 10, 85. There it passes. It passes through anything. My hope is you find the point slope form answer. I love if you rewrite and get slope intercept form knowing what it means. My hope is use point slope form for the reason that it is. It gives you a known point, and that's perfect for it. Okay, this next one. Rewrite y equals negative 1/2 x plus 8 in standard form, ax plus by equals c, where a, b, and c are all integers. Now, integers are whole numbers, which means this negative 1/2 x can't do. We're going to have to get rid of that fraction in some particular way. If it's dividing by 2, then let's multiply everything by 2 like this, and then the fraction will be gone. Y will become 2y. Hold on. Y will become 2y. Negative 1/2 x times 2 is negative 1, so negative 1x, or just negative x. And then 8 times 2 is 16. So I made everything 2 times bigger, no more fraction. I'm nearly in standard form. I have to get x and y in the same side of the equation, so let's add 1x to both sides, like that. And now I'm going to have an equation that says 1x, or x, plus 2y equals 16. So here's the standard form equivalent. Nothing we do very often, but it's more so I want you to know what standard form looks like, how it is to clear fractions, and just overall maneuverability. It still has its purpose. And there is the form. All right, skill number 12, solve system by graphing. We're going to do that quite often every time we have these. Let's go ahead and take a graph and do exactly that. So let's do it down below right there. Can you still see? Oh, yeah. All right, here we go. Y equals x minus 3. Now, x means a slope of 1. That's m equals 1 over 1. Negative 3 is the y-intercept there, so we'll rise 1, run 1 like this. Excuse me, I'm getting something in my eyes. I'm doing my doo-doos. My doo-doos. All right. We get that line right there. Oh, I thought I just turned it green, but apparently it didn't register. There it goes. All right, and let's do y equals negative 1/3 x plus 1. So 1 right here, down 1 right 3. I see where you're intersecting, sir. And up 1 left 3 like this. And let's draw that line as well. And fit it. Okay. So where do they intersect? You got to state. It's not enough to draw the lines. You got to state they intersect at 3, 0. There it is. All right, number 2, solve systems algebraically. Now, there's so many different ways I can do this, and unfortunately, I wish I just had 3 hours to just explain this one problem. I'm only going to look at a couple ways for this thing. Last time we solved a system algebraically, we solved using substitution, but that's because a variable was by itself. It said y equals blah, and I substituted for that. Now, it's not against you to take, say, this x and solve for it. Subtract 4y, divide by 2. Get x equals, substitute for x. Totally cool. I even recommend it in some instances here. This problem, we'll leave it. There's another method here called the elimination method, which is basically this. Line up your variables, line up your constant, line up your equal sign, and then add down your lists. Now, if I added right now, I get 4x plus 2y equals 18. That actually doesn't help me. The goal in the elimination method is to eliminate a variable, but I did add down the lists right there, which is something you're allowed to do. They will still operate within your same system. Now, what I can do is I can manipulate an equation so that when I do add down the lists, I end up eliminating a variable, such as, and there's so many different ways I can do this. I think there's so many possibilities, and I don't want to stop short and have you go, Mr. Robinson, I thought of another way. And like, great, I thought of it too. If I took the bottom equation and multiplied everything here by 2, what's going to happen here is this turns into 4x, this turns into negative 4y, and this turns into 12. And just kind of ignore this for a moment. Look at the top equation with bottom equation. What happens if I add now? 2x plus 4x is 6x. 4y minus 4y is 0. It eliminates. And now I have 12 plus 12, which is 24. I have now created one variable in one equation. Divide both sides by 6, you get x equals 4. No matter which way you solve this thing, and I'm not done, but no matter which way you solve this thing, you will always get x equals 4 if you do the math correctly. No matter which way you eliminate, do substitution or anything. I chose to eliminate y in doing so with that. Now, how do I solve for y with this? Well, ignoring all the stuff that I crossed everything out with, you can take an equation, such as this one here, substitute 4 for x, and then solve for y. See, we only tend to use the elimination method to eliminate one of the variables and solve for the other. Subtract 8 and divide by 4, you get y equals 1. We tend to not use it for the second one. We can tend to substitute after that. The elimination is for the first time through. If I did want to find y by eliminating x, I totally could. And let me just show you that last one, and then I'll move forward. But by the way, this answer here is 4, 1. That's where those two graphs would have intersected. So let me show you the alternative of not everything, just finding y by eliminating x, one of the alternatives. I consciously chose to multiply by 2 because I decided that with these signs being opposite, 2 times 2 is, negative 2 times 2 is indeed negative 4, and those would have eliminated. What if I made these opposite? What if I made this a positive, this is positive 2x? What if I made this a negative 2x? And you can't just make it negative. You can multiply by something to make it negative. How about negative 1? If I multiply top and bottom, or if I multiply left and right by negative 1, I'll get negative 2x plus 2y equals negative 6. Kind of ignore this equation for now. What's 2x minus 2x? Well, it's 0. It eliminates. 4y plus 2y is 6y, and 12 minus 6 is 6. Divide both sides by 6, you get y equals 1. You get the picture. You are going to get those regardless of what you do. You can choose to eliminate one variable to get the other in both instances, or eliminate to find one and then substitute for the other. You can also, of course, use the substitution method if you get a variable by itself and then substitute it for the other one. But that's all I'm going to do for that set, because that's quite a bit that I was talking about there. So, I'll leave that. It didn't reveal everything that I did, but it was quite enough. All right, I didn't mention the next skill here. This next skill is on what are called arithmetic sequences. Arithmetic sequences are sequences that contain what's called a common difference. A sequence is a list of numbers that follow some math pattern. In an arithmetic sequence, they feature what's called a common difference, which means you add or subtract the same number over and over. In this arithmetic sequence, you might notice that we go from negative 12 to negative 7 to negative 2 to 3. And because it's arithmetic as described, that means it's adding or subtracting the same number over and over. In this case, it's adding 5. Now, if you can't tell what it's adding, this is kind of a dumb example, because it's a hard example to say it with, but you can take one number and subtract the one before it. Negative 7 minus negative 12, which is negative 7 plus 12 is 5. Negative 2 minus negative 7, which is negative 2 plus 7, that's 5. 3 minus negative 2 is 3 plus 2, which is 5. They share that common difference. This is easier to explain if your numbers are 5, 10, 15, 20, 10 minus 5, 15 minus 10, 20 minus 15. Anyway, if we want to write the next three terms, if we want to continue the sequence, let's keep adding 5 from the previous term to get the next one. This is called a recursive algorithm when we keep adding 5 from the previous one. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. Cool. All right, find the value of the 51st term in the arithmetic sequence below. Now, this is also arithmetic. You might even recognize the common difference in this one. I'll tell you what we're not going to do. I'm not going to be adding my common difference over and over 51 times until I get there. I will do some version of that, but it's using a certain formula, and we're going to get into that. So that formula is this. It's going to look very funky, especially if it's your first time seeing it, but I hope that if you're looking at this stuff, then you have seen it before. I just got to kind of dummy check you. All right, so it looks like this here. This is called subscript notation. We've seen these before with x1, y1, x2, y2, but we use the value a. I want to try and speak shortly on this, so we'll try. A sub n is the value of some nth term, value of nth term. Pretty soon we're going to find the value of the 51st term, so I'm going to call this a sub 51 when we get there. We'll find the value of the 51st term. So a sub 1, therefore, is the value of the first term. We can tell what the value of the first term is in a sequence because it's clearly written. In this case, it's 5. A sub 1 in our problem is 5. We are going to be writing that in our explicit rule. That's what this is called. D represents common difference. How appropriate? D is your common difference. In this case, you might have recognized 8 minus 5, 11 minus 8, 14 minus 11 is 3. We're adding 3 each time. Your common difference is 3. And n represents the term position, the term that we're looking for. Here's what an explicit rule does. For the term position, we're looking for the 51st term. We can actually use that number 51 to compute our answer. And that's the cool part. But first we got to write out our rule. In our rule, we will be substituting for a sub 1 and d. So the rule itself is going to be a sub n, the value of any term n can be found by taking 5 and adding 3 n minus 1 times. Now, that's not our answer. We still have to do a sub 51, right? They're going to ask us for that. But this rule kind of makes sense. See, this rule says start from your first term and add 3 this many times. If I want to find the 51st term, I'm going to add 3, not 51 times, but 50 times. How come we're adding 3 50 times and not 51 times? Because we're starting from the first term. The first term is that one, 5. How far away is the 51st term from the first term? It's not 51 away, it's 50 away, right? That's what that n minus 1 is doing. I'm substituting 51 minus 1. I'm substituting 51 for n, subtracting 1, and then I'm adding 3 over and over 50 times. I mean, I'm going to do 3 times 50, but that's what we're doing. So are we literally adding 3 that many times? No, we are mathematically doing it. 5 plus 150 is 155. That is the value of the 51st term. And I skipped past what all the other terms were in the list to get that. I could find the 1000th term really fast just by doing that as well. I don't want CNN on my screen back there. I can find the 1000th term really fast by substituting. Give me a calculator. Or, well, actually, I don't need that. But, yeah, a sub 51 is 155, and that's it right there. All right, and that's some stuff on skill number 13, and that is week number 14 material. Okay, week number 15 material right here. We are going to simplify speedily fast. Negative 11x minus x is negative 12x. 6 minus 6 is 0. Those just cancel out. Listen, we're left with just negative 12x. If you write negative 12x plus 0, I guess it works. I'd really rather you didn't. 10 times 10x is 100x. 10 times 1 is 10. Those do not combine. You get 100x plus 10. That's skill number 1. Skill number 2 here, I got these equations. The left and right side are fully simplified as they are in this first question. If I add 2x over and subtract 3 over, I'm going to get 3x equals negative 12. Divide both sides by 3, I get x equals negative 4. On this one right here, if I multiply both sides by 2 to start with, I'll get x minus 5 simply on that side, and then I get 12 on there. If I add 5 over, I get x equals 17. You can see, after doing so many weeks of this stuff, I'm now just going to speed through a lot of these. Solve m plus a equals t minus h for t. It spells math. Solve for t. Literally just h is being subtracted. So let's add h over there, and t looks like it's going to equal m plus a plus h. Ma, or ham, or however you want to order those, as long as they're all being added. All right, let's solve for d in this right here. Now this looks like your explicit rule for an arithmetic sequence. Let's solve for d without distributing. Hint, don't distribute d. D is multiplying by n minus 1 though, and a sub 1 is being added. We got to start by subtracting that a sub 1. Get the d quantity by itself, and you get this. And then if I divide both sides by n minus 1 right there, that's what d equals. D equals, because the n minus 1's cancel, a sub n minus a sub 1 over n minus 1. It actually, for reasons that I understand, it actually is really close to the y2 minus y1 over x2 minus x1 stuff. It kind of has to do with rates. But that's the answer for D. That's the only answer I'd really like to look for there. All right, skill number 4. The difference of a number and 8 is 7. Our number is x. Let's subtract 8 from x, and that difference, 17, excuse me, is 17. Okay, a 30-ounce bucket is filled with x baseballs and y softballs. Baseballs weigh 5 ounces each, and softballs weigh 6.25 ounces each. Write an expression representing the total weight of the bucket filled with baseballs and softballs. Now, 30-ounce bucket, that's an empty bucket. That's not when it's filled with baseballs and softballs. I hope that makes sense. So the 30-ounce bucket, the bucket itself is already 30 ounces. Now let's add x baseballs that weigh 5 ounces each, And let's add Y softballs that weigh 6.25 ounces each. And that's how many ounces the bucket now weighs. That's it. All right, set up equations here. A swimming pool has 20,000 gallons of chlorinated water and drains 23 gallons a minute. How many minutes would it take for the pool to have 9,650 gallons of water left? So it starts with 20,000 gallons right here. And when we drain 23 a minute, drain 23 gallons a minute times the number of minutes. How many minutes? How many minutes is X? That's going to equal 9,650. You got to use some serious math here. Subtract 20,000. I don't want to be wrong. 10,350. I keep looking for my calculator. It's on my computer. 9650 minus 20,000. 10,000, negative 10,350. And then you divide both sides by negative 23. I mean, we should get a positive number, right? It's positive minutes that we're talking about. 450. So it's going to take 450 minutes for the pool to drain completely. That's 7.5 hours. I don't know if that's realistic or not. It's like, yeah, that sounds realistic, I guess. It's got to drain. That's a lot of poolage. 23 gallons a minute, though, man. A lot of gallons, a lot of poolage. I guess it's a big pool. In a biology class of 30 students, the number of girls is 3 more than twice the number of boys. How many boys are in the class? Okay, so for this right here, you have to understand that girls and boys combine to 30. A biology class of 30 students containing girls and boys. The number of girls is 3 more than twice the number of boys. So if there are B boys, boys is B, girls compares to boys in such a way, 3 more than twice the number of boys. Take twice the number of boys and 3 more than that. And then when you combine that, B plus 2B plus 3, we get 30 total students. How many boys? Let's solve for B. 3B plus 3 equals 30. 3B equals 27. Divide by 3, you get B equals 9. You have 9 boys in this biology class. Must mean there are 21 girls, which is 3 more than twice that number. All right. Solve by cross multiplying. 5 plus x over 3x equals 1 over 2. All right, 2 times that quantity there, 5 plus x, equals 3x times 1, which is just 3x. Distribute the 2, we get 10 plus 2x equals 3x. Subtract 2x over and you get x equals 10. That's it. And we've seen x equals 10 quite a bit. I bet you could flip a coin and get x equals 10 as your answer pretty much all half the time, and you just be right. Don't even show any work. I'm joking. Kayla can type 2,970 words in 45 minutes. How many words can she type in an hour? All right, 2,970 words per 45 minutes equals x words per 1 hour. Now, you don't want to say 1 hour because you are no longer corresponding proper units anymore. This is words and words. This is minutes and hours. You need this to be in minutes. So you need to know that 1 hour is 60 minutes. Now it's in proportion. I can cross multiply right here. 60 times 2970 is a lot. So 178,200 word minutes equals 45 times x. Divide by 45 here, and we're going to get x equals 3,960 words. Go, Kayla. How many words is that per minute? 2,970 divided by 45. 66 words per minute. Can you guys do 66 per minute? I always try and average over 100. It doesn't always happen, but I try. All right, is the below graph a function? Explain why or why not. Using the vertical line test, it seems to be a function. Sure, we repeat y's. Sure, we repeat x's with the same y's. Sure, x's give you the same y over and over sometimes, but we're never repeating y's for the same x. I always forget if I'm saying that correctly to you because I kind of say it out loud kind of fast. It passes the vertical line test. Yes, it passes the vertical line test. All right, f of x equals 4x minus 5. Find, f of 1/2. F of 1/2 equals 4 times 1/2 minus 5. I promised I wouldn't be this long. Half of 4 is 2, right? 4 times 1/2, 2. 2 minus 5 is negative 3. There it is. All right. Skill number 8. Find the slope of the line that passes through 1, 2 and 3, 10. That's your y2 minus y1 over x2 minus x1, which is 8 over 2, which is 4. You could also put 4 over 1, but I'll take 4 because I'm going to keep moving on. Find the slope of the line in the equation 6x plus 2y equals 13. Seen a couple of these. Let's get in slope-intercept form. And really, once again, it's one of those things. I'm going to divide everything by 2. Negative 6 over 2 is negative 3. I don't really care what that y-intercept is, 6.5, whatever. I just care that the slope there is negative 3, not negative 3x. Or negative 3 over 1 is fine, but negative 3. Divided everything by 2, slope-intercept form. You got it. Skill number 9, sketch that graph. Give me a second. There we go. All right, sketch the graph of y equals negative 1/2 x. Now, if you notice, it doesn't show the y-intercept. That must mean it's 0. Negative 1/2 x plus 0. So we're starting right there. Fall 1, run 2. Over and over and over again. Oh. And remember, negative means the negative slope goes this direction right here. Let's draw that line right there. Write the equation of the line in slope-intercept form with a slope of 4 and passes through the point 0, negative 11. Now, it's interesting because, slope-intercept form, y equals mx plus b. We need m, we need b. Now, I've shown you a lot of different things, and I'm going to keep it short this time. If you want to find other methods, you can. Your slope is 4. They tell you that. We mention all the time, b is your y-intercept. The value of y when x equals 0. Guys, that is your y-intercept. B is negative 11. A little tricky in that I'm saving you from doing work if you notice that. If you notice it, that is your y-intercept. Your y-intercept is not always just the y value, but when x equals 0, it is. Now, yes, what could you do? You could use point slope form, plug in that for x1, y1. You can use slope-intercept form, plug in for xy, solve for b, but you will get negative 11 if you do the math correctly. Your equation, you still got to write, is y equals 4x minus 11. I'm going to stop it right there. That's all. If you look at it, if you look at it on a graph, even though it's out of window range, it's right there, up 4 over 1, up 4 over 1. That's where it crosses the y-axis. That is it. So it's a pretty easy problem to do if you know what to do with it. Otherwise, use the other methods we've used in the past there. All right, skill number 10, find the domain and the range of the graph below. Now, in this particular graph, you see arrows, and the arrows means it goes down forever. Not just down forever, but down and left forever, down and right forever. Sure, it goes more sharply down than it does right, but make no mistake, it goes right forever. It goes right and left forever. So domain, what happens when a graph goes left and right forever is continuous and continual. Your domain is all real numbers. There is no x value that this graph does not hit. You might say, what about 5? Yeah, you go down there, you will find that it hits 5. What about 100? You go down low enough, it will. That's your domain. Your range is limited, however. It may go down forever, but it doesn't go up forever. In fact, the highest it hits is 3, and it does hit 3. 3 counts. So the way that we say that, not as a compound inequality, but just a single inequality, we just say y is less than or equal to 3, like that. There's our domain, there's our range. All right, the second question here on skill number 10 has kind of a matching thing. And there are a couple ways that we do this here. I'm not going to do this whole A1, B2, C3. I'm just going to write the letter that matches the graph. Let's read the situations and see if we can find them. Mary leaves the house, walks to the store, and returns with groceries. So all of them seem to leave the house right there. That's no different. Walks to the store. So you're going to be in the store for a while. Returns with groceries. You must have been perusing the store for a little bit. I don't think the store is going to have you be walking further away from home the whole time to the register and somehow returning home like that. I think 2 is out for A. 1 and 3 are still in place there, but 1, how big is the store that you're gradually getting so much closer to home and so much further from home back and forth like that? Whereas opposed to here, you're kind of perusing the store a little back and forth, a little bit of walking. Store's not too big. How far from home are you? It's kind of the same distance. Looks like 3 is A right there. And we'll talk about other situations if we have to, see if we can match it up. But process of elimination right now, I want to try and eliminate 3 with A. Roger walks around the block. Now, I'm not going to explain this one in full, but I'm going to first say it's going to be B. As far as walking around the block goes, think of a block as in, here's you at home. You walk this way, you turn this way, turn that way, and that way. So picture this. Here's home. I'm walking from it. Am I going farther from home? Yes. I turn the corner, walk around the block. Am I going farther from home? Yes. This distance here is farther than this distance right here. Is it considerably farther? No. Here I'm getting closer to home, considerably closer. Here I'm getting obviously very close. I'm getting to home, but not as fast as a distance as I was in the other direction there. So in that B scenario, I'm distancing myself from home. I turn the corner. I'm getting not considerably farther from home. I'm turning the corner, and I am getting farther from home, less significantly than before, but I am. And then as I turn that other corner, I get a lot closer to home with that one, and then I just get closer to home at the end, turn the last corner. So yeah, it's going to be B in that scenario right there. Sylvia runs to the track, takes a few laps, and runs home. Now, this one is going to be C right here because a track is bigger than a grocery store, and you're running a lot faster to make it happen. The track isn't an up and down thing. The track is a loop, but the loop has you going further from home, closer to home, further from home, closer to home as time goes on. Remember, time just keeps moving that way. So you're going further from home, closer to home, further from home, closer to home, around a track. A Ferris wheel would have the same kind of up, down, like that, just going up and down it, even though the Ferris wheel is a circle, because time is moving forward. Anyway, C, B, A. All right, skill 11. Find the x and y intercepts in this equation right here. Answer as x, 0, and 0y. In standard form for this equation right here, the x-intercept is when y equals 0. 2x equals 10. Divided by 2, we get x equals 5. So that answer will be 5, 0. Y-intercept is when x equals 0. Substitute 0 for x. We get 5y equals 10. Divide by 5, you get y equals 2. That is a y-intercept of 0, 2 right there. And those are your two intercepts. Skill number 12. Skill number 11, number 2. State whether each equation is in slope-intercept form, point-slope form, standard form, or none. So this first one is point-slope form. That's your y minus y1 equals m times x minus x1. This one here, this is nothing. It almost looks like standard form, but standard form needs x and y on the same side of the equation. ax plus by equals c. If the equation said 4x plus 8y equals negative 1, that's standard form. This one, however, is not. And yeah, standard form would have no fractions either. Not to say that point-slope form and slope-intercept form can't have no fractions, but standard form absolutely can't. It's still a none. This one is slope-intercept form, y equals mx plus b. There was no true standard form on this one, or so it seems. And those were our three answers there. All right, skill number 12. Solve the below system of equations by graphing. Let's pull up a graph. And just kind of put it right here. I might have to erase it later or just move it right on to that one. Move it upward. Y equals negative 4. That's y equals 0x minus 4. Remember, y equals equations are horizontal lines. This crosses at negative 4, and it goes flat horizontally across that negative 4. Hold on, I'm trying to set up my arrows. It goes across this way. That is y equals negative 4. I'll tell you something else about it in a sec after this next one. Y equals negative 2x plus 2 right here. Start at 2, go down 2, right 1, like this, and this, over and over. Where do they intersect? Well, I'll tell you in a second. Calm yourself, I'm trying to graph. I can't tell you two things at once. All right, where do they intersect? Well, they intersect right here at x equals 3, y is negative 4, at 3, negative 4. Now, if there's one hint that can give away the whole, even if you can't graph y equals negative 4, which I'll give you many reasons, I've given you many reasons as to how you can figure out what it is. Know this, y equals negative 4. Where do you think the line, what value of y do you think that the line y equals negative 4 intersects with another line? I think the y value is going to be negative 4. So if you had it intersect at any other y value that wasn't negative 4, something went wrong. What's the kind of line that's going to have y equals negative 4 hit? One where y always equals negative 4. I mean, that's where the obviousness can really help you. All right, solve the below system of equations algebraically right here. I'd like to use substitution method again for this. Y is by itself with x inside of it right there. If I substitute 2x minus 1 for y, I can have an equation that has only x's in it. Where it says 3x minus, now you got to be careful here. You're going to use substitution, so you're going to use parentheses around this thing. Do you always have to use parentheses? No, but I recommend it. because now that it's subtraction, you have to distribute that negative. We haven't seen distribution of negative in a while. That's going to be 3x minus 2x plus 1 equals 6. 3x minus 2x is x. And subtract 1, you get x equals 5. So that is the x value. Now the y value is 2 times 5 minus 1. 10 minus 1 is 9. So your ordered pair is 5, comma 9. That is the x, y solution set for that thing, 5, comma 9. Okay, scale 13 is being crowded and covered by this graph, so let's just move it over. Oh, it kind of stayed behind. That's nice. All right, write the explicit rule for the arithmetic sequence here. 10, 18, 26, 34, etc. Our goal for explicit rule is, our formula for explicit rule is this. Our objective for this is find the first term and the common difference and just plug them right into there. That's it. Your first term is 10. Your common difference is 8. 10 plus 8 times n minus 1. That is the explicit rule. They didn't ask us for a specific term, but that is the explicit rule right there. Now on number 2, you're given an explicit rule, and then you're being asked to write the first 4 terms from it. So you have 2 options in doing this. One I prefer over the other. Option 1, which I do not prefer, and I will not do it for them, you substitute 1 for n and compute what that is. You substitute 2 for n and you compute what that is. You do it for a sub 1, a sub 2, a sub 3, and a sub 4. My second option is this. Go exactly opposite of what we just did from the previous problem. If you know how this rule works, then you should know that a sub 1 is negative 4 and d is negative 7. That your first term in your sequence is negative 4, and if you knew your common difference was negative 7, your next 3 terms you do minus 7, minus 7, minus 7, and you got it. Now you may do this other thing that I offered, but an explicit rule is better for a one-shot thing for a number that's farther away, even for the 9th term or something like that. I'd rather use the explicit rule for that, plug in 9. But for the first 4 terms, no. You have the first term, you have the common difference, use them. All right, scale 14, this was the new one. I keep forgetting to mention what the new one is, and this is there's 15 total scales and everything, so there's kind of one more quiz to talk about after this. Sorry, my neck. Scale number 14 here, we're going to solve the inequality right here and graph its solution on a number line. Now, I'm going to have to draw its own number line, but this inequality, you treat inequalities like you do equations. You try and get x by itself. 8 times x plus 1 is less, quantity x plus 1 is less than or equal to 88. You know, we could distribute. I can do 8x plus 8 is less than or equal to 88. Subtract 8 from both sides, you get 8x is less than or equal to 80. Divide both sides by 8, you get x is less than or equal to 10. You know, we're trying to find the values of x that can apply to this set right here. What values of x would make this thing true? And any x that's 10 or less would actually work. I could plug in 9 into this, it would work. I could plug in 0, it would work. And I can even test it with 0 and kind of show you that it works. So graph on a number line. Not that number line above. That's for another problem. This number line here, I'm only going to do so much. I'm going to show you where 0 is. I'm going to show you where 10 is. We've talked about closed circles for points that count. 10 does count. It's called our boundary point. And we are going to graph this to the left. These are values that are less than 10 or equal to 10 when we're talking about the boundary point itself. See, 0 would work for this. Check this out. 0 plus 1 is 1. 8 times 1 is definitely less than or equal to 88. That is a true statement right there. Sorry for my sloppy writing. That is very much true. Anything larger than 10 won't work there. And I always like to double check with 0, not for myself, for my students, for reasons that you will mess up. Graphing the wrong direction. Sometimes you have to flip an inequality, not right now, but you know that's one of the things. And by the way, this solution, that you need this and the graph. All right, the next one, write the compound inequality that describes the below graph. So right here, we've done compound inequalities kind of a few times before. X is between this and that, and that's what's happening here. X is between negative 3 and 0. It goes like, here's negative 3, here's x, here's 0. If you notice 0 has an open circle on it, that means 0 does not count. Negative 3 has a closed circle on it, therefore negative 3 does count. X is in between. Inequalities face this way. Always, when you're talking about compound inequalities, there's a version of the answer. Another version of the answer is you can use the word and. You can say x is greater than or equal to negative 3 and x is less than 0. And it's important to use and in a situation like this where the 2 points come together. There's nothing, I have to satisfy both at the same time. It's not going opposite directions, which we can see problems like that. But these ones are going in between like that, and that would be an and case. Okay. That is it for that week's skills. Week 15. Okay, week number 16. Let's go ahead and do skills. Skill number 15, let me just call it out right now. Skill number 15 is going to be systems of inequalities, where there's graphing and shading, and those, they kind of look like things like this right here. Not the hardest of questions that's going to be asked on this one, but I'll talk about what this was actually also doing at the same time. Okay, but let's start from the beginning here. Simplify 3x plus 3 minus 2x plus 5. 3x minus 2x is x. 3 plus 5 is 8. You get x plus 8. 3 times 2x and 3 times 1 is 6x plus 3 minus 2x. That's 4x plus 3. Looking so good. After 16 weeks, I hope this looks good. Add 3 to both sides, you get 7x equals 14. Divide both sides by 7, you get x equals 2. Or are the problems getting easier? They actually might be. 3x, because it looks easier to me too. 3x plus 2x is 5x. Plus 1 equals 6. Subtract 1. Divide by 5. You get x equals 1. Solve AC equals DC for A. Divide both sides by C. You know what, though? It cancels on both sides. A equals D. A and D are the same thing. Solve for x right here. Now, there's a negative x right now. I'm going to try something a little different. This time, instead of getting x by itself, I mean, I will, but I'm going to put x on this side of the equation. Let's make it positive. I'd prefer that. I still have y minus k over here. Now, I'm going to subtract u over, not u, but the letter u. And I'll get x equals y minus k minus u. Any answer like this is fine in terms of order as long as y is positive, k is negative, u is negative, and they are adding together. Like that. Skill number 6 is down here because skills 4 and 5 are up here. Skill number 4, translate the following. 1 less than quadruple a number. You quadruple a number, you're multiplying it by 4. 1 less than that is 4x minus 1. I'm thinking of a number between 1 and 100 inclusive. First of all, thinking of a number, it's some unknown. What is that number? It's somewhere between 1 and 100. Here's 1, here's 100. Now, inclusive means we include 1 and we include 100, like that. There's thinking of a number. What is the number? 62? I don't know what it is, but all I'm saying is, just that's the situation. I don't want you to call, 4. It's just a sentence. Like fans at a stadium at most 55,000. All right, this first one here. Regal Cinemas offers a monthly subscription pass for $22 plus 50 cents for every movie watched. That's pretty accurate. Alternatively, DirecTV On Demand shows the same movies for $6 per rental. After how many movies would both payment options cost the same amount? So if you decide to watch movies strictly with Regal, then you would pay $22 up front, and then you would pay 50 cents for every movie that you watch. You multiply that, so after how many movies? That's our X. 50 cents per movie times X movies. Now, when does that cost equal the same thing as renting $6 per movie times the number of movies? That's the question. We can subtract 0.50x from both sides, if you want to say it that way, and you get 550x. We divide both sides by 550. That means 5.5. Divide by 5.5 right there. And you get x equals 4. 4 movies. After 4 movies, you spend the same amount. Would you rather see them in theaters or at home? Movie theater. Come on. Support the movies. Support the cinemas. What would be the cost for that many movies watched? Okay. It's the same cost no matter which option you choose. So let's do the one that's easier to calculate with. Rent 4 movies for $6 per movie. 6 times 4 equals 24. Remember, you spend the same amount with Regal. 50 cents per movie times 4 movies is $2. 2 plus 22 is 24 as well. Spend $24 for 4 movies. Good option either way. It's better than like $15 per movie at Regal. Okay. Provide exact answer as a reduced fraction here. Now, me giving the hint means what I'm looking for, but also the fact you can expect a fraction. If I cross multiply right now, I'm going to get 12 times x equals 3 times 6, which is 18. Now, when you divide both sides by 12 right now, that is a fraction. I do not want 1.5, which is an exact answer. I want a reduced fraction. Divide top and bottom by 6, you get 3 over 2. X equals 3 over 2. Hulu runs 2 minutes of advertisements for every 11 minutes of a program. How many minutes of advertisements would Hulu run after you binge watch 176 minutes of a program? So if you run 2-minute ad for 11-minute program, this is skill number 6, proportions, that equals how many minutes of ad for 176 minutes of program? If you cross multiply there, you're going to get 352. 352 equals 11x. Divide both sides by 11. Pardon me for my inability to do this after almost 4.5 hours of this. 352 divided by 11 is 32. X equals 32 minutes of advertising. Hope you have a lot of bathroom trips and things you'd want to do during those times. Hope you have people you can talk to. All right, skill number 7. Here's a mapping diagram. Does this mapping diagram represent a function? Yes or no? Explain why or why not. As long as every element in the domain only maps to one element in the range, it's a function. Doesn't matter that multiple go to different elements, same element in the range. That's fine. There's no splitting arrows here. Yes, this is a function. You never have repeat x's. Not in the list, but like -3, 5 and -3, 0. We don't have repeat x's in that way. Yes, it's a function. All right, f of x equals -3x minus 11. Find f of -10. That's -3 times -10 minus 11, which is 30 minus 11, which is 19. 19, folks. Looking good. All right, skill number 8. Find the slope of the line that passes through 0, 2, and 3, 10. I had another question like this last time that was pretty close. Slope, I got to make them harder again. 10 minus 2, y2 minus y1, over 3 minus 0, x2 minus x1. That's 8/3. 8/3. No better than that. Find the slope of the line graph below. From this point to this point, it falls 1, and it runs, that's a -1, and it runs 1, 2, 3, 4, 5, 6, 7, 8. It runs 8. That slope is -1 over 8. That's just on slopes. Skill number 9, sketch the graph of y equals 5/3 x plus 4. Let me steal a graph. Can you see it? Yes, I think you can. Y equals 5/3 x plus 4. So 4 right there, up 5 over 3, down 5, left 3, down 5, left 3. That's pretty much all that I can fit personally, so I'm going to go and do that. I think I gave my students smaller axes to graph with, so I'm sure they couldn't even fit any up to the right, so you automatically go down to the left. It's still a positive slope. Write the equation of the line in slope-intercept form that passes through the points 4, 3, and -1, 3. All right, some interesting points. I want to show you this visually. Here's 4, 3, and here's -1, 3, just in green. Look at what it's doing. It's a horizontal line. That's a slope of 0. Now I will show you all that's left with that. And they both have a height of 3, which means so will the y-intercept. That means the y-intercept is 3. There are fast means of this. You didn't have to draw the graph, but you can visualize what's happening. It's a flat line. It's not going to change y. So the slope is 0, and the answer is y equals 3, or y equals 0x plus 3 if you want true slope-intercept form. I would take either like that. I'm sure that you want to look at something else with that, which is like y2 minus y1 over x2 minus x1, which is 0 over -5, which is 0. We still get to that. Once again, you can substitute this xy into point slope form or slope intercept form, or this xy into point slope form or slope intercept form. You'll get a b of 3, or you'll get a y-intercept of 3 there as well. And that's what it is. That's what it is. Kind of, it's not meant to trick. It's meant to, I'm not sure what the word is. It's meant to reward those who understand what's going on logically by going faster by it, but you shouldn't get it wrong with the information there. All right. Tyrone left his house and drove to the store. He stopped and went inside. From there, he drove in the same direction until he got to the bank. And went inside. Sorry, until he stopped and went inside the bank. Then he drove home. Whee! These are blocks, by the way, not miles. He didn't speed home. The graph shows the Y number of blocks away from home Tyrone is X minutes after he left his house until he got back home. How long was Tyrone at the bank? The bank is right here. We go from minute 13 to minute 19. 19 minus 13 equals 6. He was there for 6 minutes. How many blocks is it from the store to the bank? The store to the bank, from block 9 to block 15. 15 minus 9 equals 6. 6 blocks. Kind of easier questions rather than domain range stuff. Generally, I wouldn't ask those. All right, skill 11. Write an equation of the line that passes through 1, 1, and 3, 7. So I didn't stress slope-intercept form. That's not a requirement. In fact, I prefer point-slope form. I'll show you what the slope-intercept form answer is, though. We do need the slope first. M is y2 minus y1 over x2 minus x1, which is 6 over 2, which is 3. Now, my two favorite answers are either y minus y1 equals m times x minus x1, or if I use this one, it would be y minus y1 equals m times x minus x1. This or this are two great answers you can use. Of course, if you'd like slope-intercept form, you can do whatever you'd like to get into slope-intercept form. Among them is you can take either of these equations, like this top one, distribute 3 into it, and then add 1 to both sides, and you get y equals 3x minus 2. That's also a third answer you can get. Yes, if I distribute 3 into this one, I get the same thing. 3x minus 9, add 7, you get 3x minus 2. 3x minus 2. So any of these 3 answers are good. All right, is 4-1 a solution to the equation 5x minus 2y equals 18? Explain why or why not. All right, solutions are when you substitute xy into your equation that the left side equals the right side. Does 5 times 4 minus 2 times 1 equal 18? That's 20 minus 2 equals 18. 18 equals 18. Yes. I'd say explain why. The math shows it. The math is the explanation. That's good enough. All right, skill number 12. Solve by graphing. So we are going to graph these two equations. We're going to find out where they intersect. The points of intersection should be sound. Hopefully no one ever gives you solve by graphing equation. Maybe if it's at a halfway mark, but hopefully otherwise they don't give you graphs where they're not landing on integers or they're landing outside your window range. So if they're doing something like that, expect that you graphed it wrong. I'm just going to say that. Okay. Negative 1/2 x plus 4. I feel like I've graphed negative 1/2 x a lot. Negative 1/2 x, maybe negative 1/2 x plus 4. Negative 1/2 x plus 4. Or y equals. It's a big black line. Okay. And then y equals 4x minus 5. Yep, see, they should cross right there. That's up 4 over 1, and down 4, left 1. All right, where are they intersecting? At 2, 3, it looks like. I mean, not it looks like. Those were actually the same points for both of them. Just make sure I counted that correctly. Looks good. Point of intersection right there. All right, solve the below system of equations algebraically. Now you have different options here. I've kind of mentioned them before. I'm probably going to use the elimination method here, but I want to emphasize that if you wanted to use the substitution method, you could get a variable by itself, like maybe like this x right here. If I added 5y to both sides, you get x equals 5y plus 10. and then you can take 5y plus 10 and substitute it for x in that equation. I really love that method. It's fine. I haven't done elimination in a while for this, so I want to show you this one. So for the elimination method, once again, if I add down these lists right now, no variable eliminates. But if I multiply one of the equations here by -1, that'll change this x into a negative x, and minus 2y equals positive 4, and x minus x is now 0. Those eliminate. Negative 5y minus 2y is negative 7y. 10 plus 4 is 14. Negative 7y equals 14, therefore y equals negative 2. If I want to solve for x, I got to use one of my equations, one of the ones I kind of blurred out here. Let's look at that top one. And I have x minus 5 times negative 2 equals 10. Sorry for the room, just follow the colors. So that's x plus 10 equals 10. Subtract 10 from both sides, you get x equals 0, actually. So that ordered pair is 0, negative 2. Yes, x equals 0. You could have used any other way, including that substitution. See that you get x equals 0 and y equals negative 2. It should work. All right, skill number 13. Sequences. Is the below sequence arithmetic? Explain why or why not. Now the numbers are a little obscure, and I wouldn't test numbers and see if it works. What you seek for in the difference is subtract one number from the one before it. What is 58.2 minus 80? What is 36.4 minus 58.2? What is 14.6 minus 36.4? The one number minus the one before it will show you, it will reveal your common difference. And these are all negative 21.8. That means we are subtracting 21.8 every single time. That means it has a common difference. Negative 21.8, therefore it is arithmetic. Yes. What is the value of the 100th term in the below sequence? Okay, for that we need to write this in that form. We need a sub 1. Value the first term, which is negative 30. Common difference, be careful, it's adding. It's plus 4 right there each time. It's a positive 4. Okay, so our rule is a sub n equals negative 30 plus 4 times n minus 1. The 100th terms means we have to substitute 100 in for n right here. So we'll do plus 4 times 100 minus 1 is 99. Now 4 times 99 is 396. It's 4 less than 4 times 100. So negative 30 plus 396, which is 366. Yes, it grew positive. Over time, that makes sense that it grew positive and kind of large. All right, 366. Okay, 2 more skills and then all done. Solve the inequality and graph its solution on a number line. So I have negative 3x is less than or equal to 6. If I divide both sides by negative 3, here I get x and here I get negative 2. Now the trick for inequalities is anytime you multiply or divide both sides by a negative value, the inequality actually flips. Oh, you can't see this, I'm sorry. The inequality actually flips over. Notice that this was a less than or equal to. Now it's a greater than or equal to. It's not a magic trick. There is a reason for it, and the reason for it is, and I gotta have to probably do all this down below as far as graphing. The reason for it is large positive numbers are larger than small positive numbers. But large negative numbers, sorry, did I say that right? Large positive numbers are larger than small positive numbers. But large negative numbers are smaller than small negative numbers. Negative numbers that are closer to 0 are greater than. Negative 2 is greater than negative 100, whereas 2 is less than 100. So when you divide by a negative, you're switching and leapfrogging their position in that totem thing. That's kind of what treats it. You need larger numbers of negative 2, like negative 1, 0, 1, 2, 3, that when I multiply by those, they'll still stay underneath 6, because then they turn small or negative, and that stays underneath 6 when we do that. Now graph it on a number line right here. I'm going to make a quick one. That is 0's right here, negative 2 is right here. If x is greater than or equal to, we're going to have a solid line. We're going to graph to the right. Now I love to double check these ones and make sure, did I do it correctly? See, if I plug in 0 here, I expect that I get a true statement. Is 0 less than or equal to 6? Yeah. If I graphed it to the left, I would say 0 is less than or equal to 6 is true, but I would have expected a false statement because 0 would have not fallen on my number line, but here it does. So we're good. All right, right here. Solve the compound inequality and graph its solution on a number line. 5 is less than x plus 7, which is less than or equal to 11. Now, in a compound inequality, I have to solve for x, so I am going to subtract 7. But there are kind of three sides to this thing. Here's the middle side, and then there's a right side and a left side. You got to subtract 7 from all of these guys right here. So 5 minus 7 is negative 2. X is right here, and that's a 4. That's the solution. Graphing it on a number line, which I can do right here, I want to put 0 in its place. Here's negative 2 and 4. Now x is between negative 2 and 4, and as you can tell, negative 2 does not included there, so it's an open circle, and 4 is included there, closed circle. And x is everything in between, including 0. You can try it, but it's everything in between like that. That's how that thing pans out. No arrows. It's only in between those two. All right, last one, this new skill, sketch the graph of. So graphing an inequality, graphing a linear inequality, I should say, is done by kind of same stuff as you've done in the past. You can use slope-intercept form to graph, only now it's not just about the boundary line. It's about a little bit more than that. There's also like a shaded region that we'll talk about. Remember, lines themselves, whenever we graph these represent solutions to the thing. I plug them into my equation, left side equals right side. Any point on the line works. These inequalities of greater than and less than and things like that, they have more to do with, well, let me get y by itself. Y is greater than negative 2x plus 5. This has more to do with a whole region of values that as long as y is greater than it, this based on this x, it works out. Now let's first start by graphing that. Negative 2x is down to right 1, like this, from 5 and up to left 1. Now, when I graph this thing, see, it says y is greater than, and we've mentioned open circles, closed circles. An open circle is when something's not included. We can't make an open circle line, but we can make a dotted line. A dotted line is our way of saying that points on the line do not qualify as solutions of. Now, you can do something like test a point to see what works. You remember when I was testing 0 on these right here? I could test 0, 0, 0 for x and 0 for y in this inequality, or this one right here. 2 times 0 plus 0 is 0. Is 0 greater than 5? No. That means that 0 is not a solution to this thing. Neither is anything else on this side of the line. All these points right here, however, are solutions to this inequality. Meaning I could substitute 3, 6 in this thing, and 6 plus 6 is greater than 5, right? That'll work. Anything on that side of the line will work. Points on the line will not, because it's a dotted line. It doesn't count. And points underneath the line will not, but points above it will work. Now there's another neat trick besides testing points. It's that if you do have slope-intercept form, if y is indeed by itself, if y is greater than, then you get to shade above the line. If y is less than, you would shade below the line. This was shaded above as y was greater than. But you need y by itself in order to do that. Otherwise, you're not comparing properly with it. All right, and the last question here. Look at the system graph to the right. Is 3, 5 a solution to the system? Explain why or why not. Now, the only trickery really for me on this is don't just go 1, 2, 3, 1, 2, 3, 4, 5, because guess what? That ain't 3, 5. That's 6, 10. Look at the scales. 3, 5 is right here. Here's 2, 4. Here's 3. And here's 2, 4, 5. That's 3, 5 right there. Now, 3, 5 is a solution to the system. First of all, a system of inequalities is when you're graphing two inequalities together. Let me make up another one down here. It's where you're graphing two inequalities, and then you have this overlapping shaded region. If I made up this line right here, and if I shaded, say, below the line, say like this right here, boom. Notice the overlapping shaded region that's right in here. That ends up being a solution to your system. Now, you can erase the other parts if you want to on that, because only this red counts as it, whatever is shaded for both of them. This is what you're seeing right now, the overlapping shaded region of, I guess, underneath this line, but above that line right there. 3, 5 happens to be in that overlapping shaded region. So I don't know what those, I could come up with what those are if I find the slope and y-intercept. But 3, 5 happens to satisfy both inequalities at the same time. Yes, it's in the overlapping shaded region. So yes, 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 it absolutely is. There's a lot more I could say on that, and I feel bad that there are only 2 questions on that particular skill. for now that you could look at. I'm sure I have other videos that I talk about systems of inequalities and things like that, but that's the only one that I have here for you. I'd love to graph a system of inequalities in full with you, but you know what? Time was against me on this one. But hey, you know what? That ought to do it for this one. And I am checked out. I said it wouldn't take this long, but you know what? This camera moved a lot here. But you know what? It took as long as it had to. I wanted to explain some things. It didn't go as fast as I would have liked to. If I did it all on my own, yeah, maybe I'd do it in like an hour or 10 or something like that. But no. All right, guys. Take care. Thank you. And I hope that this paid off.